Dell Technologies, Inference Solutions, Anaconda, Conversica, Samba Nova, Xilinx, Globant, Oppen, Cognicore, Fiddler.ai, Percepti Labs, and Vision Elements. Thank you so much for helping make VB Transform possible. And now I want to let you know, if you guys haven't already been joining our conversation on social media, we would love for you to jump in. I know it's the last day, but it's better late than never, everybody. So we have that awesome hashtag that you've seen across all of our content so far this week. That's hashtag VB Transform. That helps you guys find other people who are attending the conference and join those conversations on social media. So please do use that when you join the conversation. And of course, our marketing folks want to get those sweet, sweet analytics. We're all about data here at VB Transform, right? And we have a full program of amazing speakers coming up, because I know you're like, all right, Andrea, I think we're done listening to you talk. And it's interactive, so please do get your questions in. I know that the speakers have been really excited to have that dialogue with all of the attendees. If you guys didn't already enjoy the opportunities that you have on Slack, that is where you ask those questions. And of course, we'll do our best to get through as many of those questions as possible throughout the day. And for those of you who registered for online access and VIP passes, we encourage you to take advantage of the many networking opportunities available, such as the breakout sessions for speaker Q&A, virtual roundtables, and of course, those discussion channels in Slack. All right, everybody, we are almost to the end of my housekeeping announcements here at the top of the day. I do want to let you guys know that it's the last day of our Expo booth contest. If you visit at least 5 Expo booths by entering the virtual booth, not just enter and view the booth, got to make that disclaimer, and you talk with our partners, your name will be entered into a drawing to win $1,000 plus 2 comped tickets to our next Transform event. We'll be announcing the winner at the end of Transform. And again, please note that to talk in the virtual booth expo, you need to click on the broadcast button. And if you can't find it, just expand your screen. We promise you it's there. And I do want to tell you a little bit about what's happening over on the Slack channel. If you guys haven't really taken advantage of that, it's a great place to introduce yourself. Let the community of people here at VB Transform this year know who you are, what part of AI you're working on, what you're doing now, and hopefully you'll be able to meet some other people who can have some interesting conversations with you. Oh, I forgot to mention, you can also send video clips. So if you're feeling up for it, I'm sure some people would like to see some friendly faces. We're all a little bit lonely in quarantine, I think. All right, you guys, I am almost done with my part of the opening. And now I think what I would like to do is pass things off to the founder and principal analyst of Lopez Research, Maribel Lopez.
Good morning, and welcome to VentureBeat Transform. I'm Maribel Lopez, the founder of Lopez Research. I feel as though we start every conference with, we live in unprecedented times. And it's true, we do live in unprecedented times. And organizational leaders are trying to figure out how we survive and how we return to a positive trajectory as businesses and as societies. And when I was last at a VentureBeat conference, I talked about the need for organizations to build right time experiences, which is delivering the right information to the right person at the right time on their device of choice. And we were going to use mobile, cloud computing, and big data and analytics to do this. But that set of technologies didn't quite take us far enough. Now, today, we have a new opportunity where we are leveraging 5G, IoT, and something called edge computing, where we're taking the concepts of data centers and bringing it closer to where the data is generated. And we have the opportunity to evolve from what was known as analytics to using artificial intelligence and artificial intelligence at the edge to create new insights and automation. And this is going to allow us to create a whole new set of right time experiences that will transform industries such as healthcare, retail, factory automation. And you're going to hear about these use cases today, sessions, and our panels. Now, no one can predict the future, but we can create it. And I hope that through these sessions, you will find the insight to do so. Thank you, and have a wonderful VB Transform.
Thanks so much for those opening remarks, Maribel. And she is going to be back in our first conversation of the day. The fireside chat is titled Bringing the Power of the Data Center to IoT and Edge AI. Joining Maribel is Deepu Talla, the Vice President and General Manager of Embedded Edge Computing at NVIDIA. Enjoy.
Hello, I'm Maribel Lopez, the founder of Lopez Research, and I'm really excited to be here today with Deepu Talla of NVIDIA. Hello, Deepu.
Maribel, how are you? Glad to be here today.
Great. So we're here to talk about the edge, and there are so many definitions of edge computing. It goes from everything from what could be considered the last mile telco data center all the way down to a smartphone or a self-driving car, and there are spots in between. So with such a wide definition of the edge, and with so much change that's happened in artificial intelligence, what are you seeing as the requirements for an edge computing stack today?
Yeah, sure. So we've in the last 3 years, we've seen industries such as manufacturing, retail, healthcare, transportation, and many others infusing the technology with artificial intelligence, primarily for efficiency improvements and productivity improvements, right? And it turns out that majority of that AI today is being done in the cloud. Now we're starting to see the trend of that computing moving from being exclusively in the cloud to also running at the edge. And we talk about edge AI, which is essentially the fusion of artificial intelligence and IoT. Most people associate that with AI running on the device, for example, a phone or in a robot or in a car. And of course, that is happening for sure. But also turns out there's another big use case, which is bringing the capability of the cloud or the data center close to the edge, at or near the device. So that essentially is what's really transforming many different industries today.
I love the way you put that, because I think that is the real difference, is pulling the data center closer to where the data is being generated and being able to do some analysis on that real time, maybe not ship all that data back to the cloud, as you mentioned. So that requires a lot of things. It requires some changes in thinking about what we might have had as cloud center computing with GPUs to maybe a different style of GPU. It might even have some changes in how we think about networking. How do you at NVIDIA see those changes?
Mm-hmm. So if you think about why do you want to move computing from just being in the cloud to also at the edge, there are 3 top reasons, right? The first one is cost. The second reason is latency. And then the third reason is that there's some privacy and regulations in some industries where they don't want to send data to a public cloud. Now why do we actually in the first place send data to the cloud? Because as you know, much of the intelligence that we derive today happens from the fusion of many different sensor technologies, whether it's cameras, whether it is audio sensors, whether it is LiDAR, radar, and so on and so forth. So as you have all of these sensors that are constantly generating data, we have hundreds of billions, if not trillions, of these sensors eventually in the future, that all across in manufacturing, in retail, in healthcare, and pretty much every building, right? So when we trying to process all the data, instead of sending it to the cloud, what if you had your own cloud pretty much on premise at the edge? And that's really what's happening today. And you want to bring the capability of the cloud to the edge and do that sensor aggregation in both time and space. And that allows you to really get the next level of intelligence and processed at the edge.
So when you say in time and space, can you give me an example of what you mean by that?
Yeah. So think about a traffic intersection. You want to regulate the flow of traffic. Now at a traffic intersection, we're going to have multiple cameras, right, in different directions. And so you have to combine all those cameras in space, number one. And number two, you also have to combine each of those sensors in time, because what's happened, say, 15, 30 seconds ago is going to be relevant to what's going to happen now and what's going to happen in the next 30 seconds. So you have to do all of that fusion. Now, all of that fusion is not possible to do it on the camera itself because that camera doesn't know what else is happening on the other camera, for example. So that's the reason why, today we send the data to the cloud, but now we're starting to see some of that capability come to the edge, meaning pretty close to the edge.
That makes a lot of sense to me. And I think one of the things that when we think about the cloud has evolved quite a bit. We started with the cloud as infrastructure, and then increasingly we started to add different platform software services on top of that. And I would imagine that as we move to the edge, we're talking about a similar thing. So it seems like software is taking a broader role. What do you think is important in an AI edge platform as it pertains to software?
Yeah, so I think there is 3 layers. The first layer, we call it the underlying hardware architecture itself, right? So you have to be able to process enormous amounts of data and do a lot of artificial intelligence algorithms. So we've designed our GPUs, NVIDIA GPUs, in the last 5 years. We've increasingly added more capability to process these machine learning and deep learning and other sorts of AI capabilities in our GPUs. And incidentally, the same GPUs that are powering the data center and supercomputers, we have the same architecture that comes down all the way to edge computing. So we've added Tensor cores, we are on our 3rd generation with our Ampere GPUs that allows us to run AI very, very fast and effectively, number one. Now, the other piece of the hardware that's also increasingly becoming important is networking. Actually, if you take a look at the data centers today, we see some wonderful pictures in the front of the data center, but actually if you go back and take a look at it, you end up seeing lots of cables and cables and cables, right? So miles of cables, literally, right? When you add them all up. So, and the reason why networking is becoming important is because you have data that's coming in from high data rate, high throughput, and lots of sensors that's coming in. So you want to be able to process the data, and more importantly, you want to process the data in a secure, encrypted manner. So if you are doing that on your traditional system processor or the CPU, you're just bogging down the complete system. So network processing has become very, very important in order to run it in a secure and effective manner. So if you look at today's data centers, there's high-performance CPUs, there's high-performance GPUs, there's high-performance networking. So we are starting to see that same thing now being brought to the edge. And recently, with our EGX line of products, NVIDIA, we announced the fusion of our latest GPU, the Ampere series, plus Mellanox networking. So that's the first layer. So we have great hardware that is designed. Now, you talked about software. Now, there's 2 pieces of the software. The first piece of the software is, look, we are trying to bring the cloud to the edge, right? So what's so great about the cloud? Actually, the things that are great about the cloud is you can update your AI anytime, right? I mean, there's zero downtime effectively. You don't, you're not never worried about that. And you're constantly updating AI applications. When you deploy these AI applications into all of these devices into agriculture and manufacturing, these devices are going to be in the field for decades in some cases. And you want them to be getting better and better. So your software stack needs to be designed to be cloud native. And that's the number 2 that we're doing is essentially bringing all that software capability that you have, the flexibility you have in the cloud, can you bring that to the edge? And then that's the story that we are building towards, bring the cloud capability, cloud native stack into the edge.
Now, I know there are quite a bit of various technologies that we've looked at. We've talked about CPUs, we've talked about GPUs, we've talked about TPUs. There's lots of different types of processing units. And I know there's always been this tussle of, GPU being high performance for training, but being considered costly and maybe overkill for something like inference. Are we seeing any changes as we move into edge AI around that?
Yeah, I mean, I think the edge AI is so broad. There are many different use cases. And it turns out with our GPUs, when we started, of course, the conventional wisdom was they're great for training and only training. But we have proven in the last couple of years that GPUs are great for inferencing. And the reason for that is, first of all, we've added all the tensor core capability, which essentially what you find in deep learning accelerators or other, other hardware accelerators. So we've added all that. But the key is, we kept the programmability, the software programmability. And then again, as you mentioned earlier, hardware is of course an important piece of it, but really what really makes it click in the end is all the software on top. So we've added this software stack, the secure software stack called the EGX, which essentially manages all these devices. And then that's all that's done so far is still just got you the infrastructure, if you will, right? The ability to run the applications. So, but still you got to run the applications. So we have created vertical application frameworks for different industries, such as we have a platform called Metropolis that we focus on for smart cities, which is all about processing video cameras. There are hundreds and thousands of camera feeds that are streaming all over the world. We have a platform that we're working on called Clara for medical healthcare and a lot of different use cases, AI use cases in healthcare. We have a platform called Isaac that we focus on for robotics applications. And we have a few others that, Jarvis for conversational AI, where a lot of the, interaction between human and machine is not just camera, right? It's a lot of it is audio, speech and natural language processing. So conversational AI. So really at the end of the day, companies, industries are looking for solutions. And so in order to do that, you have to provide a high performance computing platform, which includes the core software and also the application frameworks to accelerate the applications.
I love where you're going with this, because I think you mentioned this concept of solutions, and I think we started with AI and edge as a very broad horizontal thing, but to really make it sort of sing for organizations, it has to be tailored to the types of use cases that they're looking at. And you actually work with a wide range of companies, and I thought it might be nice if you could share a couple of examples of the different types of things that you see people doing in AI in your client base today.
Yeah, fantastic. So let me give you a couple of examples, especially in the times that we are in right now, right? I'll give you one example in healthcare, and I'll give you another example in retail next. So healthcare, given the difficult situation that we're all facing now with COVID-19, of course, it's become very difficult where touch is not necessarily the greatest thing, right? Social distancing is important. So hospitals, we are working with many companies in hospitals and many startups for hospitals. So we recently announced this platform called Clara Guardian, which is essentially a fusion of two main technologies. One is intelligent video analytics, and the other one is conversational AI. So if you think about social distancing, you want to know how many people are entering the hospital from multiple doors, right? There's typically more than one entrance, so you have cameras all over. So you are able to do people counting. You're able to do flow analysis as to if they're congregating in a certain spot, if there are hotspots, and also in the case of hospital, specific areas in the hospital, they're washing their hands, are they so those kind of, and also in a patient room, if the patient for example is falling off the bed, so you can do those kind of analytics. So that's one. Number two is, so we have this conversational AI. So now you can put a speaker and a microphone near every patient bed, and the patient can basically have a conversation with, can mention something, and then AI can, transform that, do, speech recognition, do natural language processing, and then, call a nurse, for example. So these, we're working with many different startups. So hospitals are the number one site for it, but of course now you can imagine that same technology now can be deployed into other buildings as we try to return back to work. So it's ability to process lots of video and also fusing that with conversational AI. So that's one use case we are seeing a lot of adoption, especially in the last 4 or 5 months. The second one is in retail. In retail, similar things exist, right? So for example, self-checkout has become quite popular recently, and so in order to do, when you're doing self-checkout, but also in a retail store, besides doing self-checkout, you want to do inventory management, right? You want to understand, the other day, a couple of months ago, I was going to a Home Depot to buy something to my wife asked me to get me something to clean up, and then I saw somebody there at the front of the entrance, basically with a clicker, counting the number of people going in, and making sure that, because you want to be safe, so they want to keep the number of people that are getting into the building to be restricted. Now, as we go back to work, imagine in retail stores, imagine in other buildings, how are you going to be able to do all of that? So again, artificial intelligence and edge computing will definitely come into the picture. So we're starting to see these move from, last year, I would say they were mostly in the lab, but now this year we're starting to see them being deployed in several, and I think soon we'll start to see them being deployed at scale.
I think one of the most exciting things about edge AI right now is this concept that you can start with one use case and then you layer use cases. So you were talking about vision and conversation, right? So you were talking about self checkout and inventory. So it's one of those things that once you get into the process, there's sort of endless ways that you can take it to improve insight in the organization. And then there are also some real sexy things that we're starting to see happen in AI too. And I know that you guys have done a lot with automotive, and I think that they're pretty bleeding edge use cases as far as AI use cases go. But I thought maybe you could share a little bit about how you see the automotive landscape using AI.
Sure. So I think when we talk about AI in automotive, the first thing that comes to people's mind, of course, is the self-driving car, whether it's partially autonomous or eventually getting to be more and more autonomous, right? That's the first thing that comes into mind. And of course, AI is very central to that with respect to doing all the perception and route planning. And an automotive is a classic example of multi-sensor fusion, right? So we've got several cameras in all directions, we've got LiDAR, we've got radar, and then in the car, there's also probably some, increasingly some microphones and speakers that are also being put into place. So that's happening, and we are seeing increasingly more amount of autonomy come into the picture. But it turns out there's a lot more AI being applied in automotive industry beyond, of course, the car itself. Number one, we have to actually create that AI that's running in the car, and that needs to be updated. So it requires an enormous supercomputing capability, enormous amount of data that needs to be collected and trained and then deployed into the car. And that's a continuous process that's going on and on. So there's a lot of AI work that's happening in the creation of the AI that goes into the car, number one. Number two, there's not enough testing that you can do really in the physical world when you put that AI in the car. So the answer is doing that in simulation, virtual reality, right? And it stands to reason that we'll probably simulate 2, 3, 4 orders of magnitude, so 1,000 or 10,000 times more number of miles in simulation, because it's more cost effective. You can do a lot more coverage, and you can do it a lot faster because you can parallelize many different things. So we're increasingly seeing simulation being used quite a bit, and NVIDIA is right in the smack in the middle of it, because we started off as a graphics company, and of course that speaks to our forte of bringing realistic environment in order to simulate the worlds around us. So that's the second part. The third part, actually, as it turns out, is automotive also has a lot of manufacturing associated with it. You have to build these cars, and happens to be an extremely complicated process, as you have thousands, hundreds, or tens of thousands of parts that are coming into a factory and in a warehouse, essentially, as you're trying to manufacture it. And we are working on that as well with respect to warehouse robots and optical inspection for defects and pick and place robots. And recently, we've announced this partnership with BMW at GTC back in May of this year, where we're partnering with them to automate the flow of this manufacturing warehouse using all of these technologies in AI. So I think automotive is a fantastic example of where it's happening from end to end, as you say, from training, creation of the networks, high performance computing, to simulation, to manufacturing, warehouses, robotics, to, of course, in the end, the self-driving car itself.
So it seems like we've got everything from a very simple camera use case that could be extended all the way into self-driving. So obviously a wide range of what we're looking at with Edge AI that we're really excited about. Any other advanced use cases that you'd like to share with the audience, or what you see is coming next in the future of AI?
Yeah, I think the interesting thing about all of this is we're still at the very early stages of this deployment, right? So we're, a year or two ago, we focused on one domain. It was maybe, just image classification, camera sensors. Now we are starting to see the fusion of multiple domains like image, video, and conversational AI. And next, where are we going? I mean, 5G is coming, right? And 5G is going to be, so important for all of this edge AI and IoT applications. And 5G is going to be pretty broadly deployed, and the architecture of 5G also tends to be pretty diverging, meaning it's going to run in small data centers. It's going to run a 5G stack might run on the appliance itself, close to the factory itself, or in the factory itself. So we're going to start seeing the fusion of multiple domains, as I mentioned, from conversational AI to image processing to robotics to then add 5G on top of that. Wouldn't it be nice to see all of those come together and work in a seamless manner?
Well, I look forward to seeing what we can create with all these great new AI technologies. Deepu, thank you so much for your time.
Maribel, it was a pleasure. Thank you very much.
Deepu, welcome to the Q&A portion of our section right now. And I know that I see a question in the Slack channel that basically I think a lot of people have. And it's basically, how far do you think edge computing can go, let's just say in 5 years? How much AI compute power can we put at the edge? And what do you think will be the coexistence with the cloud? Do you think we'll be doing more processing at the edge or a lot of processing still in the cloud?
Yeah, I think as we talked about today, much of the processing is in the cloud, but we're seeing that increasingly come to the edge. And I think if you think about 5 years from now, I think a lot of compute will happen at the edge in conjunction with the cloud. So when you've got these hundreds of billions of sensors quickly going to maybe 1 trillion plus sensors, there's a lot of data obviously being generated. If you just think about video camera itself, there's over 1 billion video cameras that are streaming 24/7, and each of them are 1080p or HD resolution. So think of this like 1 billion Netflix streams. If you were to download it, effectively that's what's happening. So it's hard to be able to send that all to the cloud. So we will see increasingly more and more amount of processing being done at the edge. But as we talked about, in order to gain the next level intelligence, you have to fuse the data that's coming from all these edge computers. So there'll also definitely be analysis that has to be sent back to the cloud. So it's going to be hybrid, but a lot of it at the edge as well.
Excellent. Okay, so a second question. With the advent of 5G, cloud GPUs may gain the edge over computing on the edge, pun intended apparently. Real time comes. What applications do you think would still prefer edge computing?
Yeah, I think, if you think about, what we talked about, so 5G itself is going to be run in a lot of distributed ways, right? So 5G, of course, will be run in a centralized manner, but also be running in a distributed manner. So we can definitely see scenarios where you have a warehouse or a factory or an oil well where, you'll have your local base station, and that 5G stack can run natively right there, right, on the edge computer. Now, just running 5G is necessary, but it's not sufficient, as you know. So then you're going to run the other application stacks, whether it's video analytics or whether it is conversational AI. So we can imagine this fusion of an edge computer that has 5G running on part of it, and then you have video analytics running on at the same time, and then maybe conversational AI also happening. So you can all three of these can be running simultaneously on an edge computer.
Okay, another question. You mentioned the discussion of simulation around automotive. Are there other areas in AI where you see simulation will be important?
Yeah, absolutely. Robotics, of course, as a natural extension to automotive. You can think about why we want to do simulation even more so, right? Because in the case of robotics, a lot of this robotics involves touch and feel when you're talking about pick and place, and they're working besides human. So when you want to bring them finally into the factory and working, in real life, you've got hundreds of pounds, if not tons of metal, steel beside you. So definitely you want to make sure that, all of those, test cases, scenarios have been exercised. So simulation, no question, is pretty much the only answer to get there. Now you can even think beyond that. Even just in the case of video analytics, as we are finding out, the way we create these neural networks today is we are basically capturing a lot of data, right? And we are labeling the data or annotating the data, and then we're training the neural network. Now, at some point, as we're finding out that there's not enough data that you can collect and annotate and do this manually. So we can leverage simulation actually to create scenarios that are accurate reflection of the real world, and then because of you create that in simulation, you can actually self-label that. So as a result of that, now we are able to actually gather even more data for training those neural networks, which essentially increases the accuracy when you deploy those that AI.
Okay, quickly, in the few seconds we have left, ML is great when it works, but it has lots of moving parts. Are there any checks and balances when something critical breaks in the chain?
Yeah, so I think that's a good question, and we constantly grapple with that, right? So it turns out that in the case if you look at self-driving cars or the effort that's happening there, it's not exclusively ML or deep learning, right? So there is redundancy being used with obviously number one in hardware, but there's also redundancy being used in software and also in the algorithms. You can do some traditional computer vision based approaches, and then you can compare that with deep learning based approaches. And not only that, you can run multiple deep learning based neural networks and have a comparison of those independently in order to come up with an answer that is not just dependent on a single critical point, but a fusion of multiple answers.
Thank you, Deepu, so much. We're out of time for questions at this point.
Thank you, Maribel.
Thank you again to Deepu and Maribel for their discussion. Coming up next is a fireside chat titled Pin to Purchase, Lessons from Pinterest on Leveraging Computer Vision and E-Commerce at Scale to Create Inspirational Shopping Journeys. Please welcome Professor of Marketing and Technology at NYU and former SVP and Chief Innovation Expert at Ipsos, Nicole Alexander, along with Jeremy King, the SVP of Technology at Pinterest.
So welcome everyone, and thank you for joining us today. I am Nicole Alexander. I am a professor of marketing for NYU and the former chief innovation expert at Ipsos Market Research. I will be joined today by Jeremy of Pinterest. And welcome, Jeremy. I'm really excited for this discussion today.
Thank you so much for having me. It's great. It's great that we can set this up.
Yeah, definitely. So one of the things when you and I spoke a week ago that I found really interesting is outside of all the amazing things that you and your team have done over, not just the last several months, but over the last year, I found out that you recently came on board with Pinterest, I think in 2019. So before we jump into all the other questions, tell me a little bit about what brought you into Pinterest. What was your mandate, and what was your first job that you were going to tackle once you got there?
Yeah, thanks. It's great. It's been about 15 months since I joined Pinterest, and you're right. I was coming off a run with a wonderful run at Walmart, where I was running the front end side of the business. I was CTO of the U.S. business, and it was a great run. I was traveling a ton, and the plan was to take the summer off with my kids before they went off to college. That didn't happen because I got this wonderful meeting with Ben, who's the CEO, Ben Silverman, and one thing led to another, and he asked me to join as the head of engineering, and I couldn't resist. It's such a great company, and machine learning has really been at the foundation of Pinterest from the beginning. So I really wanted to make sure that my skills stay really relevant there in the world, and Pinterest is really leading computer vision and machine learning, and it's really hard not to love Pinterest. I mean, if you talk 9 out of 10 people that you talk to, number one, know about Pinterest and will say, "Oh, I love Pinterest," and it's really great to work for a company that everyone really uses for inspiration.
Oh, absolutely. Well, I have to say I'm a pinner, and I've been using it avidly over the last several months. So, but one of the things also is a user of Pinterest, I've noticed a lot of the interesting additions that you've had. So, but particularly, I'm sure you've seen traffic up over the last 3 to 4 months, just with COVID and the current situation. I'm just curious, what are some of the biggest shifts that you've seen during COVID of how users are engaging with the site, in particular because of the lockdown that some of us are still in, some of us are coming out of, and how has your team sort of preempted those shifts, if at all, and leveraged that behavioral change?
Yeah, it's great. And frankly, it's fascinating to work on a platform that has such a global reach. You can see things changing literally day by day as cities go quarantine, activity changes literally overnight. People are searching and saving and creating boards at all record highs. Our searches are up like 60% and people immediately went to like how to entertain bored kids, or how do I set up a home office, or do DIY masks, or all these sorts of things. So amazing is very shortly after people sort of got a handle on their life, they turned back to Pinterest for inspiration, thinking about travel and places where they want to go, DIY projects, remodeling, backyard ideas, and all the things that Pinterest is great for. You know, I sometimes I laugh when you look at queries, something like make your own fettuccine noodles is up like 470%. You know, so I think about making pasta and bread in their house for the first time, and learning how to cook and all these wonderful things they're using Pinterest for. You know, when we first we were working on another project that you asked about, what have we been doing? We were working on a project called the Today tab. One of the things about Pinterest, especially for new users or people that come back, is, you know, how do I get them access to the right information? We're very careful about making sure we collect and curate information from the world's most renowned experts, whether it's anti-vaxxing or information on COVID-19 or you know, what to do in a lockdown. We want to make sure we prepare this. We were working on a section called the Today tab, and we've been working on it maybe for a month or so with 4 or 5 engineers. And when this thing hit, we said, we have to launch it. It literally became an overnight project for, you know, 4 or 5 engineers, launched it literally over the weekend. And then it was sort of helping us not only take the billions of pins that we have on Pinterest, but also help them get inspiration, whether it's what to do on Juneteenth. I was just looking this morning, it's about 4th of July decorations, and of course, you know, inspiration for Pride Month and those sorts of things, and gives people a little bit more inspiration about what is in Pinterest, because it's so vast. So think about it as your own personal curation of inspiration, but also a little bit of editorial that we can do to help people find new things in the world. And it's been great.
Amazing. Yeah, I saw that pop up, and it's been a really interesting way to surface new content that I would not have normally have seen had it not been for the Today tab. So one of the things that we talked about, I'm sorry, one of the things that we talked about was that I think you call it Pinterest builds itself as sort of a visual discovery engine that leans heavily on, obviously, computer vision, AI, which makes for an opportune platform for e-com, particularly in the wake of businesses being temporarily shuttered, consumers being a bit hesitant of going back into shopping in brick and mortar environments. In March, you also rolled out the Verified Merchant program. Tell us a little bit about how you leveraged AI and visual search technology in order to ensure the program was a success. And are there any areas that you're still improving upon, or any hiccups that is kind of like, in hindsight, a learning opportunity?
Yeah, great question. This is one of the main reasons I came to Pinterest. I have over 20 years of experience in e-commerce and retail, and we talk about this event at Pinterest as we call it inspiration to action. One of the things that happens when you come to this, you find something that you love, whether you want to make it or make it for dinner, or you want to create a craft, or you just want to find this that sells this item. This is the number one thing that people want to do. So it's about building, you know, our vast, you know, take the billions of pins that we have and identify every single object in there, whether it's a pair of shoes or a dress, or it might be a piece of outdoor furniture that you love. You want to be able to tie that back to a merchant. So we've created not only the Verified Merchant program, which was really tied to make sure that we were getting really qualified merchants that have reputable merchants that have great return programs and have great shipping policies and all the things that you would expect. And we wanted to avoid a lot of the things that the social marketplace, they've got a lot of drop shippers and poor quality products, and shipping takes forever sometimes, and we just wanted to avoid that completely. So the Verified Merchant program was really not only to help us build out a huge catalog of actual products that we could identify with pins, but also to make sure that every single item that you buy through Pinterest is something that you get and you're very happy with. Now that we can't browse the aisles of physical stores, people are finding, time to go on Pinterest to sort of post clothing, home equipment, home decoration, outdoor ideas more and more, and we need to be able to close the loop on that. That's a huge part. And last thing I'll say is that the computer vision behind this is super incredible. We have some of the best computer vision people in the world, and to identify individual items from billions of pictures is a monumental task, and it's one that's it's getting better and better every day.
Amazing. So again, I had a lot of launches over the past several months. I know the one that I've been playing with personally that I love is you recently launched Lens, which allows users to do several things. But the area that I've tried myself is the ability to use my camera phone to get recommendations just of items that you see, whether it be something on television, something in my closet that I want something similar of. Can you tell us a little bit about the inspiration of Lens and some of the work that went into developing it? Because it appears that the accuracy rate is extremely high. I've tried it multiple times. I've never, had it come back with an error or without finding something that has a very similar look and feel to it. So.
Yeah, thank you for that. It's something we really strive for. So Lens is the ability for you to use Pinterest, take a picture, instead of searching with keywords, you take a picture of a particular item, and then we'll return back that item. We've had Lens for several years, and there's been a few copycats out there in the world that have copied almost exactly the terminology and what we do. But what we really think about that we've changed recently is we've created a dedicated shop tab. So if you're taking a picture of a beautiful outdoor space that has lots of different furniture in it, we can identify those individual items and then say, here's the location that you can get them. So that shopping tab is getting a lot of traction, and to your credit, many people are discovering Lens for the first time because we've added the ability to do shopping. This ties directly into what I was saying earlier about the verified merchant program. So making sure that we have millions, if not billions, of items in the catalog, so they're easier to identify. And like you said, a lot of it, we internally we call it Stella or shop the look. Oftentimes people are doing exactly what you said. It's like, I have this great dress, or I have these shoes. What can go with this? And so there's lots of like, fill out the look. I have, I want this purse, I want this dress, I want this pair of shoes. So the shop the look is something that we really look about. How do you take a scene and recreate it?
No, absolutely. And now, does this also align with your partnership with Shopify, or is that something separate?
Yeah, it very much does. So Shopify, we just launched a partnership with them about a half a year ago, and it just launched recently. And it's an amazing a connection between the two companies. Shopify being the biggest e-commerce platform in the world, it's literally a one-click add my items to Pinterest. And so if you're a Shopify merchant, you just say, I want to share my items to Pinterest, and then we'll upload the catalog from Shopify directly. So that is, and not only that, we also work with Shopify to make sure the merchants are legitimate and part of the program. So it's been a great partnership, and we continue to work with them on making it easier to purchase ads and to boost their items and all the things that you would want to do on a platform.
Perfect. And you touched a bit about specifically the spike in traffic over the last several months, a little bit earlier, and obviously with all of these new consumers or pinners coming onto the platform, I'm assuming simultaneously you have advertisers and partnerships that are eager to get in front of them. But when I think about from a media perspective, we always go back to, particularly if you're on the agency side or the brand side, how do I attribute credit, right? If I'm going to, if I want to understand how much traffic is coming from Pinterest versus these other channels that I'm advertising or present on, attribution or multivariate, analysis is really a key element to that. So are you being challenged with that? And is that an area that falls under your purview? And how are you talking about that to agencies and brands?
Yeah, that's a wonderful question. And I think every single person in digital marketing today is struggling with this question. Pinterest, in a lot of ways, is what we call an upper funnel part of the discovery process. When you're looking, when you come to Pinterest, oftentimes it's really only one word or two word queries. You might say kitchen ideas or backyard projects, or glass vases and things like that, or stylish watch or hairstyles or things like that. And this gives an opportunity for companies that are really not very well known yet, an opportunity to get in front of customers that they would never have the opportunity from before. Now, in the case of, I recently moved to San Francisco, and we bought our entire apartment on Pinterest. And we got introduced to companies like Joybird, who does couches and things like that. We would have never discovered Joybird, and we bought some mattresses and things like that for our apartment. We would have never discovered them about Pinterest. Now, the challenge, of course, is we looked at those couches maybe a month before we actually purchased them. So, who actually gets the credit? Because I may have gotten retargeted by another part of the internet. And so, really, this last click attribution, I think, is pretty old school thinking. And you touched on the point: is multi-touch attribution is really an important part of it. Of course, there are many platforms in the world say just forget about that. The last click is the only thing that matters. But as well as I do, if you're a business that wants to get introduced to new customers, there's really only a couple places on the internet that you can go to.
Very true, and the discovery phase is a very important one. So having that attribution across all the channels that finally lead to that purchase is a key element into how am I thinking about my media planning, where should I be, and how do I align all these different systems in order to actually close a sale at the end.
Absolutely. And companies like Home Depot, sorry, one last thing. Companies like Home Depot have really thought about it in different ways. They know if you're buying a refrigerator, it might take you 10 to 30 days to make a decision on a refrigerator or cabinets. If you're buying, power tools, it might take you 4 or 5 days. If you're buying a light bulb, it's probably one day, right? So they really think about these things in very wide swaths. It's not a one size fits all for even a single company. And I see companies getting more and more mature on how to measure digital engagement.
No, absolutely. It's becoming much more of an art as well as a science. So one of the areas that I always find extremely interesting as a gamer is VR and AR. And one of the things that I noticed, particularly in this climate where so many people are, looking for, their next role, is thinking about the skill sets. So VR and AR has been like this huge trend, but we really haven't seen it leveraged to mass scale or to its full potential, in my opinion. So I noticed that this is an area of skill set that you have listed for a lot of the job recs under engineering for Pinterest, because you guys are still hiring. What's Pinterest doing currently in this area? And if you can give us a bit of a sneak preview at all, what do you plan on doing in the future that you want to make sure that your engineering team really has this skill set embedded?
Sure, I'd love to. And you're right, AR is there's a lot of hype and a lot of gimmicks out there yet. But the way we're thinking about this is really the future. We've got some projects I'll outline for you, but Pinterest is inherently visual, so I think it will be a really good place to discover AR. Whether it's what we've already launched, which is called Virtual Try-On. So if you do a search for lipstick today, in the upper left corner, you'll see a virtual try-on button, and you'll have the ability to scroll through colors from dozens of different lipstick brands, and you can actually try them on your face. It's really fun to see a bunch of engineers trying lipstick on in the test labs. But that's just scratching the surface. So makeup is an obvious place. People have been experimenting with the sort of mirror types, how to put this shirt on or change my look, my hairstyle. And also you've seen, I think Target a few years ago did a wonderful job with, does this Christmas tree fit in my living room space? And you sort of measured around. And I think that's just the beginning of, can I put a home appliance in this space, or, my backyard renovation? So as we look at the future of retail, I think more and more of this will become AR, and whether it's something you take a picture of and then you want to apply it, or whether it's it's something like trying on. Cameras are getting better and better, and I think the next generation cameras are going to have LiDAR in them that'll help them understand where they are in the world, and it'll be much easier to do this. So we're getting ready for some fun visual cues that Pinterest can lead.
No, absolutely. And as someone who just bought a couch for your new place in San Francisco, did you use any of the AR VR to figure out how to situate your home?
We played around with it. It was a really weird space, so it didn't work exactly right. It wasn't just a square room. So that's what I mean. It'll get better and better as things, as the tools get more accurate and that sort of thing. So it'll be great. Companies like IKEA have 100% of their catalog already 3D. So they're already ready for this innovation to hit.
Absolutely. Absolutely. Well, Jeremy, I want to say that I know that we're running a little short on time. So I want to say thank you so much for joining. This was an amazing conversation, and it gave a little bit of a better glimpse inside of Pinterest and some of the things that you guys are doing over there with computer vision, and then just advanced AI systems. So thank you so much for joining us today. And thank you to the audience. We really appreciate your time. And we look forward to the rest of Transform.
Great conversation, Jeremy. I'm Matt Marshall, founder of VentureBeat, and here to take questions from the audience. Audience, if you haven't already, submit your questions on the Q&A channel here in Slack. I see some rolling in. Also, remember to click over. If you're in Tame, you could click over for a private Q&A session with Jeremy by looking at the session icon and going over there for a few minutes as well. So Jeremy, we have some questions here. Let's see. So you mentioned you have some of this comes from Hari Sivaraman. You mentioned you have some of the best computer vision people in the world who can sift through billions of images and identify the right match. This sounds like a massive undertaking. What might be the top 2 or 3 lessons you can share with our audience who are looking to implement similar computer vision technology?
Yeah, thank you for that. I think, sure, starting with talent is always an important part, and Pinterest has been blessed with a wonderful group. Even though we're a relatively small group, about 1,000 engineers, we've been able to attract talent given the scope of our company and what we're after. When you're starting, it's all about making sure you have access to good data, and you make sure that your engineers, engineers can actually use it. You'd be surprised at the number of CTOs I talked to that have sort of locked their data behind firewalls and policies and security, and they really can't do much with it. So I would say open your data up in a safe manner, of course, depending on the company you're with, and then let your engineers add it. We spend a lot of time building out our own machine learning platforms as well. There's a lot of open source and third-party tools out there now that didn't exist when Pinterest was started, but make sure you're looking at the latest and greatest from the cloud providers and from third parties as well.
Great, Jeremy. As you know, I talked with Vanya Josefovsky, who's a predecessor a couple years ago, and with Fan Li, or Li Fan, excuse me, who with three or 4 years of this journey on computer vision, and everyone kept talking about the small team that they had, very small team in computer vision. Now you said 1,000. How many people do you have on the computer vision team? Do you still think of it as small?
Yeah, the computer vision team isn't that big. It's less than 20. But in the end, what you really need is that core set of algo capabilities to build the graph, the identity and computer vision graph that then adds signals and embeddings into the rest of the company. So we think about Pinterest in 3 main surfaces. There's home, feed, search, and what we call related. And the related sections is really kind of a recommendation engine. They're getting signals from the machine, from the computer vision team that are ingesting the billions of pins that come in every day, and then effectively classifying them. The good news is Pinterest is almost a big classification engine. As people are pinning items to boards, they're also saying what that board might be for. We were talking before about home decor. Somebody might pin something as a, I like these blue accents. Somebody else might pin it to kitchen ideas. Somebody else might say great range hood. Somebody else might say, farmhouse kitchen or something. And so we're grabbing those signals that are essentially being crowdsourced by pinners and using that data as well as what we can discover from the computer vision side.
Great. I'm going to try and wrap two questions into one here. So there's a question from Nikki and another from Emil. So what are some of the biggest challenges on the platform and product side in your view? And maybe just double click on the technical strategy, right? Emil's question is are you focused mainly on computer vision? It sounds like your ML strategy is much wider than that. Maybe talk a little bit about both of those, right? The challenges you see in the platform and where you focus.
Yeah, there's two things we're really discovering right now. Pinterest is a great place where if you have an idea, you do a search, you can go very deep into a section. So we're also using Pinterest as a sort of a discovery platform for things you may not have come to the platform for. Of course, people came for like homeschooling ideas and how to build a home office and all the things that they discovered. But it's also a great place to elevate content like Black Lives Matter or what's happening with the Pride movement this month, and just telling people what's going on in the world. And so it's a little bit of editorial along with machine learning. That's one. The second thing is the platform for shopping. As we ingest hundreds of millions of catalog items, we don't have to just use the visual signal to help discover. When I find a beautiful lamp or a TV or a range hood for my kitchen, I want to know exactly where I can buy that. And oftentimes things like brand and price and all kinds of other attributes become more interesting. And so we sort of pivoted our signals once you go into the shopping tabs into more of those sort of traditional e-commerce sides. So it's sort of a marrying of the e-commerce business with the classic Pinterest computer vision technology.
Great, Jeremy. We're out of time. Thank you very much. And we're going to see you over in the private chat here in a second for all of those who want to join us. Thank you, Jeremy.
Thanks, Matt. Great to be here.
Thank you so much, Matt and Jeremy, for that chat about Pinterest. I know I was definitely taking notes about connecting my Shopify store, so thanks for the pro tip, Jeremy. Up next is a discussion on how Intel's technology is enabling push towards defect-free factories. Please welcome the VP and Senior Principal Engineer, the Internet of Things Group, at Intel, Brian McCarson, and welcome back the founder and CEO of VentureBeat, Matt Marshall.
Hi, I'm Matt Marshall, founder and CEO of VentureBeat, and I'm talking today with Brian McCarson, Vice President and Senior Principal Engineer of the Internet of Things Group at Intel. Hi, Brian. Thanks for joining us.
Hi, thanks for having me.
Brian, presumably we're talking about new computer vision applications on the edge. Could you tell us what you're seeing in 2020?
Well, what we're seeing is some interesting changes that are happening across a variety of different market segments. The one I work on currently is the industrial segment, so looking at how humans manufacture and distribute goods. And what we're finding is the advent of artificial intelligence technologies that can be applied from a vision-based perspective in the factory is really starting to take off. And the way these are being used is to try to help supplement some of the things that humans just can't really do naturally. And one of those most important applications is really around how you can detect manufacturing defects on products, whether that's looking for bad pixels on a computer screen for a laptop, a smartphone, a tablet, whether that's looking for manufacturing defects on critical components that go into an automobile that's being manufactured. The human eye is really good at detecting things like motion and color and changes in patterns. But when it comes to detecting nearly microscopic surface defects or fractions of a millimeter changes in size, this isn't really what our eyes are designed to do. But you can program a camera with a relatively simple AI-based application to be able to do some of those things that are really impossible to expect a human to do reliably. And so the whole field of quality control and defect monitoring in manufacturing is one of the most exciting new areas that I see really exploding in the industrial domain.
Brian, can you talk a little bit about maybe some customer examples? I don't know if you have any of some of these specifics around whether it's fixing pixels or observing defects, and what are the things you can say publicly about some of your customer cases at Intel? Because I know Intel is driving some of this with your hardware and some of the software around what you're doing.
Absolutely. One of the first breakthroughs that we had in the industrial segment was when Intel was partnering with a cloud service provider named Alibaba that many of you know of. And we were working on trying to improve how factories can produce just-in-time production for a variety of different segments. And one of the factories that we started working with early on makes transmissions for a variety of different automotive makers. They're a metal fabrication company. They cast different types of metals, and aluminum is one of the things that they cast. And the aluminum casting process is extremely sensitive to even the smallest fluctuations in machine performance. And obviously, with the expectations that people have today when they purchase an automobile, they're expecting extremely high reliability. And so the automotive manufacturers themselves have very tight quality control requirements in what they will accept from their sub-suppliers. And who actually had some of the best quality control practices in the industry was still only able to detect about 1 in 5 of the manufacturing defects that they had in their line with a human eye inspection. It wasn't that they didn't have enough people there to inspect, or that they didn't have workers that were really dedicated to what they were doing. They were asking humans to detect things that the human eye isn't really designed to detect. And when we were able to work with them to understand what they wanted to extract in terms of information they were trying to gather on the products as they were being manufactured, we were able to help them come up with a very scalable way of detecting defects immediately after these products were produced. And we were able to move their defect detection capability from 1 in 5, or roughly 20% positive defect detection rate, to greater than 99% defect detection rate. And the cost per machine, this company spends well over $1 million per tool. The cost per machine to deploy the hardware and the software required was a few $1,000s. So for literally a return on investment that's measured in days, they were able to go deploy what turned out to be one of the world's most advanced defect quality control implementations that could be implemented right directly on the factory floor without any machine retrograding. And this was pretty exciting for us. At first, we were thinking, wow, did we just get really lucky that we just happened to find that one problem that was relatively easy for us to go help solve? But what we found out as we started working with hundreds of additional factories globally, that we're all swimming in opportunities like this. And now that AI is becoming more accessible, more affordable, and some of the enabling software tools that Intel is providing makes it simple for you to go deploy an AI-based solution on a PC right next to an existing machine on the factory floor, simple relative to what it was even 2 years ago. This is really creating, I think, a fantastic opportunity for factories to improve their operating margins, for factories to improve their operating margins by improving product yield, reducing the number of customer returns, and ultimately have a very significant environmental impact. Because a large portion of the Earth's greenhouse gas emissions come from the manufacturing sector. And if you can improve the efficiency of that sector, even by a few percent by improving yields, that can have a massive impact on overall global greenhouse gas emissions. So there's a lot of things that have come together to make this really a great opportunity in the market for companies who want to capitalize on these now available AI innovations that are in the market and really see how they could turn those into profitable businesses.
Brian, you talk about the accessibility and a number of factors that have come together recently that weren't here before. For decision makers that are listening to you, can you maybe pick out one or two of the top trends that you see that are existing now to make it suddenly accessible in 2020 versus say a year or two ago? Right, you talked about declining price in the hardware, right, and maybe the software accessibility and UI. There's the algorithms, presumably CNN driven, right, convoluted neural networks and deep learning and computer vision that's presumably been around, but improving rapidly. Are they all coming together in like a Cambrian explosion? It's at a single time, or are there one or two things that listeners here should actually keep an eye on in terms of making it relevant for them right away this year?
Well, there's a few things that I think have come together in the market in a really positive way in recent years. One is there's more open source software capabilities that are now available in the market to help make it easier for people to tap into the value of the transistors that they purchase in a processor with a either integrated GPU or a discrete chip that they would add on top of existing hardware. Whereas before, it really took a specialist to go in and try to unlock all that goodness that comes with the silicon that you purchase. So that's one. Certainly at Intel, we've, of course, taken this open computer vision community that Intel has supported for many years and started translating that into a toolkit known as OpenVINO for visual inferencing capabilities at the edge, and have been populating that with a number of models or algorithms that are ready to go to get people started right away, so that you don't have to be an expert in the field with 10 years of AI experience to be able to go in and start making progress. And the way the software development community often works is they will smartly go and look and see what kind of code is already available from people who have solved these problems before, and use that as the starting point, and then make improvements to specialize that code for exactly what they're trying to do. And we can contribute to that more openly now, both at Intel, but more broadly in the overall AI ecosystem. So I think those are some interesting factors. The open source community, the availability of additional tools, and making it easier to unlock the value of hardware have all come together at a really good time. Additionally, there's been several other markets that have been happening, market evolutions that have been happening over the previous years around computer vision. And that's resulted in some basic algorithmic capabilities around feature detection, object detection that just didn't even exist a few years back. So now taking some of those existing tools and capabilities, adapting them to a different use case can really get you started with an 80-90% effective solution. So you're only having to do some minor tweaking along the way to get up to 96, 97, 98% plus performance.
Brian, we talked a lot about the technology side. If we take a look at the corporate transformation side, right, where a lot of companies have moved to embrace the cloud, and you talked about not necessarily stopping at the data center, but actually taking things down to the edge. Can you talk a little bit about what that means for transformation inside the end users of these technologies? What are some of the challenges you're seeing in 2020?
Yeah, one of the biggest challenges that we have is a lot of edge software is hard-coded, proprietary, or locked or tied to one specific set of hardware. What we're finding is the world is getting tired of that. The world wants to have more cloud-like experiences at the edge. We've gotten used to the fact that, we've moved away from having a BlackBerry-style device that you purchase that comes preloaded with all the software you're ever going to have, and you just configure it to your profile to do an email push and pull, to having a smartphone type device where you're buying excess compute, connectivity, and storage, but because it's a microservices-based architecture, you're able to customize it for your needs, and you can add and remove apps at will without having to program that device manually. People are wanting to see that cloud-like experience extend down to the edge. And so as businesses and companies are making decisions about what's most important to them and what technologies do they want to go deploy to help solve some of their business challenges, I would ask everyone to pause and think about how future ready is the approach that I'm thinking about taking at solving this problem. Have I selected a set of technologies that are going to create a foundation that I can innovate on afterwards? Or am I locking myself into another proprietary walled garden? Am I trying to extend that cloud-like capability closer to the edge? Or am I locking myself into code that is going to take an expert to try to be able to unwind if I ever need to make an upgrade or an enhancement? And so looking for that microservices architecture with virtualized or containerized compute modules, and trying to focus on the value-added applications that you can deploy on top of that, I think is really key to making your factory, your retail store, your smart cities, your automobile more future ready. And that's going to facilitate a much more adaptable, agile deployment of AI in the future.
Ryan, let's talk a little bit more about the challenges organizations are having to unlock some of this value. I think in the abstract for this conversation that we came up with online, we refer to analytics pipeline and companies needing that and to work in tandem with AI algorithms. Is there anything more you can talk about for that decision maker who may be listening to this in terms of the challenges organizations have?
So yeah, the challenges that people face are not always obvious, but they're definitely real. Talking about deploying a microservices architecture at the edge sounds fantastic, but there's a reality that machines have been existing for decades that use proprietary code. And take the industrial segment as an example. There's one company that Intel works with who has documented all the different languages, different programming languages and communication protocols that the machines on their factory floor speak, and they counted over 200. So it's like trying to conduct an orchestra in a factory with 200 different instruments all on their different sheet music, all communicating completely differently. If you can't get everyone aligned, it's going to be extremely difficult to try to automate things. And so as companies are thinking about the decisions that are needed in order to decide what technologies go into their factory floor, go into their retail store, go into their smart cities deployment, they should be thinking about how scalable is this? And are there open source technologies that I could be using that will help abstract away some of that proprietary information lock that people have been dealing with for decades with some of these legacy systems that exist? And for machine builders, for companies that are thinking about getting into business, they should be thinking about how do they concentrate on their value added components at the application layer and not contribute to this proprietary walled garden approach by adding in yet another language or communication protocol. Because just like we've seen alignment in the cloud domain and in the network domain, we're going to see that convergence in the edge domain. I don't think it's going to happen in my lifetime that there's going to be like one universal communication protocol, but there's going to be microservices architectures that allow you to abstract away some of that communication specific challenges and really normalize to a standardized way of communicating between devices and applications.
Great. Hey, Brian, we got another minute left. In terms of just putting a size to this market, I'm wondering if you've actually looked at that, right? If a lot of us are familiar with the conversational AI application area, which is something I think everyone can relate to, right? There's every company is going to need a way to communicate with some sort of virtual agent with their customers. With computer vision, sometimes you start wondering, okay, how big is that market where you actually need to be able to, where you're in a factory, you're an industrial supplier, for example, perhaps. But as you took a look around, how big is this market? Have you tried to put a size to it?
Well, we have, and what we find is pretty astounding. Let's just take the industrial segment alone. So these are the factories that make all the products that we consume, whether it's furniture or phones or laundry detergent. All these factories that are building the goods that we consume. The industrial automation business, just the industrial automation portion of that, is a $500 billion a year business globally. And more of those companies are pushing their industrial automation systems to be AI based. And more of those are finding value in utilizing vision-based AI capabilities to help them go solve challenges that they weren't able to solve before with just traditional time series data analytics. So it's not that time series data analytics is going away. That market is continuing to grow. But what we're seeing is right on the heels of that, the vision market is following as well. And I think it's creating a multiplier effect in the AI market right now, where this $500 billion a year industrial automation market is really over the next 2 to 5 years is going to see a very massive shift towards both a harmony of time series and vision-based AI applications, whether it's improving machine uptime, reducing factory defects, doing a better job at tracking inventory and storing that inventory. AI is really able to solve a lot of challenges today that weren't really economically or technologically feasible even just a few years ago.
Ryan, I see we're out of time. Thank you very much for joining us. It's fascinating.
Thank you for having me. It's my pleasure.
Thank you, Brian. I'm back to ask some questions live or answer some questions in the Q&A thread from the audience. And again, audience, feel free to go over to the Q&A poll on Slack if you have the pass to get there. And also remember, we have a few minutes with Brian in a private session. If you could click through Tame over to the session module and go to the private Q&A close to the top, and we'll have a few minutes with him there as well. So looking for, well, this questions rolling in from Brian McCarson, OpenVINO, ready to go, algos. Can we bring this into the classroom for high school kids to start to play?
Oh, absolutely. I think what we've been trying to make available is in the OpenVINO model zoo that we have is a whole repository of ready-to-go models that in some cases already have some pre-trained sample sets that can be used. So you're not starting off from scratch. You kind of already get like a kit. It's like maybe instead of having to put all the raw ingredients to bake muffins, we have the pre-ready mix for you, so you can get started, and then you can optimize from there and customize it for your specific use case that you want to explore or experiment with. And so those are available today, and I would encourage all of you to get access to your free OpenVINO download, and you'll get access to a whole suite of different capabilities that are there for you to explore and apply to your innovations and go do something wonderful with.
Great, Brian. There's a big field question here for you from Ben Ilfeld. Do you have any insight into the future trends that are going to be big for companies to be leveraging, especially for future application opportunities?
Yeah, Ben, that's a great question. And obviously, I don't have the best crystal ball, but what I can tell you is uh, it, companies are pushing for more IT-like, cloud-like experiences closer to the edge. So abstracting away all that proprietary fixed function code so that you can really concentrate on deploying applications that provide value and doing that in a way that you can update those applications seamlessly over the air at the click of a mouse, rather than having to go send trucks out or send people out to go and actually physically reflash a device. That's just becoming more and more an archaic way of trying to approach things. And with the AI field changing so fast, there's going to be models and topologies invented later this year that are going to be starting to be scaled next year. We can't possibly predict all of those. So you have to plan for change. You have to go into your next deployment, your next experiment, and think about, what am I going to do when there's a better topology, when there's a better model, when there's a refinement to my algorithm that I can go deploy. And make sure that you're thinking that through from a ease of use and future ready perspective. Great question, Ben.
Great. Yeah, there's a couple of questions on defect detection we'll get to. So from Adi Scheinfeld, do you think the main challenge now is improving AI algorithms, or in the hardware itself, sensors, cameras? And then the other question related is, does in defect detection, do you need a big bang approach on the AI implementation, or can it be done incrementally as companies see value in ROI?
Yeah, the two great questions. Quickly, I would say incremental value as you see ROI is the approach that I would take. AI can be challenging, and it can take time for employees in factories to get used to it. So as soon as you see a ROI positive opportunity, go take advantage of that, go deploy it, start to learn, get people comfortable with it, and it'll make it that much easier for you to go deploy additional opportunities later. That's one. The second is, I don't think our limitations right now are really on compute. I don't think our limitations are on storage, and I don't think our limitations are on camera capabilities. Right now, the market, at least for the industrial segment, is primarily limited by availability of models, algorithms, and new topologies that can work well for the industrial segment.
Great, Brian. I see that the time is just out. It just blew by. There's a whole bunch of questions we'll get to over in the private Q&A if those of you who asked them could join us, but I'll ask them on your behalf if you're not there. Thank you very much, Brian.
Thanks for having me.
And thank you, Matt and Brian, for that discussion. As I mentioned, they will be in the offstage Q&A room. And right now, the exclusive Executive Forum Roundtable is beginning. If you signed up, you should have received a calendar invite for the private Zoom room. If you're like, well, I didn't get a calendar invite, how do I get there? Don't worry, if you check the VIP Slack channels, there will be details on how you can join that room. But if you're not attending the roundtable, we're going to take a short break. So you can quickly stand up, stretch your legs, grab some water or another coffee, or if you want, you could pop into one of the many Slack channels in the VentureBeat Transform workspace to connect with some other attendees for some virtual networking. When we come back, we'll have another fireside chat. We'll see you in about 15 minutes.
AI in the enterprise is all the rage. But put the hype aside. How are today's organizations actually executing and seeing value from enterprise AI? Dataiku is the platform, democratizing access to data and enabling companies to build their own path to enterprise AI. To make enterprise AI a reality, Dataiku provides one simple user interface for data preparation, data exploration, automated machine learning, model deployment, AI monitoring, and management. Dataiku is built for everyone with robust features for both the code-free and the code-first. From business users and analysts to data scientists and engineers, Dataiku makes working with data faster and smarter. Each company's path to enterprise AI looks different, so Dataiku supports the creation of a spectrum of applications. Whether that means building out a self-serve analytics platform or fully operationalized AI integrated with business processes. No matter what the underlying changes in architecture or advancements in technology, Dataiku remains at the center, the cornerstone of data governance and responsible AI. Dataiku's centralized, controlled, and elastic environment fuels exponential growth in the amount of data, the number of AI projects, and the number of people contributing to such projects. Dataiku, for every industry, every use case, and also for everyone. Discover your path to enterprise AI at dataiku.com.
Free trials can be great, but sometimes it can be hard to remember when they end before you get charged. Thankfully, Eno, your Capital One assistant, is always looking out for you and your money. You'll receive a message when Eno spots a potential new free trial. Tell Eno you want a reminder, and Eno will let you know the day before your free trial ends. You decide whether to cancel your trial before you get charged or to continue with your new subscription.
Resistance. Sarah, your Movie Plus trial is about to expire. Do you want to continue or cancel?
Capital One knows life doesn't update you about your credit card. So meet Eno, the Capital One assistant that looks out for charges that might surprise you and helps you fix them. Another way Capital One is watching out for your money when you're not. What's in your wallet?
Meet Jackson, an IT leader who's at his best when he's empowering the business to harness data and analytics at scale. But Jackson can't provide on-demand access to specialized computing resources and his team's favorite tools for data science. So they're going rogue and using unapproved, ungoverned tools to do their work. And he's worried about security risks and frustrated by lack of visibility. The data scientists face workflow roadblocks and can't easily access the right business data. The CFO is upset about runaway departmental IT costs. And balancing business-critical workloads and governance while enabling AI innovation is keeping Jackson from being the best IT leader he can be. Jackson needs a vacation. And he needs Cloudera. Cloudera Machine Learning lets IT leaders give their teams the resources needed to experiment, iterate, and impact the business with machine learning without compromising data security and governance. So Jackson can focus on maintaining efficiency and scalability for multiple analytics workloads and onboard new projects and teams without impacting workloads or SLAs, while his data scientists experiment and innovate with self-service access to govern data and scale out compute resources on a single, secure, managed platform. And thanks to Cloudera, Jackson knows that changing deployment infrastructure and evolving technology won't disrupt future operations because Cloudera Machine Learning, together with integrated multifunction analytics experiences for Cloudera Data Platform, can be deployed anywhere with the same experience, including on-premise or in public and hybrid clouds. Cloudera Machine Learning means Jackson is always at his best, empowering innovation while driving the business forward by efficiently securing and delivering data from edge to AI. Now's probably a good time to put in for that vacation. Learn more about Cloudera Machine Learning today.
Every enterprise has its superheroes. Data scientists are the math whizzes. They give the organization the ability to fly with Python and R-based machine learning models that power competitive advantage. The League of Data Scientists knows everything about the latest open source technology innovation and how to put it to work. Their ally? Team IT. With protection superpowers, IT casts force fields around data science workflows, so nothing gets in or out without their sign-off. Their mission: keep everything safe, governed, and auditable. Team IT and the League of Data Scientists are united against a common enemy: vulnerability. From minor bugs to serious security gaps, vulnerability knows how to exploit open source software and can cause real problems in an enterprise. It breaks audit chains, opens the door to unauthorized users, and creates havoc. Fortunately, they have a secret weapon: Anaconda Team Edition. Anaconda Team Edition fuels Team IT's force field. It's a repository of thousands of data science and machine learning packages, curated by Conda experts, with vulnerability screening in place, so IT can curate, safe list, and block packages based on CVE scores, alerts, and reports. Team IT stays in charge of the who, what, when, and where of the data science lifecycle, keeping the enterprise safe and secure. And data scientists get to use the latest and greatest tools from the open source brain trust. Anaconda Team Edition. Powerful protection to help the enterprise fly. Good guys prevail.
Data science is a critical strategy for many enterprise companies. It's at the heart of AI and machine learning projects. The hard truth, however, is that data science projects fail. In fact, according to a study by Dimensional Research, 96% of companies run into problems with AI and machine learning projects. Whether it's a lack of data scientists, domain knowledge, business insights, or simply because of a lack of measurable value, achieving success with data science can be hard and frustrating. It doesn't have to be. Data is a complete rethinking of how data science is done. Through acceleration, augmentation, democratization, and operationalization. Our platform takes the complexity and failure out of your data science projects. It all starts with acceleration. Data frees up data scientists from the tedium of low-level manual tasks and gives them the freedom to focus on solving problems, allowing them to deliver 10 times more projects. Artificial intelligence in data augments your expertise. Our AI engine explores millions of hypotheses and helps you find deeper business insights that you would never have imagined. Data democratizes data science and makes it easier to put the power of data science into the hands of more users. With Data, citizen data scientists help your business scale data science and establish a true data-driven culture. Finally, Data enables faster data science operationalization. It takes your data science projects out of the lab and into your business. With .data, your data science process generates business value on an ongoing basis, giving you the ROI you've been searching for all along. When tested against top competitors, .data was able to shorten data science development cycles from 5 months to 5 days, all with raw customer data, while maintaining accuracy and, in some cases, even improving accuracy of the results. Acceleration, augmentation, democratization, and operationalization of data science. .data is data science without the headaches.
everybody, and welcome back to the main stage here at VentureBeat Transform. Up next, we've got another fireside chat, so I hope you enjoyed your break because this one is definitely going to be fascinating. And it is all about how Uber is leveraging AI on the edge and how computer vision can deliver a better product to its users with greater privacy and lower latency. Please welcome back Maribel Lopez, the founder and principal analyst at Lopez Research, along with Uber's chief scientist, Zubin Gawramani.
Hi, I'm Maribel Lopez, the founder of Lopez Research, and I am very excited to be here today talking with Zubin Gawramani, and he's from Uber, and we are at the AI, computer vision, and IoT at the Edge track. So I've had the opportunity to meet Zubin before, but I know the audience hasn't. So Zubin, maybe you can come in and introduce yourself and tell us a little bit about what you're doing at Uber.
Great, thanks. Hi, Maribel. This is great to be here. So I'm Uber's chief scientist and VP for artificial intelligence. And in that role, what I do is I help lead Uber's efforts around AI and machine learning. And just by way of background, I founded an AI company called Geometric Intelligence, and I've also been for a very long time a professor of machine learning at University of Cambridge.
Fabulous. Well, as I said, we are at the IoT, at the edge, computer vision, AI. As you can see, it's a very broad topic that we're looking at. And I know when I think about edge computing, there's a lot of different edges. There's a telco edge, there's a data center edge, there's the edge that could be at the automobile or at your smartphone. So when Uber is thinking about this, you play in many of those areas. Could you talk a little bit about how Uber is approaching the whole concept of the entirety of the edge and how AI fits into that?
Yeah, thanks. So really, when people think about AI and Uber, they often think about autonomous vehicles, since we made a very large investment in that area, and we've been doing this for many years now. First, let's talk about autonomous vehicles. I mean, clearly, successful autonomy involves sensing the world, understanding it, predicting it into the future, and then making decisions all in real time around like the behavior of other vehicles, pedestrians, cyclists, etc. And to do all that, you really need to be doing all that AI computation on the edge. And the edge in this case is really the vehicle itself. The vehicle is basically an AI-driven robot that is trying to move things around in the world. And the reason the edge is really important there is for latency and safety reasons. You can't really offboard your intelligence to some data center somewhere else. So that's clearly one area. But Uber also interacts with literally, tens of millions of people through their mobile devices. And that is another edge that we have a great deal of interest in. And so we have thousands of machine learning models at Uber driving all aspects of our business. Honestly, most of those machine learning models are not on the edge. They're living in our data centers, trying to model the complex dynamics of cities, ETAs, traffic, etc., supply and demand, our natural language interfaces with our customers, preventing fraud, enhancing safety, and so on. But some of those AI algorithms really are better on the device. They're better being deployed on the device. And so edge computing plays into some of the interactions that we have with our users on our mobile devices. And you have to think that, as a very global company, we have lots of people interacting with devices, but in areas where bandwidth is very poor, And so we need, we need to be able to do the computation on the device itself, so we don't have to deal with the bandwidth, and each mobile device has significant power. So, just to give an example of that, I mean, the reason for that is like running ML algorithms on the edge improves latency, it lowers bandwidth costs, improves safety and power and privacy. And one of the things we've done there, yeah, sorry. So yeah, I just want to give one example, just so we have a concrete example to talk about. So one example is on-device image quality. So when people have to upload documents, IDs, and things like that for verification purposes, we need to make sure those documents don't have blur, glare, they're not truncated. We make sure that they're actually IDs. And we use mobile ML on mobile with very small model size to be able to do that in real time on people's devices. And I think that makes people's experiences much better.
So that brings up a couple of interesting questions, right? So we were just talking about models on the edge, and then there's models in the cloud, and there's also some sense of how fine-grained the accuracy has to be when you're building these kinds of things. So do you think of it, you have categorizations of models, there's small, medium, and large, and how do you think about the whole pipeline of updating and managing what you mentioned was thousands of models? That's a lot of models.
Yeah, it's definitely a lot of models, and we definitely have categorizations of models. There are various ways in which we think about managing the whole zoo of models that we have at Uber. So one of them is we have a tiering system. So we have tier 1, tier 2, and so on. And the tier 1 models are the ones that are feeding important signals into our tier 1 services. So, if that model is producing poor signals, if it fails for some reason, then one of our essential tier 1 services go down, and that causes lots of pain for our customers. So we pay great attention to our tier 1 models and sort of less to the lower tier models. We also think about models and how they ingest data. So some are real-time models where they're really taking in signals from like every single interaction and sort of real-time signals that are really needed for that flawless user experience. And some are basically running not environments are much less. So we really try to manage them by understanding the tiering. We try to manage them by understanding the tiering. We try to manage them by understanding the signals that they take in, whether they're on device, on the edge, or data center. It sort of creates some order onto the chaos of having those thousands of models.
Excellent. Zubin, if I recall correctly, you have something that was called Michelangelo, and that was a AI platform that you had been working on. Can you tell us a little bit about that? And I know that we had also at one point talked about open source and where you see open source fitting in the AI landscape as well.
Yeah. So Michelangelo is the machine learning platform that we use internally at Uber. And we built this over the last 4 years or so, and it now serves those thousands of models that I talked about. And our goal was really not to reinvent the wheel here. So Michelangelo was actually built on top of best-in-class open source projects at the time. And we've integrated this into our data infrastructure, and we could do machine learning everywhere from like notebook-based ML that a single data scientist might do to larger projects where we might have like a team of 10 engineers or something working on a really important machine learning model. And the goal here is really to make the process of going from model ideation and experimentation to having it in production, to then monitoring it afterwards when it's in production, make all of that as seamless as we can. The things that we've the sort of principles that we used in building this platform are really, as you mentioned, Maribel, to embrace open source. So build kind of only what you need, because there's a lot of good stuff out there. And then customize the things that are important to you. And for us, Uber has some unique properties like, our space-time, real-time kind of features and things like that. Our use of like optimization methods to optimize parameters. So we built some of those components to it. And then, to really try to create as much transparency and accountability in the models that we have. So that tiering that I talked about, exploring models, like tracking their performance over time. And then, the thing that you always discover in a machine learning setting is you also have to invest in your data pipelines because, garbage in, garbage out, right? And so, we have to then spend a lot of time with our feature store, our data quality tracking, and even thinking about like tiering of data sources, right? So that we know which ones we have to put more effort into maintaining and which ones we can sort of not stress about as much.
Just for a second to pick up on that tiering of data sources concept, one of the things I think is really challenging for organizations is they have their data, then they might be working with third-party data and trying to figure out, to your point, the data engineering around that of what is good quality data. How have you been thinking about that? Or do you find that you don't use enough third-party data that's become an issue for you?
No, we certainly do use third-party data, but it takes quite a long time to kind of onboard that third-party data and to ensure there's a lot of quality. The platform we have provides a lot of sort of endogenous data. And so, our dependence on third-party is not that much. But when we do use it, we have to take lots of care to sort of check that it's high quality, to align it with our own data as well. Like, you really data, kind of when you think about it, the data is all about relationships of measurements between each other. And so you need to have very good alignment in time. You need to have alignment to different use cases, different products and things like that. So it takes a lot of effort.
Now, you were just talking about this concept of not reinventing the wheel, but in some ways, the wheel had to be invented in AI with companies like Uber that were very data-driven. They were early to the space, so maybe tools and other things weren't available at the time. From where you were to where you are today, what do you think's changed in AI?
Yeah, and if it's sort of a little over 4 years, that's to serve our needs a few years ago. And, even if it's sort of a little over 4 years, that's a long time in modern AI history,
AI years,
right? Yeah, AI years are like dog years, right? That's a long time in AI history. And I mean, fortunately, we didn't lock ourselves too much into things back then. So by depending on open source, for example, we were able to contribute to some of the open source projects along the way to sort of, match them up to our requirements, for example. But now I think there are just a lot of very good tools out there. So a new company investing in AI now will not have as many legacy systems as the ones that started out, for example, for us a few years ago. When we started out a few years ago, we didn't fully embrace deep learning, for example, as a sort of methodology. We were using tree-based machine learning very, very heavily. And honestly, tree-based machine learning works extremely well if you know how to use it and you have the right tools. So, but now we are sort of transitioning some of our models from tree-based methods to deep learning models, embracing frameworks like TensorFlow and PyTorch. The move from hardware from CPUs to GPUs, TPUs, and IPUs, which are intelligence processing units. That's another
So
interesting
many
move. Yeah. And then, nowadays we even have code-free machine learning systems. So in fact, one of our open source projects called Ludwig is a way to do machine learning without ever having to write code. You just write a configuration file and then all the code is sort of written for you. And we developed that internally. We use it internally, but other parties have used it as well. So there's a lot of evolution in the kind of tooling that is available for people out there. And I think actually a company coming in now would be able to ramp up quite quickly if they have the right talent, for example, to be able to identify those tools.
So two things. One, you just mentioned talent, so maybe a question around how do you think about talent these days? And the second thing is around, you're now a public company. So I'm wondering if anything has changed from where you were to now how you think about AI as a public company. So maybe you could help us unpack those two things.
Yeah, sure. So, talent is incredibly important. I mean, AI talent is really competitive. It's still really expensive. Um, and, there aren't really any magic silver bullets for that. But there are a few tips that are useful. So one of them is you need to find good leaders, people who are well respected, who can attract other people. People sort of think in terms of like, oh, if this person moved there, maybe it's okay, and maybe I'll move there too, right? That's the sort of mentality of a lot of AI researchers and engineers. To have a thriving AI team, you need to give them some level of autonomy as well. So, I mean, if you try to hire really expensive talent and then you tell them, oh, you're just a service for other people, they come and give you requirements and you have to do this and that task, they're just going to leave and go to another company where they have more autonomy. So you need to have some autonomy, but then you need to also align them with the business. And then the interaction model between the teams, the talent in AI or machine learning that you have, and the product teams and other engineering teams, that interaction model has to be really good as well. So it has to be one where you work really jointly together. You're not throwing problems over the wall, or you're not throwing models over the wall. So that's on the talent side. And then, I'll come to your point about like, has the company changed? And certainly, I feel like in the last almost 4 years at Uber, I've seen so many different phases of a company.
Much change.
From a hyper growth kind of mega startup to, being a public company, to being focused on profitability and more near-term goals. And then of course the crisis that comes from like COVID, like really impacting our rider business, but really making our, food delivery business explode. So it's just all those changes at the same time. And in terms of AI, this sort of forced us to go from one where we were investing in like longer term research to one that is much more nimble, able to sort of react to these competitive shocks, focused on showing ROI, operationalizing things, and really try to ruthlessly prioritize the value that we're trying to create, basically.
Awesome. And so for the last question, you've obviously learned a lot in 4 years. You've seen a lot. What advice would you give to people that are listening right now on how they should approach AI?
Yeah, there are a few things. I think, one of them is AI or machine learning is certainly not magic, really. It's as good as the data that you have, the tools that you extract, that use to extract value from that data, and the people that are, operating those tools. So those are the things you need to focus on. And that really makes you think about the importance of data engineering, to actually apply machine learning, in the words of one of my friends, is a full contact sport. You can't just sort of do it from an armchair. And you have to invest in talent. I would say invest in open source, really like embrace it. It's just part of the way people do things. And then, also don't get too
Hey, Zubin, welcome back to the Q&A. So there have been a couple of questions around, obviously, the autonomous driving, how far away we think we are from it. And from your perspective, what do you think are the advances in technology that need to happen?
Hi, Maribel. It's great to be here. I'm glad there's some good questions. Self-driving cars, obviously a fascinating area. And in terms of this question, we're still a bunch of years away. I don't want to pick on Elon Musk, but he goes off and makes grand claims all the time. I think his engineers probably sweat and try to do whatever they can, but it's a really deeply technologically difficult problem. So we're a few years away. I don't want to put a number down. And part of the reason I don't want to put a number down is because it's not a clear date. There isn't a clear 100% self-driving. Just like there are, better human drivers and worse human drivers, people who can drive in very crazy situations, and people who can drive on very basic roads and things like that. What we're going to see over the next few years is the capabilities of self-driving cars increasing to greater domains of operation. In other words, like from highways to more suburban and city streets and different kinds of weather, areas that from areas that are heavily mapped to areas that are less mapped, all the way out to eventually like an arbitrary kind of road or something like that. And the technologies that are going to get us there are really, it's not hardware. People in robotics used to think that hardware was like the thing that you needed to focus on, but actually this is a deeply software sort of problem. There'll be advances in hardware, but these are like difficult AI perception, prediction, machine learning problems. And that wasn't actually the original view in the self-driving community like 10 years ago. I mean, that's sort of changed over the time. So advances in simulation, advances in deep learning, advances in uncertainty quantification, decision-making under uncertainty, these are things that still need to improve.
Are these examples of you just need more time and more training data so that you can refine the models? Is that part of what it is when you say it's deeply a software problem?
Yeah, you do need more time and more training data, but there is another aspect to this which is difficult, which is the long tail. So, it's very easy nowadays to get a self-driving car to drive a bunch of miles on a highway in good weather. Okay, we know how to do that. The long tail is all of the very, very low probability events that can happen. That frisbee flying in front of you when you're in a suburb where a human being might think, oh, there's going to be a child running after it. To catch it, I better slow down, even if the frisbee's not in front of the car. That long tail of events is where a lot of human reasoning comes in. And, we will get better and better at it, and we need to create more and more such scenarios for our learning algorithms to improve their self-driving capabilities.
Got it. Okay, so one of the other things, there's obviously a lot of data in AI, and Uber obviously has a lot of data. When you are designing models and algorithms, how do you think about the whole privacy debate?
Yeah, privacy is incredibly important. It's important in our relationship with our users. It's important in the way users trust our platform, and trust is what drives the whole sharing economy, right? So the way we have to think about it is some information is needed for the service we provide, right? Like we need to know the location of a person to be able to get a car to them, but we don't necessarily need to store all that information. We have to comply with all the regulations. We anonymize things. We don't use personal information. So all of that stuff needs to be taken care of very carefully, but to provide a service for people.
Great. Well, that's all the time we have for questions, Zubin. Thank you so much for your time.
Great. Thanks, Maribel.
Once again, thank you to Maribel and Zubin for that discussion. And up next, we've got another fireside chat. This time it's going to focus on eBay's in-house open source-based AI platform and how it leverages computer vision and similarity search to provide users a more personalized and better shopping experience. Please welcome the CTO of eBay, Mazen Rawashdeh, along with Chief Technologist and co-founder of Samba Nova Systems, as well as a Cadence Design Professor of Electrical Engineering and Computer Science at Stanford University. Try to fit all of that on a business card. It's Kunle Olukotan.
Hello, my name is Kunle Olukotan, and I'm the Chief Technologist of Samba Nova Systems and also a professor at Stanford. And today I'm here for a fireside chat with Mazen Rawashdeh, who is CEO of eBay. And he's going to be talking about how eBay leverages computer vision and similarity search to provide the user a more personalized and better shopping experience. So to begin, Mazen, please give us a sense for the development environment at eBay and what is the scale of the use of AI and how is it used, and how critical is it to your business?
Great. Thanks, Kunle, for the introduction. This is a rich subject, and it's an exciting subject to talk about. If you think of eBay, the scale of eBay and why AI came to be a critical product for us and why we needed to build it. Think of eBay has massive volume of data, almost accumulated over 2 decades of user activities. We have over 174 million active buyers transact on the site. And we always start to figure out a way to create magical experiences for our customers. And one of the things 3 or 4 years ago, when we started going through our tech transformation for eBay, we immediately thought about building a platform, an end-to-end platform that allow us to mine the data we have and being able to unlock a lot of insight for our buyers and sellers and create these magical experiences. And AI, we decided we need to go and build an end-to-end AI platform. We think an eBay AI platform is a large-scale, multi-tenant, cloud-native platform that enabled our hundreds of developers and researchers, applied researchers, and data scientists to be able to mine the data, train model, inferencing real time at a scale and share those models. So if you think that's kind of a high level, how AI came to become part of our really core pillars for our tech transformation at eBay. And it really moved into many things we do at eBay. I always call AI at eBay, I don't call it a product, I call it an ecosystem because it's moved in almost everything we serve for our customers, but everything we do internally and manage our large scale platform. Examples, we use it in many areas from image search to personalization, recommendation, price guidance, fraud detection, and shipping estimate. Also, as you transact on eBay, we leverage AI to look at carrier performance and recommend different things for our customers. So it's absolutely an ecosystem for us.
And when you think about this ecosystem and you kind of go back to before you had this new capability that you developed to make it easier to use and develop AI applications at eBay, what was the critical set of things that kind of can do that in order to make the applicability of AI and the sorts of apps, especially those that are driven by IoT applications and image recognition. What was it that sort of led you to believe the needed a new system in order to make this capability more accessible and more available to people within eBay and to your customers outside of eBay?
So I think you were breaking up a little bit. Let me just make sure I understand. The question is, as we build this ecosystem, what was kind of the drivers and why we decided to go and build it, and how that enabled our internal product and engineering team to that's kind of the summary of the questions,
right?
Because you were breaking up a little bit. Yeah. So it's
sorry about that.
No worries. So as I mentioned, so eBay had some form of AI capabilities 3-4 years ago, but it was disjointed and it was done at a siloed model. It was not done at a scale, at a shared model, and it was not a capability that takes end to end the process of data, of compute, and shared model, and allow our researchers and applied researchers and data scientists to be able to go to one place and run their model at a scale. So that's why we felt there's the value to be able to bring all that power into one centralized place, where the aha moment was for us was, our internal users realize they can share model. And when you have large volume of data like eBay, almost over 5 petabyte of data, and keep growing, individually, you could not operate at a scale. It's cost prohibitive to have 500 or 600 researchers run these expensive models and not sharing. And all of a sudden, we were able to bring that into an end-to-end platform that allowed that sharing at a scale, but also allow us to go after this large volume of data. For example, when we look at our images, there's millions, tens of hundreds of millions of images at eBay. We actually run models at 100 million images at a time, and it creates a lot of intelligence and understanding of those images, and then have the rest of the researchers and developers leverage that instead of running these individually. So that centralization enabled us to operate at a scale and allow that sharing that it was not available before.
And so the result of that is that the users of these models get much more sophisticated, more accurate models, and they can build more interesting applications on top of that. So when you think about the capabilities that you provided with this new centralized AI system and your developers to build on these complex models, what concrete benefits does this provide to your end users, to the sellers and the buyers on eBay? What point to that says, hey, with this capability, this is what we were able to do?
Awesome. That's a great question. As I mentioned earlier, everything we do at eBay, every product we build it with our customers in mind, and we build it to create magical experiences for our customers. And one of a good example I can share is specific to the capability we build with this centralized end-to-end AI platform, what we've done during COVID-19. As we've seen influx of increase in activity on online and e-commerce transaction, That's also happened at eBay, where we had influx of buyers and sellers who flocked to our platform to take advantage of what they can do in a global platform like eBay. And one of the things we dealt with is price gouging, especially around masks and hand sanitizers, and also prohibited items. And we were able to deliver amazing value for our buyers and sellers and for our customers through computer vision, because that centralized system, we already ran models at 100 million images at a time, and we created really deep understanding of those images where object detection, image classification, and textual recognition is available for the rest of the different business unit. They didn't need to worry about running those expensive models. These models were already ran and available, and we leveraged them. And as a result, we were able to take down over 15 million items on eBay that either were fit in the category that violated our policy around price gouging or prohibited item. So that if you think of it, without this centralized AI system that ran at a scale and provided this capability to the different business units to leverage, it will be very difficult to each unit try to run in a disjointed model and being able to create that deep understanding of those images at eBay.
So you think about the similarity search capability that you provided. That are conventional models that have been developed in the image recognition community like ResNet, and how much of it is sort of custom models that you've developed at eBay specifically for your own purposes. Going further, you think about the architecture of Cryo, which is the name that you're given to the system that you've built. How would you say it differ? How is it unique to eBay and focused on eBay's problems? And how is it more general, like be applicable to other environments that might want to set up a system like this? So what sort of components does it have, in terms of the system organization and also the specific models that you're building, and how does that all feed into the capability that you've developed?
Yeah, Krylov is the name of our end-to-end AI platform we have, and what makes this platform different than many other solutions out in the market. What are you seeing? There's different solutions being built, but you have to stitch different pieces to make it work. What we build, this end-to-end unified AI platform, has all the components stitched all together for our internal customers to come to only one place, meaning all the compute and the GPU and memory and that design, including storage, including data, and then we'll call it the AI engine, which is a Krylov. It's homegrown product we built. It's mainly written in Java and Scala and some in Node.js. And then you have in the top of it the different capability like natural language processing, ML, and computer vision. So all these are stitched together as one system where our customers, internal customers and users come to it, and they don't worry about stitching these pieces together. And it's compatible with all the known public AI framework like TensorFlow or PyTorch. So you can take those product and AI framework and run them on a Krylov. So that's, I think, the biggest difference, where it's truly a unified end-to-end platform that enabled our researchers, developers, and data scientists to use. Can this be lift and shifted and be used in elsewhere? Of course. I mean, there is there's certain proprietary specific to our workload and the design, how we build it, but there's not a lot of customization that only makes it work for eBay. And if you talk about the different capability you put about image search, image similarity, personalization, buyer recommendation, it's all models our data scientists and researchers run in the back end and being able to very quickly do the inferencing and promote that into production and allow our customer to have this magical experiences. The other piece of, we also do inferencing on the edge, allow things like if we put a feature around image cleanup for our sellers, and that completely happen on the edge. It does not happen in the backend data center, but then we have it get propagated back to the edge, from the edge to the center within a short period of time. But we wanted to do it on the edge so it allow the latency, lower latency, but the speed of that transaction. So it is highly sophisticated, and we constantly understand feedback from our customer and figure out what can we do to make their life easy, leveraging those capabilities.
So Krylov, then, it's complete system to handle the full lifetime of building these AI models, from ingesting the data, 500 petabytes, to massaging the data to build the labeled data, training data sets, to training the models based on those data, and then deploying these trained models for inference for actual use in production. This Krylov system handles everything from the data to the deployed models. Is that correct?
That's absolutely correct. That's why we call it unified end-to-end AI platform. And some of these capability are self-service, and some it's in way to be completely 100% self-service. So it takes it from complete data. It's a complete data lifecycle management for AI, from ingestion, train, deployment, and then get feedback, retrain, and it's an end-to-end platform. And another aha moment was for us, what we noticed in the previous system, our researchers and developers were spending quite a bit of their time in dealing with these pieces and less time on a training model and inferencing. And as we build this platform for them, they're completely, most of the time is spent on training and inferencing, and they don't worry about creating a workspace or how am I going to move the data, or can I move this volume of data? And so that completely is being taken away from their plate and increase their productivity on the things that they really want to focus on. But also the sharing model. All of a sudden now we have these expensive models, but now they are shareable. Therefore, the ROI on that investment is just amazing.
And you think about sort of what it took to develop this Krylov system, sort of what sorts of engineering talent and how many people were involved in the development of this whole system.
Yeah, it's a fairly lean team, which is part of our philosophy. Our entire AI engineering team, including the researchers and developers and product managers, it's under 55 people, and they are taking care of everything from technologies and product, from the ingestions all the way to the training and inferencing. And so it's a fairly small team, and we believe it's important to keep it within that range. Then you'll be able to attract the 10x engineers, and you'll be able to always deal with customer issues with high sense of urgency. So this is, a lot of people think you need 200 or 300 engineers to do that. I think, we were able to do it in the last 3 years with that small lean team, and I think we've been successful in doing it that way.
And what do you think the key to being able to do it with a lean? Are you leveraging a lot of open source, or it's a matter of sort of the right kind of overall structure that's required in order to get away with a few number of people?
Yeah, I think the way it's the right culture, and it's important for us at eBay to create what I call it a culture of innovation and learning, and create a safe environment for our team to innovate and feel comfortable to make mistakes and fail. To me, it's only a mistake if you are not learning out of it. The moment you learn from it, it's a learning experience, and we really promote that culture. And that has paid a lot of dividend for us, not just in getting the product out, but attracting what I call them 10X engineers to the team.
Well, thank you very much for informative discussion about AI systems at eBay.
Thank you. Really appreciate the time and enjoy the conversation as well. Thank you so much.
Hello, we're back here with Mazen, the CTO of eBay, and to do a little Q&A. So let me kick it off with a question about the environment we're in today, right? The pandemic, global pandemic, and eBay is a global company, and it's using AI to serve the customers better, right? So how is AI and the COVID situation interacting? And how is AI being used to customers in this environment?
That's a great question and good conversation around it. Actually, AI played a really critical role for us since the beginning of the pandemic, in specific in two important areas. One of the areas is price gouging, as we've seen all prices of PPEs and went up dramatically, and we leverage AI to help us manage and control price gouging, but also leveraging computer vision to help us in detecting things around masks and hand sanitizer, where usually it's pretty difficult to detect with just regular processes. So looking at COVID-19 in the last 3 months, AI in a specific computer vision has played a major role for us in these two specific areas, and help us to protect our customers.
So, so computer vision is just one of the algorithms that you use at eBay in your platform. Can you say about other things beyond computer vision that are kind of critical to providing the sorts of service that customers expect on your platform?
Absolutely. When I think of AI, I don't think of AI as a product. I think of AI as an ecosystem. It's woven in and embedded almost in everything we do in our platform, all the services we put to serve our customers, or things we do internally inside the company. For example, in our search, we leverage AI for image similarity, and we leverage AI for best match, recommendation, price recommendation for our buyers, and also during shipping, we leverage AI to look at carrier performance and make the right recommendation. It's pretty much fraud detection. It's embedded and moved in all our experiences. That's why I call it as an ecosystem.
Right. So whenever AI comes up today, there's a lot of discussion around fairness and making sure that your algorithms are representative of the users and treat users fair. So how can you go into a little more detail into how you see this being used at eBay? And two aspects. One, sort of is it the data used for training or the people around the table? Can you say a little bit about how you think about it and how this plays out?
Yeah. At eBay, our customers is a front and center for everything we do. And we consider the experience of our customers, the well-being of our customers, their privacy, and their experience. It's always first things for us. And when we look at AI, start with the data you ingest, the data you trade. We make sure data is accurate, and also we have a lot of policies around privacy and around making sure as data is ingested and moved through the system, it's accurate and it's protected. And then the model, we keep training the models. And as you know, that constant feedback, constant loop with AI, it's what really gives you the biggest value. And we've seen that constant feedback and training, for example, in some areas of our computer vision, it's the accuracy is up to 95%. So it's that constant training for us where we believe we pay a lot of attention and pay a lot of focus into it to make sure we provide the best experience to our customers and consistent experience for our customers.
Is there any explicit thinking around fairness that you think comes up when you're training these models? Is there some way of understanding how fair they are? I mean, that's a difficult problem in itself.
It is an extremely difficult problem, but for us, it's no different than how we treat our customer in a regular basis through all of our experiences, and we apply that into AI model. So we it's our philosophy. Our customer comes first, and we treat all of our customer at the same level. So eBay, the value of eBay is a global platform where no matter where you are, from where you come, what's your background, eBay provide that amazing platform for me to transact, and we apply those same models as we build our AI models as well. It's a tough one, but I think it's the well-being and consistent way we treat our customer. It's part of our core values and philosophies.
Very much, Mazen.
Thank you, Mazen and Kunle, for that discussion. They will be available in the offstage Q&A Zoom room if you'd like to ask them any additional questions. But up next, we've got the tech showcases. So this is where we're going to do a couple of short format discussions. And up first is a showcase on how responsible computer vision can help reopen the economy. And it features Sean Moore, the CEO of TrueFace. And as most of you know, this is a hot and controversial topic in AI, especially with the events of the last few months. And after Sean's presentation, there'll be a special segment, which is a rapid fire Q&A between Sean and Hari Savaraman, the head of AI content strategy at VentureBeat. And then Sean will be available in the offstage Q&A room directly after the segment. Enjoy.
Hi everyone, I'm Sean Moore, the co-founder and CEO of TrueFace. TrueFace is a computer vision company with the fundamental goal of teaching cameras to see like human beings. Human beings are very good at pattern matching and understanding what is in their visual field of view. Cameras are not. And this morning, we are very excited to announce for the first time ever the TrueFace post-COVID solutions, which are intended to help businesses, stadiums, offices, facilities, cruise ships, all open up safely and responsibly. The founding team has 16 years experience in computer vision technology. Our technology is patented and used in the market today. And we are also the team behind Chewy, the facial recognition doorbell. For those that don't remember, Chewy was one of the first contactless access control solutions, whereby using your face as your credential to gain access into your smart home or into your office space. We're based here in Venice, California, and proud to be built in the United States. The opportunity has somewhat shifted over the last few months, and right now we are focusing on helping these businesses reopen safely. So identity management is very important. Understanding who is coming into your building, how often, and what time and what day are they supposed to be there. Contactless elevated temperature assessment means that we are extracting programmatically an elevated surface temperature off the skin of an individual to ensure that they are within the realm of being able to enter. Contactless access control using facial recognition as your credential, and then PPE compliance. We deliver this technology in one of three ways. One being VisionBox, which is our Dockerized containers, runs on client infrastructure. We've got offline SDKs, which work entirely air-gapped, offline, also on client infrastructure. And then TrueFace Aware, which is our no-code solution, again, runs on client infrastructure. Here's an example of our elevated body temperature assessment as well as access control. So here, all you have to do is add in the camera IP address, you click Start, and you'll see the stream pull up there on the left hand of the screen. We are putting the bounding box around the face and monitoring the face as it moves, and then pinpointing the inner canthus of the eye to extract the temperature from that. And you'll see it move with Cyrus as he moves his head. This technology is running in real time on that camera. So you do not need a server in a back room to process this. The process is all happening on the camera. This event data you'll see on the right side, live event, is streamed through WebSockets. And you can see there we've got the temperature extracted, the face detected true, and the average temperature frame by frame. This is an example of our access control solution using temperature as well. So you'll see the live feed there. You click into list view, you'll see the camera IP address, and the connection is good, as well as the location of the camera. Here is Andrew's profile. He's got 4 images in there. It's as simple as dragging and dropping an image to add him as an enrollment, or you can just click the trash can and it'll delete his image. And then here, we'll take a look at the events. So you can see the door has been opened for Andrew, his identity, his face template, and his temperature. And we've got a record of all the times that he's entered with his temperature. Here's an example of our mask technology. So compliance, we are analyzing if a face is wearing a mask, and here as she puts the mask on, you'll see it change from no mask to mask. And then here's our social distancing tools. So you'll see the orange boxes, which are an alert that people are getting too close together. And this can be used to ensure that people are standing far enough apart in line when they're trying to gain access into a stadium or into their place of work. It's very important for us that security is at the forefront of our minds when we develop this technology. So all of our technology is self-hosted on client infrastructure, meaning no data is ever transferred back to TrueFace servers. Facial recognition is actually a numerical representation of a face. So we're not actually storing the images, we're storing a face vector or a mathematical or geometric representation of that face. We've got technology that can auto-redact and blur every single person's face in the frame that we're not looking for and only extract the relevant people. And spoof and liveness is technology that ensures the individual trying to gain access is not holding up a picture, a video, or a cutout of someone else to use their credential to gain access. Some of our competitive advantages, on our first ever NIST submission last year, we scored in the top 10 in genuine match time. We're one of the only companies right now in the market that has published information regarding their ethnicity and age bias, or ethnicity and gender bias. And so we've taken a third-party data set here called Fairface, run our algorithm through it, and you'll see at the similarity threshold of 0.35, which is what we recommend clients use, the largest difference is between white and East Asian, and it's roughly 0.0025. We've also quantified and minimized our gender bias, so contrary to public belief, we perform better on females than we do on males, and the difference again being 0.0001. We're very excited to be a partner with the United States Air Force. We received our second contract from them last year, and we're looking forward to continuing to ensure that the individuals entering our Air Force bases are who they say they are. This is how we end every presentation, and it's something that we firmly believe in as a company, but it's through the responsible use of computer vision we can all live in a safer and smarter world. Thank you.
Hello, everyone, and welcome to this rapid fire session. I'm Hari Subramanian, the head of content strategy for VentureBeat. And today we're going to be discussing one of the most controversial topics in artificial intelligence, facial recognition. This is a topic that has divided opinion worldwide. There are people that are for it, there are people that are against it. Today we'll be having sort of a rapid fire Q&A and no holds barred discussion with one of the top industry experts in this field and one of the leading companies in this field. So please welcome Sean Moore, the CEO and founder of TrueFace. Sean, welcome to Transform.
Thank you for having me today.
Great. So Sean, let's get right into it. We want to talk about some of the biggest issues in facial recognition. As you know, it's been very controversial. Will it take humanity forward? Will it take it backward? What are the pros? What are the cons? So let's start off talking about privacy. As we well know by now, one of the most important things that determines the accuracy of an AI model is data. The more data you have, the more accurate your AI model is. And the error rates go down, therefore. In your case, the data that you're working with is really people's faces, right? How do you go about collecting this data without impinging upon their privacy?
It's a great question, and I think it's something that the industry has been evolving to answer truly. And for us specifically, there are online resources with publicly available data, and then there are private data sets, and then GANs, so generative adversarial networks. So those are the three sources of data that you can go after. And for the industry, I think a lot of the algorithms are trained on publicly available data, and then you've got companies who go out and source private data, which is important to get a more proportionate representation of the world. And that's really where you drive the accuracy is getting more diverse data, lots of it, and clean data. Truly, it needs to be clean data in the sense that it's tagged appropriately and you've got multiple pictures of the same person. So to go get that data privately means that you are paying an agency, or you are going out yourself and collecting that information from willing individuals. I think that Google made the news for paying people, I think it was like $5 per image on the street. Somewhat controversial, but at the end of the day, if those people are willing to give the information over knowingly for $5, and that's their decision. So I think the three pillars to collecting data are publicly available data sets, things like celebrity data sets, privately collected data sets, and then generative adversarial networks, which are still coming to maturity. And I don't think I know of a specific model that has been trained just on those, but it is definitely an advancement in this industry.
Got it. Great. So let's talk about accountability. Now, many years ago, and this is a personal sort of life experience that I've had, so I'd like to share that with you as well. When 9/11 happened, one of my colleagues from India, this was a hardworking, law-abiding guy who apparently resembled somebody who's a person of interest. Right? He was pulled up at the WTC station multiple times and questioned to the point where he almost felt harassed. Now, why did that happen? Because humans make mistakes in recognizing faces, especially when those faces come from a part of the world that you're not very familiar with. Right? It's very easy to make those mistakes. When humans make those mistakes, there is a level of forgiveness and there is a level of accountability as well, right? What happens when AI models make those same mistakes? How do we make sure that they're accountable, and will people be willing to forgive as easily?
I don't think people are willing to forgive as easily. They expect computers and machines to operate at 100% and 100% accuracy. And unfortunately, that's just not the case. This is really a law of numbers. And so when you talk about facial recognition, at its foundation is geometry. It's measuring angles and distances on a face. And there is no inherent bias in the technology. There is a bias in the data that is collected, which then could output a negative result. So it's very, very important that when you talk about law enforcement or an action that could cause harm to someone's life or change or alter someone's life based on a positive ID, that there are guardrails, there are procedures that law enforcement has to go down. Those procedures are transparent. Maybe there's public oversight or civilian oversight on those procedures, and then we understand the process much better. I think to your point that humans are forgiven fairly often and easy because it's a human error. There's an expectation of error within a human being. There's not an expectation of error within, say, a string of digits or mathematical equations. So, I think that there just has to be more transparency about the technology, how it's used, who has access to that data, where that data goes, how that data was collected in the first place. And that ultimately drives a better understanding of how this technology works. And we've been very explicit at our company, at TrueFace, that when these situations are taken into a life or death situation or arrest or not arrest situation, it's very, very, very important that this is not the only point of data. This is not, a 1 or a 0. It's a further piece of evidence amongst a large case of evidence that can be considered, because ultimately, like you mentioned, machines can make mistakes just like humans can. So, I think it's important that there is transparency within those processes.
Great, cool, gotcha. So I have two more questions. So I know we are kind of running out of time. So let's quickly go through those. Let's talk about bias and discrimination. You might have heard about the recent case of Robert Williams. It was a black man who was arrested from his home based on some computer vision algorithm which determined that he was the guy who took some valuable watches in a fancy store, right? So now the explanation that was given was that there weren't enough black faces that was used to train that algorithm. So now, how do you overcome this data bias where when you're training the algorithm, how do you solve for this problem?
Yeah, it's back to that data in, data out. So if you're not collecting a proportionate percentage of data from that certain ethnicity, then you're going to have an output that's not equally representative. So, I know the company that you're talking about. I don't know what their balance of the model is. It's something that they're likely not going to publish. We actually do publish that information. So we've tested our algorithms on Fairface's data set. It's a third-party data set. And we publicly announce, here is our bias, and here are the different ethnicities, and here are the different points of bias. So it's one way in which the market can hold us accountable. We hold ourselves accountable, but there's transparency that, yes, we do recognize that it's an issue. The way to solve that issue is, one, to be honest by it, and two, to make sure that the algorithms that you are putting in production are balanced. And if you're going to work with law enforcement, which we do not today, that there are procedures in place that have to be met. And I think that's likely where that fell short is, one, it was likely a data issue, and two, that the procedures were probably not in place necessary to prevent that type of thing from happening. It's super unfortunate for the individual, and it's really something that should not happen. And so, we are for regulation in this environment, and we want to see this technology regulated, but regulated properly.
Gotcha. Okay, so one last question I have, and this is about TrueFace. I want to talk about the accuracy of your model. I know that your model, your software uses the tear duct in the eye as the correct representative temperature of the human body. Now, how do you make sure that the accuracy of that, how do you test for false negatives and false positives, right? Like, for instance, if somebody just ran up a flight of stairs, his body temperature is going to be higher, or somebody just came out of an air-conditioned unit or drank, a very ice cold drink, would that make a difference to the temperature? How do you solve for these false negatives and false positives?
We work with a group called IRIX, and they provide us the cameras. And so we've taken our software, our facial recognition software, and loaded it onto those cameras so it operates at the edge. And what we do with our facial recognition technology is detect the face, and then we extract that inner eye duct, like you mentioned, to populate the elevated body temperature, or the body temperature. And what we have found from our testing is that, typically your forehead is going to be your warmest place on your face. And so some of the other providers, their technology goes directly to the warmest place on the face, which is an inaccurate representation of internal body temperature. The most accurate representation that we have found through our research is that inner canthus, the inner eye duct. And so, being able to programmatically go there without having anyone interact or hold up a temperature gun is really the next step in this solution. And the reason that it's important is because it's contactless. So you're not exposing a person on the other side of that desk to every single individual that walks into that store or walks into that production facility. And when it comes to accuracy, we're like I said, it's a newer technology, and so we're building out those research reports right now. But we do have our technology working in conjunction with these temperature guns to ensure that we are getting plus or minus 0.5 degree Fahrenheit difference. Therefore, we can funnel the individuals with elevated temperatures into secondary screening.
Gotcha. Sean, thank you very much for joining us. That was an informative session, and I hope it gave a lot of information to people who are interested in this technology. Thank you.
Yeah, thank you very much for having me.
Thank you.
Well, thank you so much for that discussion, Sean and Hari. I certainly found it really fascinating to listen to. And again, if you have additional questions for Sean, he will be in the offstage Q&A room. Up next, the showcase will be led by the president and CEO of AnyClip, Gil Becker. Now, if you guys missed the news, VentureBeat announced a partnership with AnyClip, producing the Transform Video Hub, which you can learn more about at VentureBeat.com. But right now, Gil is going to be discussing how AnyClip is using the deep learning computer vision to help organizations maximize the power of their video assets. If you have questions for Gil, he will also be available in the offstage Q&A room following the showcase.
Hello everyone, my name is Gil Becker and I'm the CEO of AnyClip. A few words about us. AnyClip is a company that maximizes the power of video. We do it with tools and insights and services, all are driven by our AI engine that generates data from video in real time. We have hundreds of media companies who are using our platform, and today we are launching our solutions to businesses, enterprise, corporations, or even small businesses. With a new set of products. Specifically, I will show you our newest AI-driven video hub, or Netflix for businesses, if you may. So video is the primary medium for communication between people and organizations. now more than ever. And you can see here enterprises and retailers and event organizers and so forth. The common denominator for all of these organizations is that they will do anything they can to attract us to watch the videos on the website and not elsewhere. And the reason for that is because this is how they make money. And this is how they create fans and how they increase brand awareness. So what is the problem here? Video data is missing. And without video data, video libraries are not accessible. They are not personalized, they are not relevant, and they are definitely not searchable. So we need a structured data so viewers will always prefer to watch the videos on the company's website and not elsewhere, just like on YouTube. And when that happens, companies will not lose business for the wrong reasons.
So what we're launching today is a video hub for businesses, or Netflix for businesses. AnyClip automatically generates accurate data from videos. We analyze frames and text and speech all together, and we recognize millions of keywords like people and brands and products and more. The videos are then automatically curated into predefined channels and sub-channels of the company's video hubs. And then the companies or the businesses can attract users to watch the videos on the website and not anywhere else. Let's see a demo.
So this is an example of Luminous Watch video hub for Cisco. Cisco has thousands of videos on YouTube and YouTube channels. So we took the videos, we analyzed them frame by frame and speech to text, and we recognized people and brands and products and keywords. Now all of the videos are sorted according to channels and sub-channels, and you can see in here, but they're also searchable. So if I have a question, if I want to look for a specific product, let's say ransomware, for example, we're jumping into the search engine. You can filter or according to the time, duration, recency, and relevance. I'm going to click on one of them, and then AnyClip creates a playlist, dynamic playlist that is relevant to what you searched in the first place. You can see it in here. Now, I'm going to show you how we're using our own AI technology in order to curate channels automatically. So that's a Luminous platform. As you can see, we have many videos. We're agnostic to the length of the videos. For the sake of the demo, I'm going to be uploading an alphabet clip manually, and now it is uploaded, transcoded, and analyzed. You can see to your right the Luminous Watch. I can create my own VOD instantly, but we're gonna just have another channel to the Cisco Luminous Watch, and you have different buttons to customize the channel, and that's it. You have a new channel that is called Google. You can easily curate it manually. You have a search engine, you have different filters, and you can play with that. But you can also create channels automatically with our AI engine, and I'm gonna be demonstrating that. You have more filters. You can look for different sources, Cisco, Bloomberg's, etc. Different people, brands. Let's put here Google. We're also supporting different categories, hundreds of permutations of education and food and beverages and news and what kind of news, etc., etc. And then that's it. I'll just click on that button, and then every time we're going to have another Google video, it will be placed automatically into this channel. That is the clip that I uploaded manually, and you can see that we detected and found the people, the brands, the advertising category, which is business and finance and technology and computing. And if I'm going back right now to the Cisco, and then I'm going to see the 5 clips that were tagged the Cisco. So a video hub for your business is as easy as it sounds if you have the right technology, and I'm here to answer any of your questions. Thank you very much for your time, and goodbye.
Well, Gil, thank you so much for that very informative and succinct presentation. Of course, if you guys do have questions, Gil will be available in the offstage Q&A room. And now it's time for another break. I know I'm thinking about lunch, and I'm sure a lot of you out there are as well. But I do want to make sure that you guys know that there's going to be another exclusive Executive Forum roundtable on Back to the Future, how the use of AI is leading advances in the transportation and automotive industry, presented by Xilinx. Once again, please check your calendar invites for the information on that private room, or of course, you can use those VIP Slack channels for access as well. And if you're not attending the roundtable, there will be a virtual networking available in the Slack channels. There's a bunch of different channels to choose from. If you guys haven't been taking advantage of the Slack workspace, we highly recommend you do so during the break, where you can connect with other industry attendees and executives. Enjoy, and we'll be back in just a little bit.
AI in the enterprise is all the rage. But put the hype aside. How are today's organizations actually executing and seeing value from enterprise AI? Dataiku is the platform, democratizing access to data and enabling companies to build their own path to enterprise AI. To make enterprise AI a reality, Dataiku provides one simple user interface for data preparation, data exploration, automated machine learning, model deployment, AI monitoring, and management. Dataiku is built for everyone with robust features for both the code-free and the code-first. From business users and analysts to data scientists and engineers, Dataiku makes working with data faster and smarter. Each company's path to enterprise AI looks different, so Dataiku supports the creation of a spectrum of applications. Whether that means building out a self-serve analytics platform or fully operationalized AI integrated with business processes. No matter what the underlying changes in architecture or advancements in technology, Dataiku remains at the center, the cornerstone of data governance and responsible AI. Dataiku's centralized, controlled, and elastic environment fuels exponential growth in the amount of data, the number of AI projects, and the number of people contributing to such projects. Dataiku, for every industry, every use case, and also for everyone. Discover your path to enterprise AI at dataiku.com.
Free trials can be great, but sometimes it can be hard to remember when they end before you get charged. Thankfully, Eno, your Capital One assistant, is always looking out for you and your money. You'll receive a message when Eno spots a potential new free trial. Tell Eno you want a reminder, and Eno will let you know the day before your free trial ends. You decide whether to cancel your trial before you get charged or to continue with your new subscription.
plus trial is about to expire. Do you want to continue or cancel?
Capital One knows life doesn't update you about your credit card. So meet Eno, the Capital One assistant that looks out for charges that might surprise you and helps you fix them. Another way Capital One is watching out for your money when you're not. What's in your wallet?
Meet Jackson, an IT leader who's at his best when he's empowering the business to harness data and analytics at scale. But Jackson can't provide on-demand access to specialized computing resources and his team's favorite tools for data science. So they're going rogue and using unapproved, ungoverned tools to do their work. And he's worried about security risks and frustrated by lack of visibility. The data scientists face workflow roadblocks and can't easily access the right business data. The CFO is upset about runaway departmental IT costs. And balancing business-critical workloads and governance while enabling AI innovation is keeping Jackson from being the best IT leader he can be. Jackson needs a vacation. And he needs Cloudera. Cloudera Machine Learning lets IT leaders give their teams the resources needed to experiment, iterate, and impact the business with machine learning without compromising data security and governance. So Jackson can focus on maintaining efficiency and scalability for multiple analytics workloads and onboard new projects and teams without impacting workloads or SLAs, while his data scientists experiment and innovate with self-service access to govern data and scale out compute resources on a single, secure, managed platform. And thanks to Cloudera, Jackson knows that changing deployment infrastructure and evolving technology won't disrupt future operations because Cloudera Machine Learning, together with integrated multifunction analytics experiences for Cloudera Data Platform, can be deployed anywhere with the same experience, including on-premise or in public and hybrid clouds. Cloudera Machine Learning means Jackson is always at his best, empowering innovation while driving the business forward by efficiently securing and delivering data from edge to AI. Now's probably a good time to put in for that vacation. Learn more about Cloudera Machine Learning today.
AI in the enterprise is all the rage. But put the hype aside. How are today's organizations actually executing and seeing value from enterprise AI? Dataiku is the platform, democratizing access to data and enabling companies to build their own path to enterprise AI. To make enterprise AI a reality, Dataiku provides one simple user interface for data preparation, data exploration, automated machine learning, model deployment, AI monitoring, and management. Dataiku is built for everyone with robust features for both the code-free and the code-first. From business users and analysts to data scientists and engineers, Dataiku makes working with data faster and smarter. Each company's path to enterprise AI looks different, so Dataiku supports the creation of a spectrum of applications. Whether that means building out a self-serve analytics platform or fully operationalized AI integrated with business processes. No matter what the underlying changes in architecture or advancements in technology, Dataiku remains at the center, the cornerstone of data governance and responsible AI. Dataiku's centralized, controlled, and elastic environment fuels exponential growth in the amount of data, the number of AI projects, and the number of people contributing to such projects. Dataiku, for every industry, every use case, and also for everyone. Discover your path to enterprise AI at dataiku.com.
Free trials can be great, but sometimes it can be hard to remember when they end before you get charged. Thankfully, Eno, your Capital One assistant, is always looking out for you and your money. You'll receive a message when Eno spots a potential new free trial. Tell Eno you want a reminder, and Eno will let you know the day before your free trial ends. You decide whether to cancel your trial before you get charged or to continue with your new subscription.
Resistance. Sarah, your Movie Plus trial is about to expire. Do you want to continue or cancel?
Capital One knows life doesn't update you about your credit card. So meet Eno, the Capital One assistant that looks out for charges that might surprise you and helps you fix them. Another way Capital One is watching out for your money when you're not. What's in your wallet?
Meet Jackson, an IT leader who's at his best when he's empowering the business to harness data and analytics at scale. But Jackson can't provide access to specialized computing resources and his team's favorite tools for data science. So they're going rogue and using unapproved, ungoverned tools to do their work. And he's worried about security risks and frustrated by lack of visibility. The data scientists face workflow roadblocks and can't easily access the right business data. The CFO is upset about runaway departmental IT costs. And balancing business-critical workloads and governance while enabling AI innovation is keeping Jackson from being the best IT leader he can be. Jackson needs a vacation. And he needs Cloudera. Cloudera Machine Learning lets IT leaders give their teams the resources needed to experiment, iterate, and impact the business with machine learning without compromising data security and governance. So Jackson can focus on maintaining efficiency and scalability for multiple analytics workloads and onboard new projects and teams without impacting workloads or SLAs, while his data scientists experiment and innovate with self-service access to govern data and scale out compute resources on a single, secure, managed platform. And thanks to Cloudera, Jackson knows that changing deployment infrastructure and evolving technology won't disrupt future operations because Cloudera Machine Learning, together with integrated multifunction analytics experiences for Cloudera Data Platform, can be deployed anywhere with the same experience, including on-premise or in public and hybrid clouds. Cloudera Machine Learning means Jackson is always at his best, empowering innovation while driving the business forward by efficiently securing and delivering data from edge to AI. Now's probably a good time to put in for that vacation. Learn more about Cloudera Machine Learning today.
Every enterprise has its superheroes. Data scientists are the math whizzes. They give the organization the ability to fly with Python and R-based machine learning models that power competitive advantage. The League of Data Scientists knows everything about the latest open source technology innovation and how to put it to work. Their ally? Team IT. With protection superpowers, IT casts force fields around data science workflows, so nothing gets in or out without their sign-off. Their mission: keep everything safe, governed, and auditable. Team IT and the League of Data Scientists are united against a common enemy: vulnerability. From minor bugs to serious security gaps, vulnerability knows how to exploit open source software and can cause real problems in an enterprise. It breaks audit chains, opens the door to unauthorized users, and creates havoc. Or they have a secret weapon: Anaconda Team Edition. Anaconda Team Edition fuels Team IT's force field. It's a repository of thousands of data science and machine learning packages, curated by Conda experts, with vulnerability screening in place, so IT can curate, safe list, and block packages based on CVE scores, alerts, and reports. Team IT stays in charge of the who, what, when, and where of the data science lifecycle, keeping the enterprise safe and secure. And data scientists get to use the latest and greatest tools from the open source brain trust. Anaconda Team Edition. Powerful protection to help the enterprise fly. Good guys prevail.
Data science is a critical strategy for many enterprise companies. It's at the heart of AI and machine learning projects. The hard truth, however, is that data science projects fail. In fact, according to a study by Dimensional Research, 96% of companies run into problems with AI and machine learning projects. Whether it's a lack of data scientists, domain knowledge, business insights, or simply because of a lack of measurable value, achieving success with data science can be hard and frustrating. It doesn't have to be. Data is a complete rethinking of how data science is done. Through acceleration, augmentation, democratization, and operationalization. Our platform takes the complexity and failure out of your data science projects. It all starts with acceleration. Data frees up data scientists from the tedium of low-level manual tasks and gives them the freedom to focus on solving problems, allowing them to deliver 10 times more projects. Artificial intelligence in data augments your expertise. Our AI engine explores millions of hypotheses and helps you find deeper business insights that you would never have imagined. Data democratizes data science and makes it easier to put the power of data science into the hands of more users. With Data, citizen data scientists help your business scale data science and establish a true data-driven culture. Finally, Data enables faster data science operationalization. It takes your data science projects out of the lab and into your business. With Data, your data science process generates business value on an ongoing basis, giving you the ROI you've been searching for all along. When tested against top competitors, Data was able to shorten data science development cycles from 5 months to 5 days, all with raw customer data, while maintaining accuracy and, in some cases, even improving accuracy of the results. Acceleration, augmentation, democratization, and operationalization of data science. Data is data science without the headaches.
AI in the enterprise is all the rage. But put the hype aside. How are today's organizations actually executing and seeing value from enterprise AI? Dataiku is the platform, democratizing access to data and enabling companies to build their own path to enterprise AI. To make enterprise AI, Dataiku provides one simple user interface for data preparation, data exploration, automated machine learning, model deployment, AI monitoring, and management. Dataiku is built for everyone with robust features for both the code-free and the code-first. From business users and analysts to data scientists and engineers, Dataiku makes working with data faster and smarter. Each company's path to enterprise AI looks different, so Dataiku supports the creation of a spectrum of applications. Whether that means building out a self-serve analytics platform or fully operationalized AI integrated with business processes. No matter what the underlying changes in architecture or advancements in technology, Dataiku remains at the center, the cornerstone of data governance and responsible AI. Dataiku's centralized, controlled, and elastic environment fuels exponential growth in the amount of data, the number of AI projects, and the number of people contributing to such projects. Dataiku, for every industry, every use case, and also for everyone. Discover your path to enterprise AI at dataiku.com.
Free trials can be great, but sometimes it can be hard to remember when they end before you get charged. Thankfully, Eno, your Capital One assistant, is always looking out for you and your money. You'll receive a message when Eno spots a potential new free trial. Tell Eno you want a reminder, and Eno will let you know the day before your free trial ends. You decide whether to cancel your trial before you get charged or to continue with your new subscription.
Hello, everybody. I'm Andrea Renee, your MC for VB Transform today, and welcome back from our break. I hope you enjoyed your lunch if you had some, or the executive roundtable if that's how you spent your time. We have lots more content coming for you this afternoon, but I did want to give you another reminder about the Women in AI Awards happening in just a few hours. So please do make sure to set an alert. It starts at 3:55. But right now, we've got another panel for you. This one is moderated by Suchi Rana, the Senior Director at Headspin, and she'll be leading a discussion on IoT and AI at the edge with panelists Nan Mulchandani, the Acting Director and CTO at the U.S. Department of Defense Joint Artificial Intelligence Center, Stacy Schulman, the CIO of IoT Vision and Retail for Intel, Dr. Josh Sullivan, the head of Modzy, and Anthony Robbins, the Vice President of North American Public Sector at NVIDIA. Also, as a reminder, please get your questions ready and ask them in the Slack Q&A channels, as panelists are going to be answering these questions right after the panel discussion. So you may want to get them in while the session is underway. Enjoy, everybody.
Hello, everyone. Thank you for joining us. My name is Shuchi, and I lead our go-to-market efforts at Headspin. I am honored to be joined by 4 amazing panelists who are industry leaders in their respective domains. We have Stacy Schulman, Vice President and CIO at the IoT Group at Intel, where she focuses on retail, banking, hospitality, and education. Anthony Robbins, Vice President of North America Public Sector at NVIDIA. Josh Sullivan, leader at Modzy, an enterprise AI platform and model marketplace, and also the Executive Vice President at Booz Allen Hamilton and the author of the Mathematical Corporation. We have Nan Mulchandani, Acting Director, Joint Artificial Intelligence Center at the United States Department of Defense. Thank you all for joining us. On this panel, we're going to be talking about the big technology trends in IoT, AI at the edge, and computer vision, and what the convergence of the various technologies means in the business application. Stacy, I'm going to start with you. You talk about normalizing the emerging technologies into various industries. What is a day like in the life of a CIO with that as a goal in mind?
Yeah, it's varied. So we spend my team and I, we spend our time primarily looking at 2 things. One is, what are all the available technologies out there that are emerging? What are the trends of the emerging technologies? And then what are the obstacles that can get in the way of adoption? And what are the problems of the various industries that need to be solved? And then I would say we do a lot of matchmaking between those 2 things. Here's the problem that needs to be solved. Here's the emerging trend. And then we look at, all of the obstacles, and we put a plan together on how to tackle those obstacles so that we can better enable an ecosystem to adopt those emerging trends.
Thank you. Anthony, your current role is it interfaces with the government. What do you think, from the standpoint of a public-private partnership, is required for that to be successful?
Well, in the case of artificial intelligence in, let's say, the U.S. federal government, I think this is a giant team sport. And I think this is one of the most important technology transformations that the U.S. federal government has ever undertaken. And I do not believe that they can take it by themselves. And so we as industry and partners have got to figure out how to intimately understand the mission of government, whether that's to improve citizen services or whatever it might be, and come to the federal government with ideas on, and it could be training, it could be ideas for how they manage their data, it could be ideas on how to build infrastructure or partnerships and solutions and the like. But the net is, this is a team sport, one of the greatest technology transformations of our time, and we have to be really great partners to the U.S. federal government in this journey.
Great, thank you. Josh, tell us about Modzy and perhaps some examples of how you're helping enterprises accelerate the capability to better handle how they're implementing, scaling, and securing, governing AI.
Sure, thanks, Suchi. We know every organization is going to need an AI layer in their tech stack to be competitive and to prevent, shadow AI from popping up all over. And Modzy is the AI layer for the enterprise, a platform to secure and govern and deploy AI models, including your own models and those purchased in the marketplace, maybe from others. And the origin story of Modzy is pretty simple. At Booz Allen, we were seeing AI early adopters struggling with the same problem over and over. Doing machine learning in the lab is relatively easy. getting those models into production and scaling them so you actually get value is incredibly hard. And all the complexities of deployment and model management and security and preventing adversarial probing and data poisoning and all the MLOps takes lots of different skills and lots of different teams, candidly. And developers want to use their own preferred languages and their training frameworks. They don't often speak the same tech language as IT security teams and DevOps teams. And so it's really hard to move from the lab to the enterprise. So we founded Modsy, and we built Modsy in order to make it easier to take trained models into production with features that allow you to run and deploy, govern, and secure AI models at scale. And the real end game here is to actually get value from the deployed models. One of my favorite examples of what you can do by accelerating models into production is from a company in the Midwest. They used a model originally built primarily for a national security use case, one it's publicly available, but it identifies the details of buildings from overhead images. And instead, they used that to scan all the rooftops in Austin, Texas, and they correlated that with other data to find all the available areas for new solar energy panels in the city. So they were able to use machine learning and modeling to identify the whole addressable market for solar in the city. So it's exciting to see that kind of impact about the possibilities, that we can do with trusted AI.
Absolutely. Thank you for sharing that. Nand, you have an amazing background. Having spent majority of your career in the private sector, you moved to the public sector. How do you think you're using AI in your current role to help accelerate and deliver the best outcomes for the DoD?
Well, as part of the Joint AI Center, I think it's baked right into our organization's name. So it's all AI all the time for us now. Obviously the topic that we're going to be discussing here is, IoT and edge compute and other things. And it's very interesting how, in the commercial world, we talk about edge computing and how it relates to sort of what we're doing with the cloud, which is centralizing compute in one end, but then pushing a lot of the compute out to the edge, and then 5G connecting all of this. It's sort of very high bandwidth. What's very interesting is we have a very, very similar challenge here at the DoD. First, to echo the fact that this is a team sport. This is very, very tight integration with the private sector. So those relationships, understanding how obviously the private sector works and being able to bridge that from a relationship standpoint, from a work perspective, has been very useful. But also bringing those analogies over to the DoD. So for instance, the tactical edge work here at the DoD is so incredibly important. Even probably just more complex and important than we would see in the commercial world. I've just had a whole new appreciation for the complexity of operating, at scale at the DoD, where for us, the tactical edge is in working in an environment where it's potentially degraded, denied. A competition in commercial land doesn't get, isn't trying to take down our tactical edge. And so there's a whole other level of complexity. But we are really relying on the private industry and the breakthroughs and the technology platforms that the private industry will obviously enable, that we can consume, but also customize and deploy for our own use case. So it's been a fascinating, move. But both the analogies and the relationships, I think, have been incredibly important and really great.
Wonderful. I think that's a good segue to my next question, which is the panel, as you said, is at the convergence of IoT, edge computing, computer vision, and 5G. What are some of and that is sparking a whole new level of innovation. What is each of you excited about in this space? And what are some of the cool technologies that you've seen, that you're using, some of the use cases? Talk to us about that. And I'll let whoever wants to go first. Stacy, maybe start with you, or none.
Yeah, I'm happy to jump in and sort of continue the thought there, maybe.
Sure.
So for us, one of the big challenges is right now when you take a look at different parts of AI, and I talked about this before, is AI as a technology space is not just a single monolithic thing. It's obviously composed of multiple lines, multiple algorithms, vertical technologies, et cetera. So we think of this as sort of on a case-by-case basis. But let's take the topics that we're trying to discuss here today, things like computer vision, when it comes to sort of the tactical edge and other pieces. right now, when you actually take a big challenge like that, the amount of compute, memory, power, and other things to stuff very, very sophisticated algorithms with large databases onto a chipset or a board that will then fit on, say, a pre-existing commodity drone of some form, or an aircraft, or something, a video camera sitting at some outpost. That we are, that's a very, very big challenge, and it's going to take advances in battery life, in chipsets, in algorithms, in all kinds of things. And again, like I talked about, in degraded and denied environments, how does the tactical edge, the IoT device, connect back in, potentially upload data, download data, new instructions, new updates, and then there's the entire back-end process of how do you qualify that, how do you test it, how do you iterate on those algorithms in the central location, and then download them after being tested or updated. That entire end-to-end process is an incredibly complicated one, and is going to be, I think, if somebody's thinking about starting a company, or our partners on this webcast, if they're investing, which they are, this is really, I think, where the game is going to get played out from an exciting standpoint, the next gen technology here.
Wonderful.
Right. My head went to almost the same place as Nod. I mean, for me, I think running and retraining models at the edge is going to rewrite the next decade ahead of us. Right now, most machine learning models are actually quite large in size. They could be hundreds of gigs in size. They're very fragile to retrain on new similar data. I just saw a proof of concept recently for an encrypted AI model running on encrypted data on an edge device. And if that device were lost or captured, you cannot reverse engineer the model parameters or the details of the training data as easily. And so imagine a complex model running on board a low power GPU chip. I know some of the NVIDIA chips are as low as 7 watts of power inside of a drone, with the ability to retrain on new data while deployed. The example I saw was a crop management drone trained to detect drought and weeds, and it saw a new type of weed, updated the model weights for that class of object only. And then how can it securely redistribute just the model differences to the other drones nearby with a 5G modem? Simple, practical example of what's being built in the lab right now. And of course, I think Nand hit it. Of course, the military applications of encrypted models deployed in potentially hostile areas that may be compromised if left behind. And if you can encrypt them so that they're not of as much value if they get left behind or taken, or an asset gets lost, or even in commercial, a commercial asset on a pipeline gets lost. The huge advances coming, I think, in encrypted models and encrypted data.
Yeah, and then I think some of the
not just in encrypted models and encrypted data, but huge advances on lessening the amount of data that's needed, because that's the other big challenge that we all have to address, is the amount of training data needed, the provenance of that data that goes into that trained model, the privacy requirements that we all should follow and need to follow to maintain the accuracy and the privacy of that data, and just the advances, again, in lessening that data. So I'm seeing some really great advances on reducing the amount of training data needed, in particular for temporal-based models that I'm seeing really good results with.
And then if you think about the workflows or use cases across the federal government, you'll find things like inside the Department of Defense, platform sustainment is a huge opportunity for our federal government. Cybersecurity. There's nobody that's in the field of cybersecurity that doesn't believe that AI is going to play a material role, as well as with healthcare. And for example, the work of radiologists, right? So if you say healthcare, platform sustainment, cybersecurity, just to name a few, and then throw in for good measure, autonomous systems and robotics. Some of the biggest use cases across the entire federal government, where they spend enormous amounts of money and have critical mission challenges, will be advantaged by the advancement of artificial intelligence, especially to the extent that we can help the Department of Defense and civilian agencies develop and then get into operations. So there's a great opportunity here for all.
Wonderful. And I think Stacy touched upon the challenges. That would have been my next question. What, with any new emerging technology, there comes new challenges with how do you scale it, and from a privacy security standpoint as well. What do you think are the challenges that you, in your particular use cases, maybe are faced with, or things that people should be aware of? So if we can talk about that.
Yeah, data acquisition.
Josh?
Amount
Yes.
of data needed for that. Securing those models. I think Josh talked about that earlier. You know, once you get that trained model out, once it gets out to the edge, you need to make sure that's secured. Federated learning out at the edges, and the full end-to-end solution for all of that, from all the way from down at the edge and the device at the edge up to the cloud. Tying all that together in the pipeline for all of that is the biggest challenge that we're seeing right now.
Mm-hmm.
Yeah, Suchi, I think I agree with a lot of what Stacey said. You know, Gartner report just came out and said #1 barrier to AI implementation was security and privacy. I think rightly so, but maybe I'll take it in a different direction. I think about it a little bit differently than I think most people. For me, deploying an AI model in your IT environment is an entirely new attack vector. You know, I've seen a model working correctly that can identify tanks and other military equipment be fooled into seeing a school bus because someone sent poison data into the model. I've seen a model that is designed to predict someone jumping over a fence be totally blinded and miss someone because of carefully crafted pixels that were in the video stream. You know, and that's just for models that are already trained and running right at inference time. There's also security attacks that can slightly alter training data sets with a little bit of misinformation to cause specific predictions to go wrong. In our Modsy Labs team, we were working with a commercial data set that detects malware, and the team was able to launch a poison frog attack, which is basically where you implant a small change in training data in a very engineered way, so that after it's trained, this AI model would not detect a certain string in a file. It would think it was benign, but really it was a malware marker. And so, you know, I think there's a conversation we're having about ethics, like facial recognition and the role of technology and privacy and law enforcement. And those are crucial conversations and the right ones to have as a nation. But I also think, I don't want us to ignore what I think is an equally profound conversation around adversarial defense and the ability to hack AI models with poison data and attempts to, you know, influence their predictions, because we're going to keep relying more and more on these machine predictions, and you're going to create an outsized impact that becomes possible by hijacking just a few bits of training data to change an entire outcome. You know, so I don't want to bolt the front door and leave the entire back door propped open.
Yeah, let me jump in on that point, because so there's actually a couple of things in there. You talked about AI ethics. You talked about you know, obviously you know, making sure that there is transparency. Obviously, all of the AI ethics issues around training data. So the thing that's interesting to us is, obviously we are worried about things like adversarial attacks against data, the models, et cetera. But even more important than that is the training and eval side of this, because you know, when you think of sort of an oxymoron like mass customization, think of a single system that's deployed worldwide globally. Now think of a situation where you've got a training data set that has been built, you know, obviously we've trained the model on a particular training data set, but that data set is not representative of, say, global terrain or global information, or even things like faces. So when you think of the diversity of, you know, obviously humankind out there, if you're doing something like facial recognition or something, the training data set from a testing and representative perspective is so important. So there is the adversarial aspect to it, but there's also the test and eval side to make sure that we can guarantee that a single platform that we deploy globally, worldwide, across sort of a uniform set of, say, you know, our services, can perform well across all of these. And what we're finding, and all of what we would agree, is we're still in the early days of AI, where the ability for a single data set to perform in multiple different environments and applications is incredibly important. So there's still a lot of research work to be done here, including the fact that what Stacey talked about in terms of the security of it, both at the tactical edge, on the transport layer, and then on the back-end cloud side, in terms of securing the data, securing the model, securing the transport, securing the endpoint, so that if we were to fall into hands, reverse engineering it, and then actually not only attacking the data, but being able to change the situation or environment that a tactical edge system is actually sensing, and being able to fool that. These are all incredibly important things that are very, very hard to pull together. But again, that's, I guess, what we're getting paid to do here. So that's all the stuff that we have to integrate together to make happen.
Yeah, it sounds like a simple task, right? So, and then I would just add, right? So there's work going on relative to AI principles between nations. So that work is going on. There's AI standards work that's occurring at NIST, as a part of the executive order and going across the federal government. There's really interesting work that has occurred and continues to occur on AI ethics. It was originally launched by the Defense Innovation Board and has then been picked up by Nan and team at the JAIC on behalf of the Department of Defense. And then, of course, some of the panelists mentioned security. But something also that's really important to recognize, because we face this exact same thing when we are dealing with the cloud adoption in the federal government. And just the simple fact of change and transformation leadership, right? That's a big deal. So if we agree that this is one of the greatest technology transformations that any of us have ever, stared into, then what this is about a lot is change and transformation. The Department of Defense has been working on artificial intelligence since 1957. We had major breakthroughs in artificial intelligence going back to kind of 2012, if you will. And the progress, the positive progress that's been made with respect to deploying artificial intelligence has been nothing short of stunning, right? And so as we at NVIDIA engage with customers in the federal government, they understand, they're the largest producers and consumers of data in the world. They've got to pay careful attention to standards and ethics, and they got to figure out how to get it into operations, and they got to rationalize this data and this infrastructure. But they often say, how do they get started? And sometimes that how do they get started, is fraught with change and transformation leadership. It's a very important skill, and sometimes it doesn't have a lot to do with technology, but it has a lot to getting the government to intersect with large transformations, the likes of which artificial intelligence is inspiring.
Mm-hmm, mm-hmm. Thank you. Yeah, no, thanks for sharing that. And my next question, I guess some of you touched upon startups, innovation. What do you think, what role does open ecosystem strategy plays in the digital transformation, whether it's the government or large enterprises? It's like build versus partner. And how are each of you partnering with the startup ecosystem? I'm sure there's a ton of entrepreneurs in the audience that can truly leverage. That can benefit from. Yeah.
Well, I'll take a shot at it. I've seen kind of both sides of it. I've helped build and sell 4 companies in the enterprise infrastructure and cybersecurity space. So I've seen the startup side of it, and then I've seen exactly, obviously, the one of the world's largest customers now being part of Team DoD. The great news is, from the outside, there seems to be this idea that the DoD, the Pentagon, has a very hard time liaising and working with tech startups, and even large tech companies. That very well may be true, sort of, in the past or others, but there is a huge amount of change going on in the DoD in terms of partnering and working directly with tech companies, small and big. I mean, we've got projects going on. The JAIC has projects going on with 7-person startups out in the Bay Area, to obviously direct work with actually every vendor on this call. I mean, Booz Allen Hamilton with our joint warfighting operations, obviously NVIDIA, an incredibly key partner, and Intel on the hardware side, and even on the AI side. So, the ability for us to have those direct conversations, direct work with them, the environment has never been better. And there's huge changes going on in terms of how acquisition gets done, how we actually acquire, procure, and deliver software inside the DoD, from a DevOps, from a cloud perspective, and other things. So, I don't want to put too much of a entrepreneur's sunny, optimistic startup spin on it, but it is actually, it is nowhere near what people think it is. It's a matter of, I think the piece that to me has actually been the biggest sort of thing over the past year I've been here is, the DoD is coming to grips with the fact that, and it's a sort of obviously a phrase in the industry that we use a lot, is, software and hardware is eating the world. The stuff that we do in the tech industry is transforming every single business in every area in the world, in the economy. And the Defense Department is not immune to those secular forces. it's one of the biggest, transformations that has to happen because we are the biggest, sort of one of the biggest organizations. But it is absolutely happening. This realization that I call the sort of hardware-centric design point to moving to a software-defined design point is a realization that's happening all the way from Secretary of Defense all the way down to our service members, who the next generation of our digital natives. They come in, they understand how the world works. They're not insular and immune from that. And AI and consuming software the way they do and how we build it is just a natural part of how they're operating. So I'm very, very positive and excited about the opportunity for us to do this. But we're not going to build software here. Our charter is to work with our commercial partners and bring that software in and enable it. And that's really the challenge that we're facing. But I think we'll get through it.
Yeah, and on that point, I think part of the, to deal with the open solution, open ecosystem point, I feel strongly that the pace of innovation in AI and the software is so fast that a single company just simply can't do it all. So the days of monolithic proprietary systems, I think, are over when it comes to this stuff. And we really do have to figure out how to build best-in-class ecosystems around this, and open solutions with open ecosystems, I think, are the only things that are going to actually keep pace with innovation today.
Yeah, and I think there's a lot of areas where the federal government is doing great work, right? I mean, I think what we've seen in the JAIC by themselves, I think there's some fantastic work that's going on there. The Defense Innovation Unit, in addition to the work of the Defense Innovation Board, I think they've added some really great innovation perspective. I think the work the way that the government's trying to connect to Silicon Valley, Austin and Boston, for example. We at NVIDIA have this large inception program where we work with thousands of companies that are trying to figure out how to get into commercial and government markets. And we help coach, guide, and mentor them for that. But this is going to be one where it takes a village, because the government's going to have to work with universities. You see what the Army has done with Carnegie Mellon, or the Air Force is doing with MIT. And it goes further than that, because to get AI into operations at scale, it is going to require innovation work to occur by the large contractors, whether they're the defense contractors or large contractors that, like Booz Allen, that are really adding a ton of value inside the enterprise. So we're going to have the large contractors, the innovation community, higher ed, all working together to bring the promise of artificial intelligence to the federal marketplace with leverage and scale.
Yeah, I would just add on, agree with a lot of that. I don't think anyone can do this alone. The ecosystem, I think Stacey said, the ecosystems that allow integrations and our open architectures, those naturally accelerate solutions. I think we all know that. I am seeing a few interesting startups. They want to build like AI end-to-end solutions. I mean, have you ever seen an end-to-end solution work? No. It's like a recipe for hurt and disappointment. No, right? Open architecture solutions that allow your teams to use the tools and languages and frameworks that make sense and integrate into your tech stack and remain extensible into your future is paramount. I don't think a lot of people understand, if you're going to really use AI at scale, it's going to affect every layer of your tech stack, your infrastructure, your CPU, your GPU, your other chipsets. Is it in the cloud or on-prem or at the edge? Your deployment mechanisms, every bit of that is affected, and you have to have an ecosystem that allows lots of integrations for this to work at scale.
Yeah, and I would just add, just to dovetail on that point, the last point I'd make is, as a consumer of, the software and hardware that we do, having this layered approach and open standards approach is something incredibly important to us, because having monolithic technology stacks that don't move at different sort of paces and angle, timelines and cost structures, just isn't going to work for us long term. We consume so much custom software that we need to be able to swap out or ride the technology curve on each of those different modules or layers of the stack, as opposed to just being captive to a single technology commoditization curve that may occur at a vendor's pace. And so that is so important to us. I can't overemphasize that aspect of sort of taking open standards and compartmentalizing and layered approach to building and consuming software.
Great, thanks. Well, as much as I'd love to continue the conversation, we're at time. So I have one last question that I'd like to wrap up with. We live in unprecedented times, and almost each one of us, everyone's being impacted by COVID. And what do you think the role of the government and corporations will be in the post-COVID recovery process? And how do you think it'll accelerate that? Just if you want to each take a minute quickly.
Well, listen, I'm hopeful. I'm going to be an optimist here. We've had galvanizing moments in the past, Industrial Revolution and World War II. I'm hoping that on the other side of this, we can have a galvanizing moment that builds a foundation, governance and interoperability that actually speeds up and accelerates the adoption of this responsibly, of this kind of technology across the enterprise, and that we find ways to help relieve some of the limited and constrained resources that we have, and that AI can actually contribute to a level of personalization of citizen services and funding, new job creation and whole new economies of the future. So that's my hope.
Thank you.
I mean, putting on my DoD hat, I'll just add that, as you know, I mean, obviously the military support to civilian authorities is a very, very key role that the DoD plays. Our job, as the Jake, but also putting on my DoD hat, is to make sure that support, this military support to civilian authorities, such as NORTHCOM or the National Guard, that we arm them with the best technology and capabilities that we possibly can. When this this crisis hit, my predecessor, old boss General Shanahan, we immediately sat down and talked about how we can bring very quickly AI-enabled capabilities to NORTHCOM and to the National Guard for doing things like predictive analytics around supply chain data and things. Just you look at the lines of the food banks that the news was reporting. How can we actually directly apply capabilities to this? And we use this crisis as an opportunity to actually drive this change. And now NORTHCOM and NGB are using Jake developed software along with our commercial partners who built 45 different data sources and multiple models on top of it to do predictive analytics. This was a huge win for the DoD, for the Guard, and then as a way of delivering better services to our citizenry. So we feel very excited and proud to have contributed to that.
Thank you.
Yeah, and I think for big companies, I think it's time for the big tech companies. This crisis is accelerating the adoption of tech unlike anything I've ever seen before. And it's time for us tech companies to stand up and make sure that we provide the right technology, the right ecosystem with the right people without getting hung up on who's getting credit for what. And we just need to go and solve the problem. And then we can focus on sorting out credit at another day. But right now, I think we need to be responsible and deliver technology and deliver great solutions. I know Intel, we opened up our patent portfolio for anybody fighting the COVID crisis. And we intend to do more things like that to be a responsible citizen at this moment in particular.
Thank you. Anthony, any thoughts?
Yeah, global challenges like COVID-19 bring to the fore, I believe, some of the best of humanity. And I think you're seeing some of that across the federal government and cross-agency work. So the government, whether it's inside the Jake, as Nan talked about, or as across the federal government where they're trying to bring HPC assets and scientists and resources to go try to figure out what a vaccine might look like or how to address something like this, a global pandemic. We as a nation have solved some exceptionally challenging things in the past. And I have no doubt that COVID-19, when we look back at it, will be a defining moment where perhaps we saw expressed a greater sense of teamwork for global good. And I think we'll see that in this case.
Great. Thank you all. Thank you for sharing such valuable insights. Really appreciate your time. This brings us to the end. And thank you again for being here.
Thank you for having us.
Thank you.
Thank you.
All righty. Well, I just wanted to mention that Nan will not be able to join us, unfortunately, for the Q&A part. But now I do see a few questions that have come in from the audience. All right, let's begin. I have a question from Sydney Friedberg. How do you write an AI model that doesn't require vast amounts of data? How do we move from crunching 10 million manually tagged photos of cats to identifying T-72 tanks in the forest? So
Hey,
I guess the
I'll
question was
start. I
around
think it's a great
meaningful.
question. Thank you. Yeah, thanks for the
Mhm.
question. Listen, I think there's all kinds of different architectures for models that are really important. There are models that work on small amounts of data. And then there are others that if you really want a performance metrics and you want an accuracy on all the subgroups that you're looking at and the different types of data, that you really want a large sample set. And so it really does depend on the architecture of the problem that you're trying to solve, of the technical solution that you're trying to solve. And so I don't think every model requires a lot of data, but it is true that a lot of large neural nets right now have huge weight files in them. And there's a lot of research happening by a lot of big tech companies, including all of us here, to look at how do you prune down the size of some of these large networks so that you can actually use them at the edge in a little bit different way than is possible today.
Yeah, and Josh, I think it relates to the use case or the problem that you want to go take on. For example, look at what our children are doing in schools and the amazing work that they're doing with robotics. So they're doing some really interesting AI work in the area of robotics with really small amounts of data. Then you go to the other end of the spectrum and you look at what's going on in the world with respect to autonomous systems. Massive amount of data that's being consumed or used to train models there. So there's a wide spectrum. Your use case really is going to determine the amount of data that you're going to need at this point.
Yeah, I agree with all that. We're seeing some really good results with spatiotemporal learning, and that reducing the size of data that you need for your models. So I'd say you're probably going to start hearing a lot more about that soon.
Great. Our next question is, it's actually for none, but in case any of you want to take it, it's how much government regulation do you think there should be in AI? And what, in your opinion, is the right balance? And it refers to the Algorithmic Accountability Act of 2019. So if anyone of you want to take it, or...
Well, I mean, I could take a shot at it. I'm not that I'm going to be a sit-in for non at all, but, and we mentioned earlier that nations are trying to figure out how to work collaboratively, and they've already there's already been established, I think it's across like 41 nations now, a set of AI principles that are going to guide the work that nations will do from a research and development standpoint. And deployment standpoint with artificial intelligence. The U.S. federal government cares a lot with respect to standards and ethics, and they'll play a role in standards around artificial intelligence as per the executive order that was signed by the president in February of 2018. So the federal government will play a role in standards. They will play a role in setting policy. They're already playing a role with respect to the role of ethics in the Department of Defense. Yet they have to rely on the work across educational institutions, commercial companies, and other nations. And so, we mentioned earlier, this is a giant team sport. And at this stage of the technology adoption curve, that will work. The government will have a big role. So will commercial industries and other nations.
Yeah. On that, I don't want to say how much regulation is needed, but what I can say is what would be a disaster is that every country and in the U.S. every state decides to regulate it separately. That would be an impossible situation. So we need enough to keep that from happening.
Yeah, my only thought on the topic, I agree what the others have said. If you think about the national safety standards that we put on ourselves, having a national safety standards, especially around bias, and if you look at what's happening in society, even right now, national safety standards for machine learning, much like we do for highway safety, for food products, would certainly be a powerful motivator for us to even create awareness of some of the really complex bias topics. And start making the right changes we need to, because this is an acceleration of using this kind of technology. We need to think about, in my mind, safety standards is the place to start.
Great. Okay, the next one is from Mukesh. On-device can be like mobile devices or drones. And it looks like GPUs are addressing more of the mobile market, and FPGAs are kind of leaning towards robotics. Do you agree or disagree? And how do you see different hardware shaping the AI industry and future of startups in this space?
Well, Stacey, would you like to? I'm happy to take a shot at that one if you'd like me to. Stacey, how about I start and you can go. So, listen, the federal government and commercial industries have used FPGAs, and they've used CPUs and they use GPUs. All of them play a role in the work that's going on with respect to artificial intelligence. In the case of our GPUs from NVIDIA, we've worked really hard to deal with size, weight, and power. We've worked really hard on the programming environment, we call CUDA, and then we've worked on packaging so that we can make this available, kind of at the edge and in data centers and in the cloud. One of the challenges to the systems that we have built across the federal government over time is, everything was custom built. And we think for the first time with respect to GPUs and CUDA, we've got a common development platform that can serve the entire federal government, whether that's citizen services, or the Department of Defense, from very low end, very low power envelopes to really big supercomputers, whether you're in the cloud or you're dealing with robotics and autonomous systems and the like. And I'm sure Stacey has something to add as well.
Absolutely. Yeah, I mean, I don't think there's a magic bullet. I don't think that there's a one piece of hardware that's appropriate in all cases. And I do think it depends on your use case, your power requirements, and so much more. I would say the thing that we are seeing is that there is the need to be able to take that computer vision data and combine it with other data in real time. And so if that is in a use case, then it does limit the type of hardware that you can have. And so I just wanted to add that context in there, because if we focus purely on just the vision piece of it, then it definitely leads you into one way of doing it. Now on a drone, how much data do you need on that drone that you need to blend with the vision data? I don't know. Again, depends on the use case, maybe not as much. But when we're talking about autonomous stores or autonomous systems, there is a substantial amount of data that needs to be blended with that sensor data. And so that of course would be a different hardware footprint.
Yeah, at MODSI, what we're seeing from the field with customers doing all kinds of different use cases is just like model architecture really depends on the problem you're trying to solve. For us, CPUs are very prevalent. GPUs, you lock the entire GPU when you're using it, and you do CUDA acceleration, things like that. They're for more specialized use cases, but we use them all the time. And then FPGAs are even more specialized. So in kind of the hierarchy of specialization, and then you pick the right hardware architecture that matches the software and model architecture that you need to execute.
Awesome, thanks. We have another question that came in from Saloni Podar. How do you balance domains that are very little labeled data versus domains which are very large amounts of labeled data, and the growing number of domains for an existing task, which adds to the complexity of managing models?
Yeah, this is Josh. Let me offer a thought, because we kind of talked a little bit about that with the first question. So let me maybe take it in a little bit different direction. I think here's what I see by far when it comes to data volumes and selection is the bias that we introduce into things. And I think we have to accept a premise that we all know people are biased and our data is biased, and how we use that data is likely biased. And I think if we're going to think about a better future that involves data architectures and model architectures and data volumes and the different domains that we pull from, we have to think about how we're going to fight implicit and explicit societal biases. And I would offer two ideas. First, this is to reject the idea of black box models and publish bias mitigation metrics for models. And so there are three main types of those, right? There are fairness metrics, where you look at the selection and error rates of all the subgroups, and you check for bias amplification. There are standard performance metrics, and lots of us, we know what those are, right? False positive rates, accuracy, precision, recall. But you have to look at it for each of the subgroups in your data separately. And you have to make notice of differences between those subgroups. And then the third main topic is the generalized entropy metrics, which really look at fairness in groups and individuals. And so reject the idea of black box models. And if you start there with the outcome that you're driving, that will, I think, help on data selection and the philosophy, how you select data, the volume of it, and how many different domains you want to put into one model architecture. And then the second is, I just think we have to have a re-education on bias in AI, right? When everyone understands the problem, it makes solving it a lot easier, back to the conversation we were having about national safety standards.
Mm-hmm. Cool. Anyone else like to add anything, or I can move on to the next one? All right. The next question is for Intel and Modzy in particular. It says, can you talk about some of the best use cases of AI, some of the best uses of AI to make technology more secure? To what extent can AI eliminate hackers and ensure better cybersecurity? And Anthony, feel free to chime in as well. But Stacy, you want to go
Josh, do you want to
first?
start off and I'll jump in?
Yeah, I'm happy to, Stacey. Listen, I think we said this, a little bit earlier to one of the other questions is, this is a whole new attack surface. And so I think we have to be thinking about adversarial defense and defense in depth. This is a whole new way of attacking the training data that you have, that the performance of your models and the predictions that they get. And I think when we have that awareness, we can start to apply a defense in depth of security postures. But for me, and I think for Modzy, the whole science that we're collectively, all of us, researching and are publishing in peer-reviewed papers is all about adversarial defense and applying a cybersecurity approach to AI models in a way that really has never been done before. And as an industry, we all need to understand really what that looks like and how to apply it.
Mm-hmm.
Yeah, I'm not a cybersecurity expert, so I can't speak much about that. But in terms of the AI models that I'm seeing that deal with security, I can go into physical security. So there's a lot of improvements in that space of being able to automate the physical security of a location, or even physical security of a model in a box itself. And so that, I just wanted to add that angle into.
Yeah, and I would just add that this is also another area where the federal government over time has done extraordinary work. And then today, whether it's the intelligence community, the Department of Defense, or civilian agencies, they're doing a lot of work relative to the security aspect of the development of artificial intelligence, the development and deployment of artificial intelligence. And we can talk, I think there's going to be an offline chat piece of this. We could talk through that and answer about the work that the government's doing here, because it's like the work they're doing in ethics and standards and the AI principles. There's significant work here.
All right, great. Well, we have 10 seconds left, so I guess it's time to move to the Zoom chat. But thank you all for taking the time. Really appreciate all your insights and all the valuable feedback, and appreciate you taking the time to join us. Take care.
And thank you to all of the panelists who joined us for that last presentation. As Suchi mentioned, they will be going to the offstage Q&A room if you have any further questions. But now I'd like to welcome back for another presentation, Kunle Olukotan, the Chief Technologist and co-founder of Samba Nova and Cadence Design Professor of Electrical Engineering and Computer Science at Stanford, who will talk about accelerating software 2.0 for IoT and Edge. And this session will be immediately followed by another main stage Q&A. So if you do have questions, be sure to drop them in the Q&A channel on Slack.
Hello, my name is Kunle Olukotin, and I'm the co-founder and chief technologist of Samba Systems. And the title of my talk today is Accelerating Software 2.0 for IoT and the Edge. As we know, there's been a huge proliferation of IoT devices. The projection is 64 billion IoT devices by 2025. There are a range of different things that you can do with IoT. You can have cameras for security and for monitoring traffic. You can have sensors for civil built infrastructure. You have for power lines, for roads, for bridges. And all of these devices generate a lot of data that needs to be collected, mined, and interpreted to make better decisions, right? And so typically this is done using, today, using models, using AI models to interpret the IO data, which necessarily means using machine learning. So machine learning is a new way of developing applications, and the widespread use of machine learning in the form of neural networks and deep learning has the potential to fundamentally change the way that we develop software. So if you think about traditional ways of developing software, often called software 1.0, the code is written using some sort of high-level language like C++ or Java, and the process of developing the software is to start with a problem, decompose the problem into a set of components, devise algorithms for those components, and then build the components back into a system. Contrast that with software 2.0, which was coined by Andrej Karpathy, or the term was coined by Andrej Karpathy, and here the idea is that the programmer input is training data. And the goal is to generate the weights of the neural network by some sort of learning algorithm. And of course, doing this means that the training data will determine the sets of models that get generated. So the use of software 2.0 has been, and machine learning has been used to do solve a number of hard problems, such as language translation, image recognition, medical images, images from cameras and images on the web, and also robot control. As an example of the benefits of software 2.0, Google shrank its code for language translation from 500,000 lines of imperative code to 500 lines of data flow. And by doing this, of course, you got a number of benefits, right? So that you got, of course, fewer lines of code to actually write, but other also benefits in the deployment. The new model new models could be deployed with fewer amounts of memory and in a ways that were more predictable runtime. And so the goal of Samba Systems is to develop the next generation of systems for software 2.0. My co-founders are the CEO, Rodrigo Liang, who's had a long career managing huge hardware projects both at Sun and Oracle, and is an expert in VLSI design. And my other co-founder is Chris Ray, who is a professor at Stanford and is well known in the fields of machine learning and databases, and is also a certified MacArthur Genius. And so thinking about how to develop systems for software 2.0, two computing trends, the whole notion of developing these systems is driven by two computing trends. The first is the fact that multi-core approaches to computer design are running out of steam. It doesn't matter whether these cores are large cores, as you typically get with Intel or AMD processors, or more streamlined high throughput cores, as you might see in a GPU. Fundamentally, the cores are inefficient, and putting multiple cores together means that you have even more inefficiency. And so what we need, especially at the point of time that we're now in with Moore's law the improvements of Moore's law declining, we need architectures that are fundamentally more efficient. So the other big trend is a convergence of training and inference, right? So typically today, the types of accelerators used for machine learning training are different from the sorts of computation environments that you use to run inference. And by bringing them together, you get a lot of benefits. So these two computing trends are driving the design of the next generation of systems for machine learning and software 2.0. As I said, software 2.0 is all about data flow. And the way that you describe algorithms and applications in software 2.0 is by using these high-level frameworks that machine learning application developers use, like PyTorch and TensorFlow. And these fundamentally produce a data flow graph that represents your application. And the elements of the data flow graph are the core kernels of the machine learning algorithms, such as convolutions and matrix multiplies and norm batch normalization kernels. It turns out that you can take these data flow graphs from machine learning applications and convert them into a form that is better for high performance execution. This we call parallel patterns. And parallel patterns can be thought of as a high-level representation of both the computation and the data access patterns in your algorithms. And we've seen that you can take these parallel patterns and optimize them for higher computational efficiency. So what we have done in SambaNova is take this fundamental execution mode called parallel patterns and cast and accelerate it in hardware. So we've got a native way of executing parallel patterns in hardware using what we call a reconfigurable data flow architecture. So the reconfigurable data flow architecture is composed of both compute units called pattern compute units and memory units called pattern memory units. And these can be composed together with an on-chip dynamic network to support the computation and data flow requirements of the particular machine learning application. So as an example of how this looks, you can look at the data flow representation that I showed earlier, and I show it mapped spatially onto an array of reconfigurable computational memory units that would exist inside the SambaNova chip. And this provides very efficient computation and very high bandwidth communication between the different kernel elements. And all of the communication stays on chip and is supported by the on-chip network. And so when you're thinking about designing a high performance system, there are two key things that you've got to balance: computation and communication in order to get high performance. And traditional architectures like CPU and GPUs allow you to program the computation, but they don't really allow you to program the communication, the data flow. But by using a reconfigurable data flow architecture that supports both of these elements of high performance computation efficiently, we can get improvements in both performance and flexibility, and we can make possible the sorts of applications that were not possible before. We call these kinds of transitions 0 to 1 applications. You weren't able to do it with the conventional architecture, the conventional computational infrastructure, but with SambaNova, you can. So today, if you look at the machine learning pipeline, what you see is different platforms, software and hardware platforms, being used for training and inference. Typically training, both training from scratch that we call de novo training, and training in which you repurpose an existing model, is done with GPUs because you use large batches of data that are efficiently processed by GPUs. But inference, because you only are inferencing one example at a time, this doesn't work very efficiently on GPUs, and so you typically do this using a CPU. And so what has to happen is you've got to revalidate the model that you trained on a GPU and in order to run it on the CPU. And furthermore, you don't have the ability to modify the model by retraining on the CPU because the CPU does not support training very efficiently. So this sort of difference between training and inference is particularly a problem if you want to continuously do IoT stream processing. So this is something that I'm doing at Stanford University with my colleagues Keyvan Fatalian and Chris Ray. And what you want to do here is, given a stream of data from some IoT device like a camera, you want to continuously adapt your model to better model and interpret the data that's being sensed by the device, right? So the data is changing, and also potentially you want to change the decisions that you're making, and you want to continuously adapt, right? So as an example, let's look at what might happen in an environment in which you have a camera, right? So if you look at the traditional ways of doing camera processing, you start with images on the internet, images of cats and dogs and all sorts of other things. And your goal is to come up with a set of models that give you high classification accuracy among a large number of categories. But contrast that with a situation where you've got some IoT camera probably monitoring an intersection somewhere in the country. But here you're likely to see all kinds of vehicles, trucks and cars and maybe motorcycles, but you're unlikely to see a giraffe. You're not likely to see a lion. And so there are lots of things that you won't see. But what you will see is a shift in the type of images that you see on the camera, right? So here's an example looking at an intersection, and you've got different weather conditions, right? Sometimes it's dry pavement, sometimes there's rain, sometimes there's snow, sometimes there are people walking around. And so you get different sets of images, and you need to be able to have a model that can deal with this so-called distribution shift, right? So weather, time of day, types of vehicles, etc. And so, a good example of where you see this would, of course, be with intersections where you get this different sets of data, and you need models that are capable of dealing with that. And so the solution that potentially works very well is this idea of continuous model adaptation, right? So here you're trying to take very tiny, efficient models that can retain high accuracy for complex tasks, but you're going to continuously adapt them to specialize to the contents of the video streams. So the way to think about this is that you don't want to worry about coming up with a model that can handle everything, all situations that you might actually see. And that's sort of course, we would require a training set that covers all the situations that the camera might potentially see. What you want to do is to have a model that can quickly adapt to the scene and the data at hand. So as an example task, let's look at semantic segmentation, where you're trying to detect people or animals or objects and distinguish or segment that object from the background, right? So you see a lot of examples here of people, animals, or cars, and then being distinguished from their background. Okay, and so the way to do that using this continuous adaptation model is a just-in-time model, right? And so the idea is you come up with a small model, a deep neural network that can be evaluated and trained quickly, and then you have a much larger model that you train with a huge amount of training examples. We're going to call this the teacher model. So you've got a teacher model that knows a lot of things about how to model a large, very complex scene, and you've got a much simpler student model. And the idea is that periodically you retrain the the student model using recent data, and you use the teacher model as the supervision, which tells you how well the student model is doing. So let's look at an example of how this works in segmenting some table tennis players in a tournament, right? And so you see on the left here, we have the teacher model, which is this regional convolutional neural network. And then on the right, we have this just-in-time network, which is this much smaller model, which is periodically retrained using information from the teacher model. And you see that basically they track. There are times when the woman walked over to the judge where things didn't track as closely. But if you look on both sides, you see that fundamentally the segmentation is working just as well on the right as it is on the left. Okay, and so you see, so this approach really does work, and what you get is a tremendous improvement in performance, right? A 20x improvement in performance, and this includes the time that it takes to do the periodic retraining. So what are the implications of this continuous adaptation? Well, so the key thing that it does is it places these extra demands on the deployment platform, right? So you need the flexibility to execute inference very efficiently, and you need to be able to do the training online. So anything that, any accelerator that only does training or efficiently, but doesn't do inference very efficiently, won't work in this environment. Also, you need to be able to handle the small student model efficiently, and also the large teacher model, and run that efficiently. So a accelerator GPU that can run the large teacher model very efficiently, but can't run the student model very efficiently, won't work well in this instance. And then you also have to have the capability of being able to dynamically move between one model where you are doing inference and another where you're doing training, and be able to do that in real time and decide when you need to do to run the teacher in order to do the supervision. So SambaNova, with its ability to do large batch training very efficiently and small batch or single instance inference, gives you this capability. So what we can do is this convergence of training from data center to the edge, right? So in the data center, you can train the large model, and you can train the large model from scratch. You can deal with huge amounts of data. You can get very efficient training, and you can build models with very high accuracy. And then you can deploy this model with lightweight, continuous adaptive models like JITNet, and you can continuously retrain the model to take advantage of the specific environment, and to adapt to the data that is coming from the IoT device, such as the with the camera input. And so, to conclude, then, you know, SambaNova Systems is in line and supports these two computing trends. It provides a much more efficient computational structure substrate for doing both inference and training, and is much more efficient than conventional architectures. And it supports this convergence that allows you to implement the sorts of capabilities that are required for the future of IoT and edge model development and computational requirements. So thank you.
Hi, everyone, and welcome back. And joining me live now is Kunle. How are you doing today, Kunle?
Very well, Andrea.
Excellent. I just want to remind everybody watching that if you have questions for him, you may drop them in the Q&A channel in Slack. But I was watching your presentation, and I'm going to be honest, most of it went right over my head. And I think it's really fascinating how you take something that is, in depth of a topic as reconfigurable data architecture and make it, something that students can approach and understand. And when you meet your students, do a lot of them come in with a little bit of background, or do you think that most of them come in kind of blank slate?
Well, they usually, come in with background depending on what courses I'm teaching, right? If I'm teaching an introductory course, then I won't assume that the students know much, and we'll start from the basics and we'll build up. But if I'm teaching an advanced course would cover something like reconfigurable data flow architectures. I'd expect them to come with a fair amount of knowledge about both, computer design, about applications, about how to analyze the performance of applications and understand, how the memory characteristics and what we call parallelism characteristics can affect performance, right? So, yeah, it all depends. And students, I teach students at both the undergraduate level, where when I teach the introductory courses, and of course that I also have a group of PhD students who sometimes or oftentimes teach me stuff, right?
Oh, that's lovely to hear. And of course, it makes sense that the introductory level, has a much different, educational experience than your more senior students have. But I do have a question here from Slack from Nicole. And Nicole asks, how are ways in which hardware helps make AI more accurate and explainable?
More accurate and explainable. Well, I mean, so explainability has a lot to do with the algorithms, and if you look at kind of the evolution of machine learning, right? But the whole idea of training neural networks is a very old idea, 50 years old or more, and the whole idea of kind of using what's called backpropagation to actually train these networks is something that's been around since the 80s. So what's changed? So what's changed is the ability to train these models with much more data, right? So you can train a more complex model that has much higher accuracy, right? But that was only possible because we had much more computer performance to actually crunch the data that was and crunch, do the numerical computations, floating point computations required to train these models. And so when it comes to accuracy, these two things go hand in hand: bigger data sets, more complex models, and much more computation. And so in terms of explainability, again, that also is something that is enhanced with more computation, because that allows you to kind of run these algorithms that potentially can give you some idea of sort of what's going on with the different components of the model, and work out those algorithms more effectively. Because whenever you try and do something that gives you more insight, typically that's going to take more computation, right? And in order to make this computation feasible, you're going to need more architecture capability. I mean, it's already the case that training these large models can take weeks, right? So more and more computation is kind of the key. Yeah.
Another question for you. So you're a Stanford professor. What are your thoughts about AI being a specialization in universities? Is enough being done to train the future workforce in a scalable way?
That's a very good question. I think, one could, argue today that there aren't enough qualified, capable machine learning, data science people to satisfy the needs of the U.S. economy. But it is the case that lots of people are at Stanford are flocking to CS, and so CS is the most popular major in the school, in the university, and it's true among men and women that CS is the most popular, and it's also bigger than the next three majors combined, the next most three popular majors combined, right? But what I often joke about CS is that CS is to the rest of the university as machine learning is to CS, right? So everybody who's interested in majoring CS is really moving towards AI and machine learning, and the rest of the CS is sort of not as popular. So students are definitely voting with their feet, and I would contend, being a systems guy, that as I just explained, the importance of hardware in this whole AI ML revolution. But it's certainly the case that students recognize the importance of AI and ML and are taking those classes and getting trained.
Well, it's certainly an exciting field, one that I wish was around when I was in college, and I'm sure it was. I just didn't know about it or didn't know how to find it. So it's great that there are people like you that are speaking at things like VB Transform, and hopefully some students are out there watching and are getting inspired to keep learning. So thank you so much for your time today. And if you have any further questions for all of the people watching, Kunle will be taking additional questions in the offstage Q&A room. So enjoy the rest of your day.
Thank you, Andrea.
And now we're going to take one last final break in case you need one more coffee hit, or maybe you just want to take a quick stretch. Or, of course, you can always use this time to reach out to someone for virtual networking in the VB Transform Slack workspace. During the break, though, I want to remind you that another exclusive executive forum breakout will begin on how industrial companies are making products faster, better, and cheaper, leveraging AI technologies such as robotics, computer vision, and IoT at the edge. It's moderated by Seth Colliner, the editorial director at VentureBeat. And please check your calendar invites or the VIP Slack channels for access information. We'll be back in about 15 minutes. Welcome back from the break, everyone. Up next, we'll all get to embrace our inner kid for just a little bit while hearing about how deep learning delivers ultra high definition content in animated features using less than half the data center footprint and how you can apply that to your business. You may recognize this clip as being from, that's right, Toy Story 4. Now, if you're wondering how this animation was made with so much realism and how AI helped influence every frame in the movie, here's someone who can explain. We have the technical director of Pixar Animation Studios, Vaibhav Vavilala. At the end of his presentation, I will be back to take your questions to Vaibhav, so go ahead and enter them in the Q&A Slack channel.
My name is Vaibhav Vavilala, and I'm a technical director at Pixar Animation Studios. I've worked on the lighting and rendering optimization team on Coco, Incredibles 2, and Toy Story 4. Today, I'm excited to talk about how machine learning has made an impact in animation and go in depth into a project I've been working on, Deep Learned Super Resolution, which uses generative adversarial networks to reduce render time and produce high resolution imagery. But first, I want to start off with an overview of the filmmaking pipeline. I know we have folks here from many different industries, and it's good to get an idea of what are the different problems that need to be solved to create one of these incredible films that capture the minds and hearts of millions of people around the world. Let's kick it off with story. Many years before a film is released, a filmmaker will come up with an idea, a set of characters, conflicts between them, the setting, and theme. They eventually get to a screenplay and sketch storyboards to figure out how these characters think, interact, and feel. This is all careful planning before a ton of artists and engineers come together to bring these characters to life in a virtual 3D world. Next up, we have characters and sets. We have modeling artists using computer-aided design software like Maya or ZBrush to create the 3D geometry associated with every character and set piece. All this art is described with math, using vertices, edges, and different transformations. And the technology is so advanced that artists can design fine details like strands of hair or create an enormous forest by instancing just a few trees. From here, shading artists design the surface of each piece of geometry. We have hair, skin of different colors, various patterns of embroidery on clothes, and so forth. It's incredible the vast array of real-world textures artists can capture in a computer by using physically based models to simulate how light bounces off different materials. Next, let's talk about layout. Once we have the characters and set pieces, layout artists arrange these elements for every shot. They select the camera and lens and think about the composition of the scene and depth of field. From here, we have animation, which is by far the most labor-intensive part of the filmmaking process. Animators need controls to animate a character. So we have special rigging artists to create these controls for every limb, for every finger. On the face, we have the eyebrows, eyelids, lips, and jaw. Our animators use these controls to create animation at 24 frames per second for a 90-minute film. All these details matter to create a compelling performance that the world keeps coming back to see. You can imagine the job gets really fun when they try to figure out how to animate animals, like dogs and cats, or even non-living characters like robots. So this is a uniquely challenging and satisfying job. Next up, we have simulation and effects. From Merida's hair to rain droplets to Violet's force field, these artists and engineers know how to observe and bend the rules of physics to produce all sorts of phenomena that are critical to telling the story. From here, lighting artists must place virtual lights in the scene, much like in a live-action production, except in a virtual world, you have so many more possibilities and much greater control. You can precisely set the number, color, position, and intensity of lights. You can turn off shadows or make lights only affect certain objects. There's so much we can do with lighting to further the director's vision. Looking at this before and after, you can see just how important lighting is to creating the final output. My work at Pixar is related to lighting and rendering, and in just a moment, I will be elaborating more on how my work in AI is impacting this stage of the pipeline. Next up, we have sound. Typically, a lot of voiceover work is recorded on site, and it takes quite a bit of precision from the animator to synchronize the lips of the character with the voice actor. And of course, there's also the film score. Some of the most iconic moments in film are so striking precisely because of the score. Depending on the composer and genre, software instruments are combined with live orchestral instruments and vocals. For decades, technology has been deeply embedded with sound and music creation, and now a lot of interesting research is happening with AI-based sound synthesis. It will be interesting to see what makes its way into production. Finally, we have image mastering. This is the final step before the film is released into the world. Their work involves color grading, creating multiple formats like HD, Ultra HD, and high dynamic range, as well as creating international versions in different languages. So that gives you a sense of the filmmaking pipeline. There's also marketing, theme park deliverables, legal, and more, but this covers most of what's involved in creating the content. So now let's talk machine learning. One example of machine learning you will find in some of the most successful films ever made, the Avengers series. To animate the character Thanos, the VFX studios used the Medusa performance capture system from Disney Research, and machine learning was used to process that motion capture data and obtain high-resolution geometry. Of course, no one advertises the incredible technology. People just want to see Thanos conquering new worlds. Another example of machine learning gaining widespread use is in image denoising. Rendering a single frame for a movie involves a computationally expensive process called ray tracing, which simulates how light bounces around in a scene. When you start a render, you observe these really unflattering noise artifacts that you can see on the left. As you render for more time, the image converges and the noise level progressively reduces until you can't notice the noise anymore. The idea behind denoising is to render for less time and have the denoiser predict the clean image given the noisy image. This technique was fruitful on several of our recent films, and some of my colleagues helped bring this technology into production. But of course, as rendering becomes cheaper with better technology, artists often eat up those gains by trying to push creative boundaries. More lights, more geometry, more fog and volumetric effects, more complex lighting. All this often results in longer render times. And of course, there's perpetually a demand for more content. So there's still room for innovation to make rendering cheaper. We've taken an overview of the filmmaking pipeline and looked at two ways that machine learning is already impacting the industry. Now, I want to talk about an emerging technology that I've been working on, deep learned image super resolution. The basic idea here is that we're taking a low resolution image, you can see here on the left, and we expect the AI to give us the high resolution image on the right, with all the fine details that we love. So why is upscaling helpful? Well, it can be used to create high resolution content, but the quality from traditional methods like total variational inpainting is not as detailed as we would get from deep learning. We upscale instead of render at high res because high res rendering is cost prohibitive at scale. I mentioned just how expensive ray trace rendering is. Just to give you some numbers, it typically takes at least 50 CPU hours to render one frame at 2K resolution. We render 24 frames per second for a 90-minute film and render each shot many times as the artists iterate. Further, we have multiple films in flight at a given time. All this adds up to a lot of demand for render farm, which is a finite resource. If we render at a higher resolution like 4K, that's 4 times the pixels and more than double the cost. So upscaling techniques can allow studios to deliver high-res imagery without blowing up the cost. Further, rendering at a smaller resolution incurs a reduced memory footprint, which can further optimize render farm utilization. So to summarize the objectives, using deep learning, our goal is to first replace parts of the pipeline where old upscaling techniques were used, resulting in a higher quality product. And second, we hope to introduce deep learned upscaling to new parts of the pipeline, which would allow us to make the same content at lower cost by enabling us to render at a lower resolution. We start off with a literature review. I examined what is the state of the art for super resolution tasks. One interesting thing I observed is that deep learning has come a long way when it comes to 2D image space operations. Ever since the ImageNet dataset came out and deep convolutional networks were found to be effective for image-based problems. Specific to SuperRes, I observed from R&D efforts by the Disney Research Group that the best results are produced by GANs, generative adversarial networks, and perceptual loss functions. These really boosted the quality, sharpness, and richness of the textures in synthesized images. Based on my review of this work, the state of the art is using a deep convolutional residual network with adversarial training and a perceptual loss function. So my task was to get a training pipeline running using the state of the art ideas and then address any gaps in the research that we will need for production. As part of this project, we collaborated with Disney Research, and it was a huge advantage being able to source ideas from them. So let's talk about data. Basically, what we want are pairs of low-res and high-res images. One idea is using existing high-res images that are already rendered and then downsampling to get the low-res. However, we observed that the relationship between a high-res image and a low-res image is a very complex nonlinear function, and there's no existing downsampling operator that can do this. Research to circumvent this problem is ongoing, so instead we render pairs of images using RenderMan, the rendering software Pixar uses for all of its films. We render pairs from many different shows, and we include scenes with diverse lighting, characters, strength of film grain, textures, and so forth. The richer the dataset, the better off we are. From there, we write scripts to gather the data into one place and keep only pairs that are coherent, because there can be lighting and shading differences due to resolution-dependent parameters that can make some pairs unusable. And through this process, we end up with about 3,700 pairs. So how do we train this thing? In terms of hardware, we set up a massive Linux instance with NVIDIA GPUs with the help of our systems team. In terms of the development environment, we built a Conda environment with PyTorch with the help of the tools build team. From there, we implemented the training pipeline in PyTorch. For fast I/O, we store the training data in a Lightning memory map database, which reduced training times by almost 1/3. One thing that's unique about SuperRes and working in image synthesis in general is that we can't just trust the error metrics like the PSNR score. An image might have low error, but reveal unwanted artifacts or smooth out useful details. Another image might have higher numerical error, but show more visually pleasing results. Improving error metrics to match how a human would perceive an image is an active area of research, but for the purposes of this project, I made sure to visually inspect the validation images when evaluating an experiment. I wrote custom Python scripts to make it easy to view images and compare different experiments, which allowed me to make decisions on hyperparameters and architecture and so forth. Recently, we started using the DGX2 supercomputer to run SuperRes training experiments. This machine has 16 GPUs, and the training time right now is around 50 hours on 4 GPUs. It was a huge advantage having this resource to run multiple experiments at once. It helped me make discoveries and address artist feedback much faster. And as a general rule, if you're trying to train any custom machine learning model, aggressive experimentation is a very important part of the process to get the most out of your project. From here, I want to talk about some of the unique challenges of deploying this technology into production. First off, most deep learning work in computer vision deals with images with luminance ranges between 0 and 1. But in the pipeline of making a feature film, we often deal with images with high dynamic range data, much greater than 1. For example, when rendering the sun or a light bulb. Because neural networks perform best on data that is normalized between 0 and 1, or -1 to 1, for SuperRes, we basically transform the data into log space before feeding the data into the network, and then transform the output back into linear space. And that's how we support HDR. Next up, when we were getting feedback on our initial results from the studio mastering team, they observed very subtle color shifts in the SuperRes output. The colors would be slightly off. You're seeing an exaggerated version of that on screen. We looked at this and noticed that the perceptual loss in giving sharpness also sometimes slightly changes the color beyond what the artist intended. To solve this, we could have reduced the weight of that hyperparameter to reduce the color shifts, but then we would also have lost some sharpness, so that wouldn't work. Eventually, someone on the team came up with the idea of adding a new loss term that penalizes the difference in the color in a low resolution space. And we haven't seen any of these color shifts since then. A third issue that came up was unwanted noise and over-sharpening of the input. You can see a little extra noise here on the balloon up top. We noticed that some of our initial hyperparameters pushed sharpness a bit too far relative to what the artist wanted, reducing the feature loss and GAN loss while boosting the content loss helped reduce the extraneous noise. A lot of artifacts we observed from initial versions of SuperRes, color shifts, noise, edge artifacts, they're often quite subtle. Most people in the audience would get so lost in the story that they probably wouldn't notice. But of course, Pixar artists are very precise, so we had to fix them. And as I mentioned, it took a lot of experimentation and iteration to get anything close to what would be considered production ready. Another unique challenge with filmmaking is handling channels beyond red, green, and blue. Most computer vision work just deals with those three channels. Fortunately, the number of input and output channels in neural networks is a simple tunable parameter, and for additional channels like alpha, that was sufficient to get us something that we could start testing with. A lot of fascinating research stays as research, but I'm excited to share that SuperRes is now part of our pipeline and is starting to find usage in our productions. I wanted to leave you with a few points that could be useful in your organization. I first came up with the idea to pursue super resolution about 2 years ago by paying attention to work coming out of Disney research and thinking about the connection with our production pipeline. What could that journey look like for you? Well, I would recommend taking a look at the titles and abstracts of some of the leading journals in AI. NeurIPS, ICML, CVPR are among the best. For computer graphics, SIGGRAPH is the leading venue. And from looking at the recent papers, you can tell there's a lot of work being done at the intersection of graphics and AI. Of course, most people are not technical enough to read through all the math, but looking at the headlines, you can see what the technology can do today and where it might be headed. And looking at the authors, you can see who are the leading actors in these fields. Once you know where the research is, think deeply about what problems your organization faces and come up with unique solutions. A second takeaway is to promote a culture of risk-taking in your organization. One of my observations at Pixar is that folks are open to new technologies and experimentation early during the development of a film. But once we're deep into production, we instead focus on stability and try to avoid the technology breaking. If you can find that balance between risk-taking and tried and true processes, you can successfully innovate and mostly avoid chaos. A related idea that's personal to me is that through this project, I was able to align what I was passionate about, AI and graphics and creating new technology for artists, with something that the company needed. We were already doing upscaling before, it's just that the quality could be a lot better with AI. Similarly, when you're working for a company, be thinking for yourself, what does my organization need to be successful? And how can that gel with what I'm excited about, or good at, or want to learn more about? This line of thinking was really important for me. Just to cap this off, the legacy of animation is the 2D hand-drawn animation that Walt Disney was famous for, going back as far as the 30s when Snow White came out. In the 90s, computer animation changed the game forever, creating so many new possibilities for artists and technologists. Now with AI becoming mainstream, we're just starting to discover how this new technology can enhance the way content is made and experienced. And I'm really excited to be part of this revolution in a small way. I want to thank the Pixar research team, systems, build and release, mastering, lighting, rendering, as well as the studio leadership team for giving me the time and space to pursue this work. And special thanks to Mark Meyer, Jeremy Newland, and Chris Shores, who have been my closest collaborators. That's it for me. I hope you learned something new. Thank you for tuning in.
Hello, everybody, and welcome back. I am Andrea Renee, joined with Vaibhav. Good to see you today. Thank you so much for that presentation and for joining me. So when we were on the break, I was asking you a little bit about some napkin math that I was doing, because in your presentation, you were discussing some of the CPU hours it takes to render. Now, ray tracing is such a fascinating thing. I come from the world of video games, and ray tracing is the new hotness for gamers out there. And I love hearing about, how it's used in animation as well. But you said there were 50 CPU hours to render a single frame at 2K resolution. Is that correct?
I mean, it varies. I mean, if you have a lot of content in there, you have, a lot of grass or a lot of volumes like clouds or water, for example, it can get a lot more expensive. If it's a very simple scene, it can be less than 50. It's just a ballpark. It's 50.
No, I thought it was interesting because I was like, let me do some quick napkin math on like how many CPU hours there would be like in a single animated film that runs around 90 minutes. And I had over 6.4 million frames. And then you very astutely reminded me, well, yeah, but that's only if they made the frames one time.
Yeah.
I mean,
iteration is a really important part of the process. Oh, yeah. No, totally. It's, iteration is a really important part of the process. And it's interesting. You think that rendering would get cheaper over time, but artists always strive for new creative heights. And so as new technology comes out, it's either rendering cost stays the same or it goes up. It just can be counterintuitive sometimes.
Well, I'll keep my fingers crossed that maybe one day the rendering price will come down the way that SSD storage has thankfully come down. But I do have some questions for you from our Slack channel. Again, if you would like to leave a question, you can drop it in the Q&A channel. So the question for you is, what are major differences between animation made by an artist versus made by an AI? Can the human eye make out if the animation has been done using AI?
Yeah, I mean, that's an interesting question. I mean, I think that the animation so far is basically mostly done by humans. Animation is AI is helping reduce the cost of production in very specific ways. So I mentioned denoising as an example. So it's sort of just reducing the render cost, super resolution, reducing the render cost. It's very, very hard to tell that AI was at work here. In terms of the actual animation, the characters moving and so forth, we're still pretty far away from AI creating the quality of animation that you've come to expect from Pixar. We're still pretty far from that.
All right. Well, thank you for your question. This next one, this might be a bit of a debate. I don't know if you can give me an official answer. Was Forky a fork or a spork?
I don't know what the official answer is on that, so I'm going to defer on that one. I do not know.
No, I do want to kind of touch on what you just said in a more serious nature about the differences between AI and human animators. I recently watched on Disney Plus the documentary series about the work done on Frozen 2. I don't know if you've had an opportunity to see the behind the scenes look at what the animators do. I haven't gotten the opportunity to see that at Pixar, but would love to. Hopefully you guys have something similar in the works with the team who makes those series. But it was really interesting seeing just how many different people touch the animation process. And, as a technical person versus somebody on the art team, how often do you guys get to intersect and kind of, put your heads together?
Yeah, all the time. I mean, it's a huge advantage having artists and engineers under the same roof. I mean, if you're a technologist, you create software, you want as close interaction with your users as possible. And it doesn't get any closer than what you get at an animation studio. Because as a technologist, you can look over the shoulder of an artist and see how do they work, what are their pain points, what's slow, what's fast. So it's a very deep collaboration between the engineering teams and the artists for every stage of the pipeline.
Well, that's exciting to hear. I do have another question. Can you emulate a darkroom process of selecting parts of the image to focus the NN on or control the focus area?
Sorry, I didn't fully understand the question. Can you say that again?
I think the question is talking about a specific photo development technique where you can select specific parts of the image or control the focus area, and how there is a manual way to do that with a human, and didn't know if there was a way to emulate that process.
I mean, in our rendering software, you can. So, the scenes are these are all 3D scenes on a computer, and so an artist will precisely control the depth of field for every shot, and over the course of a shot, the depth of field might change, or the focus might change. AI could play a role in that potentially. I'm not sure if it's a very tedious process where they want to give to AI. I think they want that control. But yeah, so far it's something that we have layout artists who control that process in a very fine way.
And just like that, we are out of time. Though this next question that came in, I find very fascinating. Would love to hear your answer on. But Vaibhav will be going to the offstage Q&A room. So if this was your question, please head over there. It was about the path that you took to get to the job that you have today. Any inspiration, education, or mentors that you would be willing to share. So hopefully he can answer that question for you in the offstage Q&A room. Thank you so much for your time today, Vaibhav.
Thanks for having me.
And now I would like to introduce our next panel. It's a conversation about AI. Oh, excuse me. I'd like to introduce our next panel in our whole day of conversations, I should say, about IoT and AI at the edge, of course. We're talking about computer vision here today at VB Transform. This panel is going to be moderated by one of the busiest women here today at VB Transform. Please welcome back founder and principal analyst of Lopez Research, Maribel Lopez. She'll be leading a discussion on digital transformation through AI at the edge. Joining her are panelists, the head of IT planning systems for BMW Group, Ginny Nassif, the co-founder and CEO of Malong Technologies, Matt Scott, and at the office of CTO Red Hat, Jared Floyd.
Hi, I'm Maribel Lopez, the founder of Lopez Research, and I'm really excited to be here today to talk to such a great group of people that are very diverse in terms of what they're doing in the AI ecosystem. So without further ado, I'm going to ask each of the panelists to introduce themselves and what their role is in the AI landscape and what they're doing that we would consider exciting. So why don't we kick off with Jimmy?
Hello, Maribel. My name is Jimmy Nassif, and I'm the head of IT planning system at BMW Group Logistics. I'm an IT manager and IoT expert at BMW Group with almost 10 years of experience in automotive engineering. Since 2016, I'm leading an AI and digitization lab in BMW Group Logistics division, leveraging innovative solutions in field of IoT and solving real-world problems in distribution and manufacturing.
Brilliant. Matt?
Hi. Hi, everyone. So my name is Matt Scott. I am the CEO and co-founder of Malong Technologies. We are an AI computer vision startup. That's an Accenture-backed company. Most of us are hailing from Microsoft Research, and we focus on the retail industry, and we solve high-value business problems for in-store shopping.
Jared, up to you.
Hi. I'm Jared Floyd. I'm a technology strategist at the Office of the CTO at Red Hat, and I'm working on technology strategy around edge computing, so edge computing architectures, and particularly how AI ML techniques are used at the edge to drive new business cases and applications.
Excellent. Okay, so let's jump right in. Jimmy, BMW. They do a wide range of things in AI, everything from working on autonomous driving to robotics. So in your field, you've been with BMW for a while. Robotics isn't a new thing for you, but I thought perhaps you could tell us a little bit about what's changed and how your work with AI has changed over the past year and a half.
Yes. So BMW Group is increasingly relying on innovation from the field of digitalization and Industry 4.0 in production logistics. So this will ensure the company's global production network to continue to receive the parts it needs in a timely and reliable manner in the future. And basically, just to give you an overview how BMW functions, I don't know how many of you already visited a plant at BMW, but every 56 seconds we produce a car just in time and just in sequence, which make it a little bit more complex. And just to count some numbers, the BMW's group supply chain takes millions of parts flowing into a factory from more than 4,500 supplier sites, involving 230,000 unique parts number, and in growing volume as BMW Group car sales have doubled over the past 10 years to 2.5 million cars sold in 2019. Moreover, as I already said, BMW Group vehicles are produced in less than 1 minute and offered to customers with an average of 100 different options, resulting in 99% of customer orders being uniquely different to each other. So this creates an immense challenge for factory logistics. And ultimately, the sheer volume of possible configuration became a challenge of the BMW Group production in three fundamental areas: the computing, logistic planning, and data analysis. So this gives us the opportunity now with new technology and new innovation to optimize these processes and make it easier for our people in the production and in the logistics. And as a response on these challenges, we use NVIDIA's Isaac robotic platform to develop 5 different AI-enabled robots to improve the logistic workflow, powered by a variety of NVIDIA Jetson AGX, Xavier, and EGX edge computers. These includes both navigation robots to transport material autonomously, as well as manipulation robots to select and organize parts. So everything is developed, as I said, on NVIDIA Isaac SDK. The robots utilize several powerful deep neural networks addressing perception, segmentation, pose estimation, and human pose estimation to perceive their environment, detect objects, navigate autonomously, and move objects. These robots are trained both on real and synthetic data using NVIDIA GPU to render ray-traced machine parts in a variety of lighting and occlusion conditions to augment real data. So the real and the synthetic data are then used to train deep neural networks on NVIDIA DGX systems, and the robots are then continuously tested in NVIDIA Isaac simulators for both navigation and manipulation, operating on NVIDIA's Omniverse platform, where multiple BMW Group personnel in different geographic locations can all work in one simulated environment.
Okay, so we're going to circle back to some of the challenges that you had and some of the opportunities that you see moving in AI, like basically some of the how you just mentioned, but what you might think is next, what you need to do next. I want to head to Jarrett because Jimmy just talked to us about a very advanced use case with AI in terms of doing robotics. Jarrett, I know that you at Red Hat definitely work with a lot of different organizations. Automotive is one of them, but perhaps you could give us some other perspectives of how you see people using AI.
Yeah, absolutely. I think one of the really cool things we do is, as a platform company, we work across industries. We provide platforms, both operating system and container orchestration platforms, and work with upstream open source communities to be able to pull in the best of breed components. So we have support upstream and in collaboration with NVIDIA for GPU accelerators for AI workloads. And then we work across multiple different verticals on how different edge architectures can be deployed. These could be distributed clusters, distributed compute nodes that are part of a central cluster, or standalone IoT type devices. So certainly we work in manufacturing, work in automotive, but I think one of the really interesting use cases that we keep coming across are smart city use cases or connected camera use cases. This really leverages the benefits of driving AI to the edge, because you have video streams. You may have hundreds, you may have thousands, tens of thousands of video streams. It's not practical to bring all those video streams back to a central location. That you can't, for bandwidth reasons, for latency reasons, for cost reasons, do that. One partner that I've been working with has fleets of connected cameras, and they use these connected cameras for all sorts of city enablement, traffic monitoring, accident detection, hazard detection, map refinement that feeds into automotive use cases such as autonomous driving. And it's not realistic to take all that data and process it directly on these low-cost cameras, for example. And it's also not realistic to push that all the way back to a core data center in a public cloud or private cloud. So instead, they're able to make use of edge enablement, edge compute clusters that have GPU acceleration, for example, to do that video analytics. And that means that 5G network infrastructure is becoming increasingly critical to this, that instead of just having cameras that are wired into a network, wired into an infrastructure, you now have these wirelessly connected cameras that take advantage of the massive increase in bandwidth, reductions in latency, and greater device density that 5G networks provide to be able to offload that AI analytics, that video analytics to edge compute locations. So smart cities, smart camera use cases are really cool. And I think another one that's really fun to talk about that I can call out is there's a project called the Mayflower Autonomous Ship, which is an IBM and Red Hat collaboration, which is a fully autonomous boat that is going to basically circumnavigate the globe. And that's all powered by open source technologies.
That's fabulous. So we're going to go from self-driving cars to boats that navigate the world. And I'm hoping that there will actually be individual air drones that can actually get me from place to place without me driving at some point in time, assuming we go anywhere ever again. So that is where we are at this moment. I actually like where you were going with the computer vision use cases, and I think that that actually tees Matt up quite nicely to talk about what we see as a real problem in terms of revenue leakage in retail. Matt, maybe you can walk us through how AI is being used in retail to prevent a really big problem that they're having today.
Absolutely. So we work on a very important problem in retail, physical retail or brick and mortar retail. It's actually $100 billion problem. It's about shrink, and shrink it also refers to inventory loss. And in particular, we work on scan fraud, which is a problem that occurs at the front end of stores at primarily self-checkout. And self-checkout machines have become, much more relevant these days, of course, due to COVID-19. But there's an increase in loss at self-checkout when compared to staff lanes, and a significant loss. And so what we do is, and the value we bring to retailers is that we actually use cameras overhead, self-checkouts to basically detect scan fraud or accidental misscans. And how it works is that basically we're looking at the products, just the products as they move across the scan bed, and we look for several common issues. So for example, misscans where a barcode is is just not scanned, it's covered, or it's just manipulated such that it's not scanned. We work on bottom of the basket where we observe that there's been products that haven't been they've been left in the shopping cart. But one of the really interesting ones is called ticket switching, where a product was scanned with a barcode that wasn't its original barcode, an inexpensive barcode that was either attached or was stacked with a product in front of it. And so how that works is we actually do product recognition. And so what's going on is that we're essentially pumping video into the back of the store on a server with NVIDIA EGX platform running. So the NVIDIA GPUs, primarily the T4 GPUs, where we have a variety of streams, maybe dozens of video streams coming in, and we're looking for these issues. But with product recognition, what's happening is we're actually learning at the same time as actually we're doing inferencing. So we're learning all the products in the store, and then we're verifying that a given scan, a given UPC actually matches the product that was actually scanned. And so how that works is that so typically in AI, you usually have to have like a side set of data that you're going to label and then train. But we've actually used a technique called weakly supervised learning, where we're actually basically having a self-learning system. And so it's a very elegant approach because it's very scalable. And once the system is deployed into stores, it starts to automatically learn the products and then apply the tech at the register. And so when an exception occurs, a staff member is alerted and can assist the customer to resolve the issue.
Excellent. That's a great use case that I think that everybody can actually relate to the concept of also how often do I need to train? How do I actually get accurate training data? Labeling has been a real issue for a lot of companies. So being able to automate some of that, I think, is a really interesting concept that we can take away from this. Jimmy, I want to circle back to you for a moment. When we think about what's going on with AI, we actually are getting better processing technology. We're getting better software toolkits, so to speak, to actually make the creation and management of models easier. But was it difficult for you to move from what you were doing to a new stack? Like, how is that process working? Like, if you were an organization, you were thinking, I want to make a change. This strikes me that this was an issue. Was it that you had something that was so much better to go to that you said, okay, let's do it this way. We really need to do it this way. Or how should companies think about that process?
Yes, I won't say it was easy, but it wasn't that difficult. So basically, the issue was to convince our people that this is the right way to go. And basically, as I already said, as BMW, we produce car. So that's the most important thing at BMW, is to bring the car to our customer in the cheapest way we can do it. But in the same quality and the better quality, because we are at the end of the day a premium car seller. Nevertheless, we need to implement new technology in order to optimize our processes and to support our people in the production to do their job easier and faster in order to produce more cars. As I already mentioned before, in the last 10 years, we already doubled the production amount of our cars and the sales of our cars, which is not making it easier for us. And just taking consideration that to produce every 56 seconds a car, you can imagine how important it is to make sure that the process is working perfectly, and our availability has to be over 99%. So basically, the most important thing is to bring our people inside of our plants and our logistics to learn the new processes and to bring their expertise in order to make sure that these processes will work in the future. At the end of the day, buying a final, buying a final product wouldn't be that easy, because we need to train our processes to recognize, for example, assets inside of BMW, which are specially designed and created for BMW. That means our people need to do the job by themselves at the first day, and they need to train our algorithm and models in the robots, for example, to recognize each pallet that we deliver to the production line in order to be able to automate the process. And at the end of the day, convincing these people wasn't easy, but I won't say it was so difficult, because we showed them the way that we are willing to take, and we showed them how the results could look in the future. And at the end of the day, we are supporting them to do their job better and faster and easier at the end of the day.
Excellent. So Jared, when we think about open source, a lot has changed in open source. And I think, we think more of open source as a platform now. Can we talk a little bit about how open source and AI are maybe coming together and what organizations should be thinking about?
Yeah, so I think a lot of what's happening in AI as well as in edge computing is moving so rapidly that it's really important to choose open platforms, because that's where the collaboration is happening. That's where the innovation is happening in each of these components. You look at what's being built, everything's being built on Linux, everything's being built on Kubernetes, everything's being built on platforms like TensorFlow or Jupyter Notebooks. And all of these are open platforms, which means that everyone can bring their best technologies forward. Everyone can come with the technologies they want to integrate and be able to immediately plug them into this enormous ecosystem of AI components. And then rapidly connect them to applications. So, for example, we have a completely open project called Open Data Hub, which it's not a product. This is simply a blueprint of how you can use open source components to all work together. And that works across different hardware platforms, different software platforms, and allows rapid innovation of new applications and new technologies.
Excellent. Matt, when we think a little bit about what's going on with retailers and what's going on with AI edge, that data that we talked about and the collection of it and the training of it, does all that happen at the edge? Do we use the edge and the cloud in a combined status? How should organizations think about where and how to process this type of data?
Yeah, it's a great question, and it's actually the edge is doing the heavy lifting. It's for a variety of reasons. First, it's also something back to what Jared was saying. You have so much video coming in; it's totally inefficient to process it elsewhere. You have to process it right then and there. So there's an efficiency argument, but also there's a privacy argument as well. So we're learning and we're actually performing inferencing all right in the same spot, basically. So it's really important to do that. The other interesting thing about retail is that you have access to, when a store is actually running, there's just tremendous amounts of data. And so you want to leverage that and basically not get in the way. You don't want your application to kind of get in the way of the data. Let the data speak for itself. So if you had to, for example, collect data off-site, label it, and curate it and do all that work, you're not really getting the full advantage of what's happening in the store, because actually what's really going on is that there's enough interaction between the customer and the self-checkout that you can actually learn directly without having human labelers intervening. That's actually the weekly supervised learning approach, or the self-learning approach that we're leveraging. So doing more at the edge brings just tremendous value. And again, it's at the end of the day, it's actually about scalability. Having a solution like this can work across thousands and thousands of stores.
Jimmy, where do you think you are in terms of the process? You talked about the ability to get to that 99% reliability, and having perceptual robots that can really zoom around a factory and do this all in real time is actually quite a feat. Are you 50% there, 75% there? And what would you like to see happen in the future?
It depends on which robots we are talking. So as I already mentioned, we are implementing 5 new robotics or robots to support our people in the logistic. 2 of them are already productively working inside of our plants in 4 different plants in Germany. 2 of them are piloting. We are piloting 2 of them right now, and the 5th one is already in proof of technology. So basically, it depends on which project we are talking about. But nevertheless, we are still at the start. I think at the end of the day, the technology, it's running very fast and we have to keep up. So basically, we need to train our people inside of our plants to keep up with this new technology. And for me, it would be amazing if we can see our robots working inside of our plants productively by the end of next year.
Perfect. And then maybe Jared and Matt, very quickly as a wrap up, piece of advice for the audience? Jared, we'll start with you.
Absolutely. I think the important thing, especially when applying AI at the edge or AI in general, is just make sure you understand the problems that you're trying to solve. That AI can help you if you're not sure exactly how to solve them, but it can't figure out what it is you're trying to do in your business to begin with.
Sure. Excellent.
Yeah. So my advice is that to really appreciate the difference between a demo AI system and a mass production AI system. Making an AI system actually scalable is very, very different from actually just making it run. And that's sometimes a mirage that happens when people are starting to play with these technologies. Looking beyond just the canonical approaches, looking at research, we just had CVPR, for example, the top conference in computer vision. There's a lot of techniques out there that really break away from just the kind of, is it a hot dog or not?
Perfect. Jimmy, any closing thoughts on your side, given that you're deep in the middle of this?
No, I can assure what Matt said. It's the right thing to do, especially when it comes to production, and especially when it comes to high availability. So it's not the same to run a demo or do a proof of technology and run it as a production. So it's basically a huge difference between these 2 stages.
Great. Well, thank you, gentlemen, for your time. It's been wonderful hearing your insight.
Thank you.
Thank you.
Hello and welcome back to the Q&A. I've been monitoring the channel. The first question is for Matt, and it's a clarification question. How do you label at the edge without human intervention?
Right. So you want to use the natural interaction between people and machines. So, for example, when you're scanning at a self-checkout, the scan itself is the label, because the scan is for example, a UPC barcode, and you combine that with the visual data, and that pair is what you need for training. And then you just use certain kind of algorithms that can leverage this type of data. So as I mentioned earlier, we use weakly supervised learning, which allows us to learn from noisy data. So in fact, if you just use data from actual usage, it's not going to work very well with the typical supervised learning algorithms, because it's going to be there's going to be a lot of noise inside of the data. So it's going to, for example, have more samples of one particular product or the other. So you need to use a better algorithm. And I encourage the audience to look for weekly supervised learning and look for our algorithm called Curriculum Net, which we published at in these top conferences such as ECCV and CVPR.
Excellent, thank you. We have another question that is focusing a bit on what are some of the futuristic use cases of AI? And I know, Jared, you and I had been at one point talking about smart cities. Maybe I can start with you on that question there.
Yeah, absolutely. I think that the huge potential for edge AI with smart cameras, with computer vision, is just the general instrumentation, the ability to make inferences and take action on what's going on in the real world at a grand scale. So some of the cases I talked about earlier, just traffic detection, traffic jam detection, anomaly detection, that there's a platform from NVIDIA called Metropolis, which can run in this distributed manner and can be used for a variety of different computer vision use cases that affect smart cities. And then you can look at a planetary, even a global scale, and say, what can we do to monitor the states of cities, the states of forests? How can we determine if droughts are affecting different areas in different ways, what the impact is on environmental changes based on either live cameras or satellite imagery.
Great. Matt, do you have any other thoughts? I mean, I know that you've been working in retail primarily, but even within retail, are you seeing some futuristic use cases you might want to share with the audience?
Well, definitely. I mean, we also see in the news lots and lots of futuristic sort of store of the future scenarios. But I think what I'm more excited about is actually making something real, practical, and scalable. And for that, it's sometimes like a little bit less exciting in some ways, but it's actually really just practical. What we're trying to do is bring ROI to our customers and bring real value with AI, and sometimes it's less flashy, but it gets the job done.
Got it. Okay, so I believe this question is for Matt. How do you deal with data drift and concept drift for models at the edge?
We just use better algorithms. So we don't use the sort of off-the-shelf approaches that assume curation, assume that you have some essentially a good set of data. We're kind of adversarial with our data. We know that it's not going to be good. It's going to have problems in it. So we're actually defending that in our approach fundamentally. And so that's why in our company we have a large portion of our staff is actually research scientists inventing new algorithms, doing original work in research for the problems we have. And I do encourage the audience to go and visit our site and see our research work, and you can see all the different papers that are behind our products.
Excellent. Jared, question around open source, and what are some of the challenges of using open source and potentially some strategies to get around those?
I think the biggest challenges in AI around open source is that this shifts where the value is from not just the software to the data that makes up the model. And while the software may be open source, may be freely available, may be a community project, the data itself may be proprietary. And so if you don't have access to the data, you just have access to the software, you can't replicate results, you can't build on what's already been done. And the core of what open source is about that community involvement, is being able to build on top of existing components. So the challenge is making sure those data sets are as open as the software.
Brilliant. Well, we're out of time for this section of the Q&A. Pop over to the Zoom. Look forward to seeing you there. Thank you.
Thank you.
Thanks.
Hello, everybody, and thank you to Maribel for once again leading a very interesting conversation. As she mentioned, they're going to be in the offstage Q&A room, so you guys know the drill by now. If you want to continue the conversation and ask a few more questions, you can go ahead and head to that room now. But next up, we have another presentation, and this one is on how synthetic data sets are generated by game engines and how they can help train real-world computer vision models. And here to discuss this topic is Cesar Romero. Please welcome the Principal ML Engineer of Unity Technologies. And Cesar will be taking your questions in Q&A, so please post them in the Q&A channel on Slack.
Hello, my name is Cesar Romero. I'm a principal engineer in machine learning at Unity, and today I want to talk to you about how synthetic datasets may help you train real-world models in computer vision. Let's start with the basics first. So many of you know that any autonomous system, before it can actually act, it needs to perceive the world, try to understand it and reason about it, which is essentially the task of computer vision, until it basically can act like a robot might or an autonomous vehicle. Any of these systems, one thing that they have in common is that they need a lot of data, and they also apply in a wide range of domains. So let's look at a couple of them. In autonomous vehicles, your car might need to detect pedestrians and other cars to navigate appropriately. In robotics, the robot might need to detect what an item is or where exactly it is to like pick it and place it in the correct tote, for example, or move it in an assembly line. In the retail space, you might want to understand the traffic in your supermarket or detect specific items in your warehouse, as well as the more recently popular cashierless checkouts. And in the space of security, you might have security cameras in residential or commercial environments where you want to detect kind of anomalous behavior or events that you want to quickly react on. All of the systems, one thing that they have in common is that they need a lot of data to be able to learn from a large collection of examples. And one of the things that I want to talk about is the challenges with real-world data. Some of them are more obvious than others. So let's look at a couple of aspects. First, we have privacy and regulatory concerns such as GDPR, for example. These kind of regulations try to emphasize that the data belongs to the individual and not to the entity that collects it, in which case it might make it hard for us to collect all that data blindly and just use it to learn from it. And one of the points that we can see is that if you simulate that data, you don't have to worry as much about who the data belongs to because it was essentially completely synthetic. A different aspect that I think fewer are aware of or understand is the biases or even in some cases lack of data that exists in the real world. That data that you might need to train your system might not naturally occur frequently enough in the real world. And we'll look at an example of that a little bit later. Also, collecting and annotating this data manually takes a significant amount of time. And that inevitably leads to cost. So the cost of collecting and annotating this data is significant. And I'm going to show you how that actually does not simply go away with scale in the case of real world data as the tasks become more complicated. So let's look at an example of lack of examples in real world. One such example is the case of car accidents or near misses. Here I'm showing you a quick clip of work that we did with the City of Bellevue and the Center for Computer Vision in the University of Barcelona, where the city was interested in understanding the intersections and near misses where a car might be close to hitting a pedestrian or close to hitting another car, and recognizing that car accidents are rare enough that it's hard to collect enough examples for your model to learn to detect this in video feeds. And so what they set out to do is create a simulation in Unity where you can actually add multiple pedestrians and cars to the intersection and see how they interact with each other and intentionally simulate car accidents or near misses and use those as examples to train the computer vision model. Another aspect that I mentioned was cost. So I want to get into that a little bit more so that we understand what is behind this cost and how actually it has gotten not cheaper over time to annotate data, real world data in particular. Back in 2012, which is when many would argue that the computer vision revolution started, or the deep learning revolution started, ImageNet was a very popular data set. It still is today. The task there is considered now simple by today's standards, where given an image, we're simply trying to predict a single label that might be relevant to describe the content of that image. So in this particular case, we have an example of an image that contains several cars, and so we just label it as cars. But it is a case today that many would argue, and there's actually evidence for this, that state-of-the-art classifier today is actually better than any single human at already understanding what the content of the image is. It is also true that just knowing that there are cars in this image is not sufficient for any autonomous system to make a decision. It's not sufficient to tell a car that there are other cars in here. So other tasks become more relevant over time. So one such task is object detection, where you want to draw perfect bounding boxes around the items that you're interested in detecting. And that way you know exactly what you need to avoid, for example. You can already see how the cost of drawing this perfect bounding box is higher than the cost of simply picking one label for the entire image. So let's look at a couple more tasks and how they increase in complexity. Semantic segmentation is a task where you want to label every pixel in the image according to what the object represents. So in this particular example, cars are blue. Normally, you also want to annotate other kinds of classes like pedestrians and maybe traffic lights. Then we have instance segmentation, where you want to individually understand how many cars there are, because just having a blob that all of these are cars may not be sufficient for your navigation task. And finally, a task that has become more popular recently is called panoptic segmentation, where every single pixel of the image is labeled according to both instance and class. This is closer to implicitly what humans do and what you might want a system like an autonomous vehicle to be able to do in real time as you make decisions. You could see how each of these tasks is harder to label than the previous one, and so therefore the amount of human time that we need to spend to label this correctly and to audit them is significantly higher. Therefore, the cost of annotation per individual image goes up, and as the size of the dataset goes up, then the cost keeps increasing. So let's talk about how synthetic data might help here. One key observation here is that in a simulation, your game engine or simulator knows exactly the state of the world. It knows exactly what each pixel is because it is rendered itself. So we can use this information to generate data sets. So let's look at a quick example of what might be like a residential robot, like a vacuum robot, for example, navigating a residential environment. And you can see how one of the things that we get for free in the simulation is that you have varying colors and lighting conditions and materials that might otherwise be very, very expensive to reproduce in the real world. So this is one of the benefits of being able to simulate your environments. I want now to take a closer look at specific tasks like object detection to make this case very, very concrete. So here on the left, we have a picture of actual supermarket objects that we acquired and took a picture ourselves. And then on the right, we have an image render with Unity that shows individual supermarket items just placed on the ground and rendered. Remember that once you have it rendered and you have these objects, you know exactly what each pixel is and where the object is. So then you have the option of rendering these products with perfect bounding boxes in random positions with different lighting conditions like you see here, different levels of blur, different maybe occlusion or backgrounds. And then you can train your model on it. Let's take a look at the kind of variation, for example, to drive this point across. If you start from a single 3D model of a product, you can arbitrarily rotate it, change the background, change the distance between the object and the camera that is capturing the image, change the blur or focus, the color of the light, and then you might end up with millions of images. And once you author the content once, you don't have to recreate each object, you're just simulating it. So let's take a closer look at the breakdown of cost. So we did an experiment, specifically in the case of object detection in retail objects like the ones I showed, to understand how the cost compares between generating a real-world data set, manually annotated, and generated a synthetic data set. What we did is, in the neighborhood of about 100 hours, let's see what data set we can create. And so there's a couple of things here that are worth highlighting. One of them is, in the case of the real-world data, most of the cost goes into annotating them. In this case, we're talking about bounding boxes. So you can just buy several products from the supermarket, place them, take pictures, but then a significant part of the cost goes into annotating every single one of these images, every single object in it, selecting the right class, and using tools that are specialized for this. In the case of the synthetic data set, the cost actually is dominated by the content creation. What's interesting is that you only have to create each product once, and then in the simulator, you can place it millions of times. So another aspect that is interesting about this is that it might require a little bit of different thinking in terms of the kind of talent and experience and skills that you need to generate these data sets. For example, technical artists and graphics engineers are going to be much more familiar typically with generating the kind of content that you might put using a game engine. So in this case, we can see how in the same amount of time, we generated 1 million images using in the synthetic data set. And even if the cost of generating the data set looks a little bit higher because the kind of talent that you might need to create digital content might be higher, the cost per image is significantly lower because we're talking about 1 million images versus 1,500 images. So let's take a look at how well does it work, because now we understand that it's significantly cheaper. And for that, I want to do a brief survey of what has happened in the last 4 years, different research projects that have shown what can be done with synthetic data set. The first one we're going to look at is called Cynthia. This is a car simulator coming from the Center for Computer Vision in Barcelona, which I mentioned earlier. They created a simulator made with Unity. They can have a car with multiple sensors that drives around a simple town and generates perfectly labeled images. What they did is then train a model using synthetic data or using a combination of real and synthetic data and tested on perfectly labeled real data. So that's the test, like a well-known autonomous vehicle data set like Kitty, for example. The overall conclusion is that very consistently, when you combine synthetic with real data, the model performs better than when you train it only on real data. To get a concrete number, the performance of, in one of the examples, in the Cambit data set, the performance of the model that detects cyclists went up by something like 18%. Very certain the class and so on. A year later, we have the next work that's done by OpenAI. And here you see an image of the task that we expect a robot to do. In this particular case, we want the robot to predict the exact position of the objects so that an arm can then pick them, much like you might see in an assembly line or a retail warehouse packing type scenario. The key observation here is that they actually train this computer vision system using 100% synthetic data, all of it rendered in Unity. And something that might come to your attention as you see this slide is the data actually used for training is not particularly photorealistic. Oftentimes we get asked how good are the images generated by the game engine? And what is interesting is that we're realizing through research is less than photorealism, large amounts of variations is what matters. Here they coined a term called domain randomization, where they intentionally randomize aspects of the image that don't particularly matter for the task that the model needs to perform, which is detect the cube and the pyramid and know exactly where the object is. It doesn't matter what the color is. You know when a cube is a cube. The overall conclusion here is that just using synthetic data was sufficient. This model was never trained using real data, and it performed the task that it was expected to perform on that table that you see on the right side. One more example that we're going to look at also in retail, which inspired the example that I showed you earlier. This is work done by Google Research, published last year, 2019, where they're interested in detecting retail, like supermarket type objects. Object detection implies you have to draw a bounding box. There might be multiple products in the image. And they trained that system using 100% synthetic data again. In this slide, I just show you the catalog that they recreated. So they bought 64 objects from a supermarket. They created 3D assets that represent those objects. And then they author an environment where they can randomly place this, much like I showed you earlier. In fact, that work that I showed you earlier was inspired by this particular paper. The overall conclusion here is that they actually were able to train a model that trained only on synthetic data performed better than the model that was trained using real data. To give you a concrete number, of course, all the details are in the paper. MAP, which is mean average precision, is a metric commonly used for object detection. When trained on synthetic data, was as high as 0.89. When trained on real data, it was about 0.76. So one of the things that you might be interested in learning more about is how do you get started? If you have a problem where you think some of these things that I've talked about are related to your task, how do you even get started using synthetic data? There might be cases where existing simulations exist. That such is the case of autonomous vehicle because it's a popular research area. So here we see two simulators side by side. On the left, you have the carless simulator created with Unreal Engine. On the right, you have the LG SVL simulator created using Unity. And in both cases, you have a car that drives around a scene and it supports multiple sensors and it generates, like you see, perfectly annotated data. In this case, semantic segmentation on the left, depth estimation on the right, and even 3D object detection. So in many cases, there is no simulation that you can use out of the box. So you need to author your own content. First, you need to start by creating the assets, like the supermarket products. Then, using a tool like SynthDet, which we released recently, you then can easily generate the labeled frames. You don't need to be a computer graphics expert to use this package and output labels for each of the frames that are captured during the simulation. This image shows the bounding boxes, which are useful for us humans to look at. Behind the scenes, what you actually generate are JSON files that contain perfect coordinates of each of the bounding boxes. Once you author your content, then you need to run the simulation to generate each of these frames. And you can do this locally to test that the labels that you're producing actually are consistent with what you expect. In most cases, you actually want to generate a large number of this because that's a key ingredient of many computer vision systems. And so you might do this on the cloud. In particular, there's a service that we maintain and develop precisely for this purpose, which is called Unity Simulation. So it's aware of what it takes to grab a Unity build and render in the cloud and produce all these frames and annotations. And the right side here, you see several images that were generated with the LG SVO autonomous vehicle simulator that I mentioned earlier. Finally, once you have your data set, it's clear that no human can look at 10,000, in some cases hundreds of thousands or even millions of images and give you a summary of the content that they just saw. So the key observation here is that you anyways need some tools to be able to perform some exploratory data analysis to confirm that the distribution of objects that you see in the dataset match your expectations and what you want the model to learn. Here I'm just showing two charts produced by an open source Python package we released recently that knows how to parse that data produced by the labelers and simulation, and then compute some statistics, like in this case, the distribution of object counts. So for every class in our retail catalog that I showed you earlier with all those products, how many times each of them show up in the image, or how many objects in this particular case show up in its individual frame. So you have some frames that have more images, some frames that have less images, and so on. And on the right side, what we see is actually a visualization of the different positions that the camera was placed on in the process of capturing all these frames. One thing that's interesting to highlight here is that in the real world, it would actually be very, very hard to get that kind of data of the camera position unless you're manually perfectly capturing the coordinates of the camera when you take images. So this is a sort of a side effect that because of the data set is synthetic, sometimes you can know even more than what you actually thought you needed. With that, hopefully that gives you an idea of the progress that have been made in the last 4 years in terms of using synthetic data set for computer vision, and you feel inspired to think of where this kind of research can help you in the problems that you're trying to solve. And I just want to thank you for your time.
Hi, everyone. I'm Andrea Renee, and welcome, Caesar, for some live Q&A. Thank you so much for that presentation, Caesar, and good to see you today.
Yeah, good to see you too.
So let's go ahead and just dive right in. So we have a couple questions already in the Q&A channel in Slack, but if you would like to ask another question, please make sure to post it there so I can see it. So the first question for you is, can an AI system trained on synthetic data be trusted to make real-world decisions?
I actually think that the answer to that question is independent on whether the data is synthetic. And you can make an argument that because you're generating the data when it's synthetic, you have a better understanding of that data set than the one that you're collecting in the wild. So any noise that is present in the data that is synthetic is deliberate. So you can control that, you can measure it, you can record it so you can analyze it once it's generated. But even if you can have a better understanding of the synthetic data set than the real one, I would argue that the answer to the question is less dependent on whether the data set is synthetic. And it's more about what was the process to create the data? How are you measuring what is appropriate or not appropriate? Like the definition of trust can get very blurry, but to answer the question, what you really want is an understanding of the process end to end, not just the task that the model is performing, but where the data came from and what are kind of all the sources, what are the distributions of the different aspects of the data set, what kind of model, how have you tested the model, what are the different performance metrics that might matter, what are sort of edge cases. So I don't think there's a simple short answer, but if you can trust one that is trained on real data, as long as you have an understanding of your synthetic data, which typically you have, then I don't see why not.
I think that's really interesting. And I do have some additional questions about that, but I want to make sure we get this other one in because it's kind of related. How far do the simulations that are used in synthetic data mimic human behavior?
So, not a lot. So what I've seen is, there's a couple of things where you could take this, but the shortest answer I can give you is that human behavior is quite tricky, very, very noisy, and it's not actually one of the aspects where I've seen the simulations shine yet. They're going to depend on a couple of things. So the behavior, there's the macro behavior of the crowds, for example, and there's a micro of individual animation of live streams. And both the macro and the micro can just be sort of handcrafted in the way that they are today in film and game. And so in that sense, they're not really mimicking. It's just based on human intuition and technical artists trying to translate that intuition into an animation. There is some early work that is more on the micro when it comes to the animation of the individual movements, where the animation is learned by trying to mimic a model behavior, but then because it learns how to apply physics to the rigid body to actually perform the motion, then it can react to changes in the environment so that it looks much more realistic than a video game animation. However, that would not solve the macro, which is more about the behavior of the crowds. And you do want to have some control of that. So if you were to do an experiment with that kind of human behavior of crowds in a synthetic dataset environment, what I would mention is that you probably want to have several, what some people might call hyperparameters, some others might call randomization parameters. So you can actually intentionally generate multiple simulations with different parameters that maybe affect how many people, or what's the distance between the people, what is the behavior, like do they try to avoid each other, do they try to go in groups? Because there's no right answer. Like all of these things that I just described could be observed in humans. And so what you actually want is just behavior in the simulation that has a whole bunch of variation so that your model doesn't overfit to a single thing. But most likely, knowing what we know today, even if you had perfect rendering of like light and pixels and everything and textures, I would expect an educated eye to be able to detect whether a crowd is behaving like a simulated crowd versus a real crowd. The cases where I've seen synthetic or model strength with synthetic data set perform the best are actually not the ones that are the wildest in the outdoors, are more like the ones that are in semi-controlled indoor environments and things like this, so that some inputs of noise that are completely out of control of the model are actually more constrained. Hopefully that makes sense.
I think that is fascinating. But unfortunately, we are out of time. I have so many questions now that I want to ask after that answer. But Cesar, thank you so much for your time today. And for everybody watching, he's going to continue to take your questions if you have additional ones for him in the offstage Q&A room. Again, thank you, Cesar, and enjoy the rest of your day.
Thank you.
And now it's time for our final discussion of VB Transform. I can't believe that we are already almost at the close of an amazing week here. And to kick off our final discussion is a topic on everybody's minds these days: data and COVID-19. Here to discuss how OHSU leveraged computer vision and IoT to help the battle against COVID-19, please welcome Dr. Matthias Merkel of Oregon Science and Health University, and Amit Fadnes, the Chief Digital Officer at GE Healthcare. This conversation will also be immediately followed by some Q&A. So if you have questions, please put them in the Q&A channel on Slack.
Hello, everybody. Good morning, good afternoon, good evening. Thank you for joining this session. My name is Amit Fadnes. I'm an officer at GE and the Chief Digital Officer for GE Healthcare. I want to start this off by basically saying, look, we're just going through some absolutely unprecedented times here in the US, but also globally because of the pandemic. We've really seen tremendous pressure on the health systems, and we've seen health systems responding almost heroically across the globe to sort of respond to this particular situation. And I think, overall, I would say we have been working very closely with OHSU here in the US. It has been a tremendous challenge for a company like GE Healthcare to sort of bring together technologies as well as clinical care pathways so that we can help our customers such as OHSU to be able to respond to the market. I have with me here Dr. Matthias Merkel. He's a pretty well-known name here in the US. He's a associate professor of anesthesiology, but he's also the chief medical officer responsible for the patient care pathways as well as capacity management. And I think these topics have been absolutely relevant, in the current context. He has really been at the forefront of your OHSU's response to the pandemic, and they have done a terrific job here, staying ahead of the curve in general in terms of the way they brought together technologies as well as solutions to be able to respond to this situation. I'm going to, hand it off to Dr. Merkel here to sort of, give us his perspectives on this whole scenario that is unfolding in front of us right now. Over to you, Dr. Merkel.
Thank you. Thanks for having me, and thanks for the nice introduction. I will go through a few slides showing our journey here at OHSU. As Amit said, I'm the Senior Associate Chief Medical Officer for Capacity Management and Patient Flow. I'm a trained anesthesiologist and intensivist, so COVID created a very busy world for me. If you look at this slide here, like on the left, I want to give you a little bit background, and the topic is really what I want to give you is technology is here to support us in the clinical world to make quicker, better decisions in the benefit of our patient care. On the left, you see how we managed high occupancy, high inpatient demand in October 2016. As you can see, this is on a whiteboard written. You can easily imagine that at the time we finished writing this, the plaque one, it was already differently. Like it shows you on the very left here, like how our critical care units looked like. It shows you how our ED was overloaded with boarders, how our women and children hospital looked like. And in the pink colored one, you see what we like, sort of the 7 points we came up to build this. Like, we should put our ED on ambulance divert. We should message that we are full. The most important part is number 3, because that's what we always settled on. Let's reconvene at 2:45 in the afternoon and see how it actually really turned out to be. And this happened to be our most common kind of intervention. Now going forward, 4 years later, I just took a screenshot of how we managed the same thing today. And this is a screenshot from June 4th, 2020 at 6:25 a.m. You will see that a lot of this is replicated, but now it's real-time data feed. It shows us how we do in adult acute care and critical care, and then you can drill down and you get really at the individual patient level almost data how we look like. It also shows you that on June 4th, our hospital, several units were already at 100% capacity, and this is at 6 in the morning. Okay, so this is at 6 in the morning, and it gives us real-time data tracking, and it makes our day much smoother. It shows us what is our demand is. It shows how we look around in the health system, and this is really critically important for us as we are a multi-hospital system, and we want to use everything to the maximum benefit of our patient care. Then as COVID hit out, it became very early, very clear, looking at other countries, looking at the East Coast in the United States, that this can rapidly overwhelm healthcare systems who, as I already showed you, are really full to start with. So this formed the idea here in Oregon that we should have what we have in our Mission Control Center for the entire state. And I'm really happy to report that we were able to put this together in from the concept of the idea to the first daters being able in less than 2 weeks and showing the entire state, 90% of our inpatient beds. And this is what on this busy slide deck, what it shows you is really the various region in our state and all the beds by if it's a critical care bed or a medicine telebed or a pediatric. It also on the bottom shows you the ventilators, how many are in use, how many are still available. So really giving you real-time data information. This is updated every 5 minutes. We didn't have this at the beginning of COVID. We now have this, and this really helps us to manage the demand substantially more. In addition, we kind of really increased the situational awareness. Like, again, this is really technology in support of us. This is a snapshot from last week showing our health system. It shows how many patients we currently have tested, how many are negative for COVID-19, the disease, how many are tested positive. And you can also see Oregon, we have been extremely fortunate that we had a very low prevalence and a very manageable amount of inpatient volume for that. What I want to highlight on the bottom of this, it shows you the tests over the course of the week. Again, technology helping us to predict how the next day will look like. So here on June 21st, this was a Sunday, we had 30 positive tests resulted, and this is a combination of inpatient and our ambulatory patients out of 309 patients. If you would scroll to the very left of this slide, you would show on beginning of June, we had more tests but had no positives. So it allows us to understand what is the demand over time on our health system. How do we operationalize that? This is kind of the active team. It shows you in our mission control, which is really the flight deck here. We have patient placement coordinator, we have nurses, that's the bad flow manager and the administrator on duty. We have also a physician 24/7 available to really manage the complex of a health system. There are team handoffs, meetings, huddles. We moved this during COVID all to electronic version, which was really eye-opening because we thought it's really important to be there in person. Some of this we now can do out of our home office. And it really allowed us to use this as the operational brain for our COVID-19 response in our health system. Having this in place before was really, really helpful. And then we moved into the next area, like here really like, so on the left, and this is kind of a sketch how we operate right now. On the left is our mission control and just highlighting some of the critical function there, which incorporates a transfer center, which managed all the patient coming into our health system out of the state and neighbor regions. And we also have established a virtual ICU, which we are building up as we speak to have physician, nurses, respiratory therapists, pharmacists sitting in there, having remote access to patients. If you go to the right side of the slide, it really shows you on the top, the mission control for the state. That's the statewide tile. It's a snapshot of the map in Oregon and how these regions, which we follow in our trauma system, are kind of organized. Each of them has a core hospital and manage their own demand, and then they go to the region 1, which has the quaternary care center, like Oregon Health and Science University. On the bottom, you see sort of this network out of the virtual ICU providing services to hospitals in the community who, in the face of COVID, realized very quickly that if we can send this patient via helicopter or fixed wing to the main hospitals in the Portland metro area, we will need to treat patients at outside our comfort level. And having access to the expertise via a virtual platform really kind of facilitate that. And this is all kind of anchored in a data dome within our university system, and allows us to really quickly kind of establish that. And for us, this was really like being able to pull this together from what we built over many years in our own health system to offer it to the state was a critical piece in feeling comfortable that the ethical discussion about running out of ventilators and bed resources will be pushed further out and hopefully never happens in our state, because we can manage this very systematically with these platforms, and really highlighting to bring smart clinicians and care teams together by a technology platform who helps us to fulfill that. The last one, and I hope it's not too graphic for other people, like the virtual ICU is really something which helps us. This is a COVID patient going on extracorporeal membrane oxygenation, life support. This is essentially like a heart-lung machine, which we can deploy in the ICUs when your lungs not working, if COVID damaged them too much and you need acutely arrest the lungs. And this allows us to have a minimal amount of team members in the room and have support staff outside visualizing it, supporting them in a very effective way. And being able to deploy this, what we thought would be a multi-year project within weeks, was eye-opening for us and really required a village to move that.
And actually, you touched upon several themes there, but I would say, what we have heard consistently on our side, talking to a number of health systems across the US and across the globe, is this theme that you touched upon towards the end, which is, a lot of CEOs have said that, look, we have had to respond, to the pandemic, and have made changes to the systems in matter of weeks that would have typically taken years in normal course. In many cases, we've heard that the online consults have gone up from something like 4 or 5 or 10 or 15 in a day to 2,500, 3,000. And in your case, things have been particularly complex because you're a distributed, health system with 64 clinics across the state. Some of the solutions that you showed, it looks like data has been the foundation, on which you've sort of progressively built, some of these solutions that have come in very handy. I'm actually a technologist. I joined GE Healthcare about 3.5 years back. Before joining G Healthcare, I was not a healthcare professional. And for me, what has been most interesting is the ability to bring together data, connectivity technologies, and clinical knowledge to be able to sort of put together these type of solutions which can truly help in scenarios like this. What would be your advice to the technology community in general? Given your experiences and truly what you've done here, is ahead of the curve with the rest of the industry in many ways. In a way that you have been able to very, very quickly put together solutions and deploy them for patient care. What would you advise the technology community overall as to how we could help you better going forward?
Yeah, that's a very good question. So I would say I would start with make sure that the clinician understands that they should tell you the problem so that you can go back to the drawing board and develop a solution. Like the clinicians need to focus on what do we really want? What is helpful? What makes my life easier so I can focus more for my individual patient and ultimately take care of more patients, locally or remotely. And then use the engineering power and software engineering brain and technology to really develop solutions and then partner with clinicians to really work out what of this works, what of this doesn't work. I think that is the biggest learning for me over the years is like, as much as I try to tell a software engineer how to fix a problem, it's totally ill-equipped. But once I tell them and kind of invite them into the clinical environment and say, come with me, walk in my shoes for a day, that has eye-opened in many areas and has really been like, I think the acknowledgement that the important part is to connect teams and the right teams together, and the technology needs to be the foundation in the background supporting this. And that kind of increases the adoption rate, it increases the satisfaction, and ultimately allows all of us to do our job better.
No, absolutely. And I think, Dr. Muckle, this is where we have valued the relationship between G Healthcare and OHSU here. These are exactly the type of inputs that we have got as we sort of built out the solutions along with you. That a couple of them that we just saw. In the past 2-3 months, we've seen a number of health systems, and actually, again, OHSU has been a benchmark in this, who have made the transition from sort of physical care to virtual care. Okay. And it seems to have swung the pendulum so rapidly in a particular direction from a virtual care perspective, given the need to sort of protect, healthcare workers as well as to protect patients from a social distancing perspective. How do you see this scenario as the COVID scenario hopefully settles down in the next few months? Do you think that the pendulum is going to swing all the way back, or do you think that we are looking at a new normal here in terms of how care pathways are executed in general in future?
I hope it doesn't swing back. Like, I think we need to find what is the right way forward. What of this is helpful, really adding value to our patients, to our care teams, like, when you talk about well-being, work-life balance, all of this is important for the patients, important for anyone in technology, and certainly in healthcare. And I think learning what is the best practice around this, where is this the right thing, where we don't have to fly a long distance or the patient need to drive long hours to get disrupted from their social care environment because we have technology enabling us to provide the same care in their familiar environment. We need to learn. We need to continue to advance this. I think this is just the beginning of the journey, and like, our imagination will be the limit for that. And like, if we don't take lessons learned out of this, the fact that we were able to pull this together, the fact that we can have an effective conference via this video conferencing, like, we would not have accepted this 6 months ago. And now this is what we do. And like, it saves us time, it gives us more energy, it gives us much more potential, having audience around the entire world. Like, the knowledge sharing we had from around the world around like, hey, COVID-19 looks like this. This is what you need to be prepared. Like, I have never experienced this before. And like, I think we need to take learning out of this so that we don't repeat errors in the past, from the past in the future, and really get more effective around that. And at the end, the most important thing is that allowing us to take better care of our patients and their family and ourselves in all of this. We are all in this together.
Absolutely, Dr. Merkel. In fact, this is a theme that we have seen, repeating quite a bit with every conversation that we have had with the health systems. In fact, most of the health systems have said that they're able to do 80% of the care pathway remotely, and that number used to be much smaller. And they really don't see this pendulum sort of swinging back all the way. But Dr. Merkel, there are many themes that you touched upon today, which are extremely important. But I think, I would say our ability to sort of work with the data and ability to sort of work, get the blend of technology and the latest technologies that are available, but most importantly, blend it with the clinical knowledge and the input from the clinical side, so that we truly understand the workflows that the clinicians want to execute and be able to implement those workflows quickly using the data analytics and the application frameworks, has a true potential to sort of change the way we deliver care to the patients, as well as we protect the healthcare workers in future. And I think that that's truly trend setting. So while the pandemic has been really, really challenging, I'm hoping that this sort of swings the pendulum in a direction that is going to be beneficial to everybody, to the patients, to the caregivers, clinicians at large overall. And I think that's the challenge in front of the technology industry, right? How do we partner with you in a way that we can actually really make this happen in reality? With that, I want to thank everyone. Dr. Merkel, if you want to make any last statements, please go ahead.
Yeah, thank you. Thanks for this opportunity. And I think the most critical part is here using the technology to combine the power of the right team. Like in healthcare, this is nurses, physicians, all healthcare professions and healthcare workers working together with the healthcare administration to really solve the problem. We are here for taking the best possible care to our patients. And I think that was something we saw at a very impressive way, and it created a new appreciation for all of us what this means and can mean. Thank you.
Thank you. Hello, Dr. Merkel. Thank you so much for that session. There are a few questions here that I wanted to sort of go through. We talked a lot about the importance of data and our ability to sort of collect the data in real time. As you do that through the health system, are you able to sort of use that data for research purposes? Are you able to sort of feed that data to the research teams? Working on understanding the COVID scenario overall, and even developing vaccinations.
Yeah, it's a very good question. So the data we share like statewide across the hospital, we have all agreed on to use this for real-time management of our state sort of as one kind of hospital system. There is potential for research, but in the midst of a disaster pandemic, we kind of limited our agreements to what we want to do acutely. None of this is geared towards vaccination development. That's a different kind of branch when you think of this in medicine. But other data outside of COVID, and also our response of kind of modeling, what is the demand, how much increase in patients over time do we have, that is what we're actively using in our health system, so that we can serve both the COVID and the non-COVID patient population, and essentially accepting that we always will have a full hospital, but like it's different if we need 1% of our beds for COVID or if we need 20% of COVID, but we do not want to go back to reserve everything for COVID, because that is obviously was a crisis intervention early on, and moving forward, learning to live with COVID is a different spiel.
Thank you. Yeah, that's great. Actually, there is another question, which is also a very important question in the field of medicine and healthcare in general, which is about AI. And I think the gist of the question is, what happens when AI goes wrong? How do we take care of, the liabilities around it? just in terms of workflow, and when you use AI in the workflow, what if AI is wrong?
Yeah, I think that is a big unsolved question in medicine, where we have to really get behind what is the QA for that kind of purpose. Right now, I think a lot of these are decision support systems who then overlay a physician and a nurse, which I think is good and bad at the same time, like, because we need to kind of advance this, and we need to develop what this means. I think a lot of scientific journals are kind of scratching their head how to really do peer review of these algorithms, which is difficult to comprehend and to replicate. And I think this is a journey we all need to partner and develop what is the right thing. But done right, I think we have good use example that artificial intelligence is super helpful in this ever increasing complexity and knowledge increase, especially in medicine.
Yes, and I think just to recap that, I mean, this is a question that's always asked, and it's a big debate, as you said, Dr. Merkel, within the healthcare community. But essentially, the way we use AI today is really in an assist mode rather than it being the final, point of decision. It's the physician, the clinician, the radiologist, the surgeon who finally has a say, in determining what the course of action should be specifically. And AI, in the workflow, in almost all the cases that I've come across, is really an assist mechanism. It's a decision support system. It's not really a decision system on its own. And I think that's a very important distinction as we go through this particular process. Well, I know that we had a very short time on this one, but I really want to thank you, Dr. Merkel, for your views on the session today. Thanks a lot.
Absolutely. Thanks for having me.
Well, thank you so much to Dr. Merkel and Amit for that incredible conversation about some incredible work that's being done in the field around COVID-19. If you have follow-up questions for either of them, you can join our speakers in the offstage Q&A room as always. And I think that's going to do it for our panels here today at VB Transform. I did want to catch you guys up on one little announcement. As you know, we had a drawing for folks who attended more than 5 of the virtual booths here this week. We will be announcing the winner on Monday, so keep an eye out for that. And did I mention that the winner is going to receive $1,000 and 2 complimentary tickets to our next Transform event? Pretty cool. And keep your fingers crossed, it just might be you. You have to wait until Monday to find out. But I do hope that everybody enjoyed visiting the expo booths from all of the partners here at VB Transform this week. All right, so now that we are finished with our panels and fireside chats and presentations for the day, it's time to transition over for our final event of the week, the Women in AI Awards. And for those of you who are just joining us or tuning in just for the Women in AI Awards, I'll give myself another little introduction. I'm Andrea Renee, in case you missed it earlier today. I am the co-founder of What's Good Games, a video games and tech media company, and of course, one of your MCs during VentureBeat Transform 2020. I would like to welcome you to the 2nd annual Women in AI Awards. We're excited to kick things off with our program highlighting some of the work happening by women in the field of AI. And now it is my pleasure to introduce you to VentureBeat's Vice President of Strategic Partnerships and co-founder of VB Lab, Gina Joseph, to say a few words.
Thank you, Andrea. It is my honor to be here today live as we announce the winners for the Women in AI Awards. Having a diverse background and being a woman in leadership, working closely with global tech companies that are leveraging artificial intelligence, I'm thrilled to be here today to support and recognize the growing role of women leaders in AI. As the leading publication in AI news, our job and calling at VentureBeat is to educate and inform people about transformative technologies that impact business, society, and the world, and to help build up a community of practitioners, scholars, and leaders around AI. And there's no doubt, about the incredibly important role of women in artificial intelligence. The future of AI means embedding ethics, diversity, and inclusion in the heart of our organizations and within the AI systems they create and deploy. Closing the gender gap is pivotal. VentureBeat's Women in AI Awards aim to honor extraordinary women thinkers, leaders, and innovators in AI. Today, we are recognizing women who have made outstanding contributions in 5 areas: responsibility and ethics in AI, AI entrepreneurship, AI research, AI mentorship, and rising star.
Thank you for that introduction, Gina, and good to see you. I know we haven't really gotten a chance to meet virtually, but it's lovely to be sharing a stage with you. And also a thank you to our Women in Tech partners for their outreach for Women in AI nominations. We have received a total of 233 nominations for Women in AI Awards this year for 120 amazing nominees across 5 categories. Those categories, as Gina just mentioned, were AI entrepreneurship, which we had 34 nominees for, AI mentorship, which we got 14 nominees for, research, 20 nominees, responsibility and ethics with 22 nominees, and rising star with 31 nominees. If you'd like to see a complete list of all of the nominees for the awards this year, please visit our website at vbtransform.com, and you're going to want to use the /Women in AI breakfast.
So much of the growth around AI comes from research and development, but many savvy entrepreneurs have successfully taken AI out of the lab and into the real world, building businesses atop this cutting-edge technology.
The finalists for Excellence in AI Entrepreneurs Awards are Sofia Elizondo, the co-founder and COO of Brightseed. Sofia and her team are pioneers in using AI to map compounds in food to transform food into a new paradigm of food as medicine. Dr. Ying Zhang, co-founder and CTO of iFi Inc. Zhang is committed to changing the world of retail to make it more accessible and an inclusive place. Michelle Romano, co-founder and president of ClearBank. ClearBank's model has eliminated bias from the decision-making process, and as a result, Michelle and her team have funded 8 times more women-led companies than any other VC. Daniela Braga, CEO and founder of Defined Crowd. Defined Crowd offers one of the highest-paying crowdsourcing platforms to the workers, driving their efforts towards a fair payment while also ensuring the highest quality of the data provided to the clients. Manasi Vartek, founder and CEO of Verda AI. Manasi has contributed an extensive amount of open source community. She's built and shared ModelDB, a system to manage ML models. ModelDB is still widely used and available to the community at no cost. And Rebecca Clyde, the co-founder and CEO of Botco.ai Inc. At the outset of COVID-19, under Rebecca's leadership, Botco.ai made its AI software available for free to businesses impacted by COVID-19. This solution has helped businesses instantly communicate the status of business operations to customers in a timely fashion.
And the first award for the AI entrepreneurship goes to Michelle Romano, co-founder and president of ClearBank. Congratulations, Michelle.
Thank you, VentureBeat, for this incredible award about women in AI. The peers that I was nominated alongside are so inspiring. So this is, just so humbling to be recognized. We started ClearBank because I had bootstrapped 4 different companies, and I totally appreciated that it was incredibly difficult to raise capital, especially when you weren't from exactly the right circles or had gone to the right schools. And so we had this crazy idea 5 years ago that we could automate that process with AI, that companies could give us their data, and then we could tell them if they qualify for capital in 20 minutes or less. And everyone thought we were crazy. But today we've invested over $1 billion in 2,800 different e-commerce companies. And so we've clearly shown that the model is able to work. And moreover, that AI has been a transformation for good. One of the things that I'm deeply proud of is that we've backed 8 times more women than the venture capital industry average. That's not because we're doing anything differently on the top of the funnel. We're just letting data make investing decisions as opposed to humans. And then we've backed founders in every state, all 50 states in America. And this compares to 80% of venture capital dollars last year went into 4 different states in America. And so we really believe that anyone with a great idea should be able to get capital to grow their business. And I'm just incredibly optimistic at the way that AI can take the bias out of things, and we are just getting started. So thank you so much for this award.
And the second award for AI entrepreneurship goes to Sofia Elizondo, co-founder and COO of Brightseed. Congratulations, Sophia.
Thank you, VentureBeat, for this award in AI. On behalf of the entire Brightseed team, we're delighted. We're entering a new era of natural discovery and precision nutrition. And Forager, Brightseed's AI, is uncovering the molecular connections between plants and human health and wellness. In partnership with others, we are discovering phytonutrients that are present in our foods, in our supply chains, and in our waste streams. And together we'll transform the future of agriculture, food, and health. Thanks again.
The research lab is where the AI of tomorrow is being tested, developed, and described. The hard work done by researchers in public and private institutions fuels the next wave of transformative AI technology, drives thought leadership, and challenges the status quo.
The finalists for this year's AI Research Award are, now I probably should have made the disclaimer at the beginning that I apologize in advance if I mispronounce any of your names. First up, we have Georgia Giuzzari, research scientist for Facebook AI, for her work in creating an open source code base for 3D deep learning called PyTorch 3D and pushing 3D deep learning research forward. Anima Anand Kumar, Director of ML Research at NVIDIA, Ben Prof, and the Director of ML Research at the California Institute of Technology, for her visionary work on tensors and advanced next-generation AI that will have lasting impact in the coming decades. Our next nominee is Yulia Sanz-Murskaya, Application Research Lead for Neuromorphic Computing Lab at Intel Labs, for her applications research in Intel's Neuromorphic Computing Lab and Cognitive Robotics Group to target a range of solutions regarding perception, cognition, learning, motor control, and more. And our last nominee is Tanya de Gasperis, research and facilitator for Montreal AI Ethics Institute, for her commitment to the field of AI research and dedication to exploring the futures of responsible and inclusive AI.
And the AI Research Award goes to Anima Anand Kumar, Director of ML Research at NVIDIA and Bren Professor at California Institute of Technology. Congratulations, Anima.
Thank you, VentureBeat, for giving me this award and for recognizing women in AI. I'm really thankful to my mentors, my colleagues, my collaborators, and my students for being part of this journey with me and for being such an incredible source of support. Thank you.
It's become clearer than ever that focusing on responsibility and ethics in AI is not just the right thing to do. It's a foundational prerequisite for any AI project or deployment. Practitioners must curb potential biases in their hard work and understand what they make has real-world implications for how it benefits people or potentially harms them.
The finalists for this year's Responsibility and Ethics and AI Award are Lama Nachman, Intel Fellow, Director of Anticipatory Computing Lab at Intel, for her work leading an effort across Intel to put together a framework for ethical assessment of AI projects, addressing bias, transparency, privacy, and more broadly human rights concerns. Mary Hickok, founder of Athletics.org. Through her platform, she provides a global repository of AI bias and fairness research, guidelines, framework, legislation, national strategies that any researcher or advocate can use as a first stop site. Carly Eckert, the Senior Medical Director for Kensai, for demonstrating tremendous leadership towards making AI fair and ethical across age, race, gender, and other protected attributes by contributing to this field both as a researcher as well as an industry practitioner. Anima Anand Kumar, the Director of ML Research at NVIDIA, for takes on large organizations to get them to stop selling data to the government. And Bina Amanath, a Managing Director at Deloitte Consulting, for developing Deloitte's ethical AI framework to help safeguard ethics and build a trustworthy AI strategy.
And the Responsibility and Ethic Award goes to Carly Eckert, Senior Medical Director, Kensai. Congratulations, Carly.
It is such an honor to receive this award. Thank you to the folks at VentureBeat for providing the opportunity to recognize and to celebrate the achievements of women in AI. The many women nominated here across categories have achieved amazing feats in their respective fields, and I'm truly humbled to have been nominated among them. Thank you to my coworkers at Kensai, who have given me the best job I could imagine, working with them daily to augment the intelligence of medicine with AI. We all know the power of algorithms, but we must approach the development, the implementation, and the use of these tools with thorough questioning and critique, always. It is up to each of us to create and to demand models exhibiting parity, promoting equity, and demonstrating algorithmic accountability. We are all chartered to do this work. Thank you.
Whether it's in the boardroom, the lab, or the classroom, these women are investing their time, energy, and expertise to build up the next generation of successful women in AI.
The power of mentorship simply cannot be overstated, particularly in STEM fields where the leadership from women is still woefully behind their male counterparts. The finalists for this year's AI Mentorship Award are Kalpana Diwakaran, Head of Studios for AI and Analytics at Cognizant, for her work in coordinating college graduate hires from the mentorship program and training them in emerging technologies, providing them with a competitive edge to thrive in a disruptive era. Tina Tang, the Head of Global Innovation, Marketing Strategy and GTM at Ernst & Young, for her dedication to hosting one of the largest LinkedIn groups, Women in Big Data. Meeta Dash, the VP of Product at Appen, for teaching Audacity courses that share real-world learnings so women in underrepresented groups can feel more comfortable to join the AI product space. Her courses include AI product management interview preparation, and a day in the life of a product manager owning AI and data products. And Erica Lee, Director of Machine Learning Engineering and Software Development at Zillow, for making ML education and working opportunities available via womenofai.org, a 10,000 plus strong group that she founded, and for launching the womenofai.org ambassador program to grow the global influence of diversity in AI.
And the AI Mentorship Award goes to Meeta Dash, VP of Product at Appen. Congratulations, Meeta.
Hi, everyone. It's a great honor to receive this award, and this means a lot to me. Thank you, VentureBeat, for acknowledging my efforts. I also want to thank all of you who helped put this initiative together and to encourage more women to join the AI industry. Now, AI can really drive a lot of change, and we do have a unique opportunity to move the needle for diversity and bias in AI products that we are building. And I believe machines are like infants who can be molded to understand what we teach them. So it's our responsibility to train them well so they can understand and empathize with people from different genders, from different race, culture, and background. That means we also need to hire people of diverse backgrounds who are the builders and trainers of these smart machines. So diversity in the workforce becomes even more critical in this context. Being a first-generation immigrant, a mother of two, a person of color, and someone who had to constantly fight the disadvantages of career challenges, being listed as a leader by VentureBeat is literally a dream come true. So efforts like this will really help us with this cause, and kudos to everyone who are driving this change forward, and thank you so much for the acknowledgement.
Just as we honor the up-and-coming women in AI, so too do we recognize those women who are establishing themselves as leaders and innovators in the field.
The nominees for this year's Rising Star Award are Karen Tan, AI Strategy Manager at Accenture, for her work in explainable and responsible AI, subject matter expertise and influence in government policy for her support of diversity and inclusion. Jackie Schaefer, founder and CEO at ClearBrief.ai, for her cutting-edge work to improve the child welfare system and justice system, focusing on where government meets AI for the benefit of children and families. Akriti Sirkranth, Business Development at NeoTribe, for her incredible advocacy work for women and minorities in AI. And Kate Callett, Director of AI and ML Ecosystem and Developer Relations for ARM, for her steadfast work to promote diversity and inclusion and social innovation and societal benefit, launching ARM's first ever data science competition in Africa.
And the Rising Star Award goes to Kate Callett, Director of AI and ML at ARM. Congratulations, Kate.
Hi, everyone. What a true honor to be recognized here. Thank you very much. I'm truly humbled to have even been nominated alongside these trailblazing women leaders in AI who don't hesitate 1 second to challenge the status quo with regard to diversity, inclusion, and representation in our field. As all of us work towards building the future of AI and pushing the boundaries of what's possible with technology, we need to think about how to do it by and for all women, all people, but also all around the world, and really enable the technology we work with to better serve society and increase equality. We need to think about how we enable the next generation of AI leaders, not just around us, but all around the world. I have been and I am still inspired and motivated today by Black leaders across the industry, but I've also come to realize that you can't be what you can't see. We all have a role to play here, so what are you going to do? Hire more diversity? Yes, but I also believe that it starts even before that. We have to encourage and mentor new generations, younger generations, to pursue STEM studies and to get into technology. Ultimately, leveraging diversity allows us to drive technical innovation that is truly reflective of our diverse society. Let's not forget that technology is a reflection of the people who build it. In that sense, diversity in tech becomes a necessity, not a luxury. Thank you very much again.
Thank you to all the incredible women leaders nominated and for what you do. These awards are important to reward and recognize women who are doing such meaningful work in AI. Artificial intelligence is changing our world, and it is our responsibility to make sure it's for the better. Congratulations again to all the nominees and winners.
Thank you so much, Gina, and thank you to everyone who submitted nominations for this year's awards. Again, if you'd like to see a complete list of all of our talented nominees pushing the boundaries of AI, you can go to vbtransform.com. And now, one last time, I would like to pass the virtual mic to CEO and founder of VentureBeat, Matt Marshall, for some final remarks before our closing reception.
What a great show over the last 3 days. As mentioned in my opening, at VentureBeat, we're aiming to create a new sort of town square for enterprise decision makers to learn about transformative technology and to transact. And transform is one way we're trying to do that. And thank you all for being part of that. My biggest thank you, of course, is to our sponsors, without whom we could not have done this. This move to a virtual world is new, and they supported us in that. A huge thank you to Dataiku, Intel, Capital One, NVIDIA, Modzy, Cloudera, Data, Two Hat Security, Dell Technologies, Inference Solutions, Anaconda, Conversica, Sambanova, Xilinx, Globant, Appen, Cognicore, Fiddler AI, Percepti Labs, and Vision Elements. Many of those sponsors generated amazing content, as you saw themselves, that made the event what it is. Thank you to our media partners, ODSC, Tyro Labs, AI Agents, and also to our Women in AI partners, There's a list of folks, but Intel and Capital One anchored this initiative, as well as our Expo partners, a big list, too many to call out now, but thank you all, and our advisors. It's a list here of the folks who we've reached out to for advice on how to put the agenda together and have given us some really good feedback. Thank you. To our strategic event partner, the folks who you probably haven't seen behind the scenes, I'd just like to give a shout out to Evergreen Creative, who helped on the back end with production and AV. And finally, and importantly, not last but not least, the whole team at VentureBeat, who worked so hard on this. I won't list all of their names, there's too many, but you know who you are. And do want to give a special call out to Lauren O'Brien, our Chief Operating Officer, who worked tirelessly for weeks and months on this and showed such great leadership. As for my own impressions, I thought it was an amazing digital event delivery, but we also want and need feedback. Please do let us know how we did by filling out a short survey that we will be sending to you right now in our Slack channels and very shortly in a follow-up email. Here are my thoughts on the actual content. There's too much really that was newsworthy and noteworthy to list all here. We've posted a lot of it on our site. But one of the most moving moments for me was the Diversity Inclusion Roundtable yesterday morning, where 5 African Americans discussed what needs to be done in AI. Conversation was riveting. I think William Griffin, Chief Ethics Officer from Hypergiant, hit it home the hardest. The tech industry has gotten so powerful, in part by wielding this technology of AI. And yet computer science hasn't developed a code of ethics, a clear one that's united, that everyone agrees to. Like physicians and lawyers who developed ethics codes centuries ago. Without that ethics code, revenue growth and speed has taken over as the primary driver a lot of the time. And so you get mantras like move fast and break things, or fail fast, which were popular at big companies in the Valley, but that is now impacting lives and disadvantaging underrepresented people. Moderator Crystal Mohan, in her report back on that roundtable, concluded this doesn't work anymore. It has been delegitimized. The Woman in AI breakfast Wednesday morning was equally as strong and worked a similar thread. Because of AI's power, it can't be seen only as a technical profession based on computer science. It has to bring in social science and be multidisciplinary. It can't consider just data and revenue. It has to consider impact on people. So a woman like Tinmeet Gebru and Francesca Rossi and others led that discussion, and Tinmeet won our AI for Good award during our AI award ceremony the first evening. A special congratulations to Tinmeet and her work. Finally, our intimate executive roundtable sessions for VIPs were also big for me personally, since they allowed me to be at the table with real industry leaders, talking in private about the big issues on their minds. So we want to keep building this town square and would love to have you join us. A couple of other reminders on that front. We have our upcoming vertical events on Transform and AI. If you'd like more information on our events on health, retail, finance, or industrial manufacturing, which is coming later in the next year, go to our vbtransform.com website, and you will be directed from there. If you're interested in partnering with us as a sponsor, now's a great time to get involved. Email us at events@venturebeat.com. And finally, remember, VentureBeat is the leading news source on AI. Join our newsletter or visit our site for ongoing coverage of leading AI news stories. Thank you, and hope to see you soon.
you.